Ehi prova test. Ehi prova 1, 2, 3. Ehi prova test sa. Ehi, 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 ehi.
till we can't feel our feet, then go and lay down somewhere nice to watch that sunset settling under the streets that hang with the locals. Get a whole lot local with everyone that we meet. So pack the bags, we're going on a road trip, just you and I all weekend to have a good time. Well, there's a full tank of gasoline and our favorite playlist full of hits. So let's push play, put it in drive and road trip. Well, there's nothing better than 48 hours, wide lines and what's ahead. The perfect sidekick, my co-pilot, this is as good as it gets. Seeing the world with the wind in our hair, no place we gotta go. Got the speakers on 10, a 2-day weekend, you and I in the open roads. So pack the bags, we're going on a road trip, just you and I all weekend to have a good time. Well, there's a full tank of gasoline and our favorite playlist full of hits. So let's push play, put it in drive and road trip. So let's push play, put it in drive and road trip. So let's push play, put it in drive and road trip.
Look into my eyes, look into my eyes. Doesn't matter if they're blue, green, brown, they flash like fire. Colors of the earth, colors of the earth. Take your flag and stick it where you like, I'm reaching higher. Oh darling, and if you think the planet's grip can hold me back, I am a rocket, there's no way you could stop me if you tried. I never felt so free as I do right now, no way that I'm ever coming down. I'm on my way to leave the atmosphere, it's all coming clear. Say your au revoir, baby, I was made for the stars. Listen to my voice, listen to my voice. Coming at you like a lion's roar, I won't go quietly. Take a picture now, take a picture now. Go on, point the Hubble at me, don't lose sight, I'm high society. Oh honey, if you believe in gravity, just watch and learn. I am a rocket, there's no way you could stop me if you tried. I never felt so free as I do right now, no way
sunshine down on the goodness of each other. Constantly in awe and wonder of all the little things that make up the magic between us. Seeing you again is a welcome sign. 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 Seeing you again, seeing you again is a welcome sign. Is a welcome sign. Seeing you again, seeing you again is a welcome sign. Is a welcome sign. A welcome sign.
Ma quindi, perché vorresti venire a lavorare in B-Sharp? Cloud. Ho sempre sognato di lavorare sul cloud.
La sensazione da subito è stata proprio quella di avere dei colleghi in più, che erano più senior di noi e che ci potevano dire tante cose interessanti.
Tante persone che si sono rese disponibili, ci hanno aiutato, hanno tradotto le nostre idee in tecnologia in primis, ma soprattutto in step di avanzamento, e quindi da un'idea è diventato un progetto.
Sono partner di AWS e quindi sono bravissimi.
Ho come la sensazione di aver dimenticato qualcosa.
Se l'hai dimenticato, allora non era importante.
Hanno tutte le certificazioni che servono, e questo che cosa vuol dire? Che per esempio per noi come startup si occupano di tutta la parte di infrastruttura, noi non ce ne dobbiamo occupare.
Quali obiettivi? Ne avevamo troppi. Avevamo proprio una visione di startup in cui ok, non ci sono competitor, ok, non ci sono realtà che possono fare quello che facciamo noi, ok, noi siamo più belli, quindi lo faremo meglio di tutti.
Posso dire, chi non è qualsiasi. Momento. Pronto?
Riuscite a capire le esigenze e poi a tradurle effettivamente in risoluzioni di problemi.
Welcome to these serverless days. How is going? Okay. How was the breakfast? And the coffee? Okay, that's fine. So, welcome to everyone. It's really a great pleasure to have you here today. It's a double pleasure because until 3 months ago, we weren't decided if to have this conference or not this year. So thanks to our great team, we managed it, we did it, and we are fully packed today. We are sold out. We have a lot of people, a lot of sessions today. So thank you very much for joining us. Thank you very much for responding. Thank you to everyone. Just let's begin. Let's start from the beginning. What is Serverless Days? Serverless Days is a joint effort of many community people all around the globe. It started a few years ago, and then it became a global event. A lot of people decided to bring global conferences, global international speakers to local events in order to allow everyone, everywhere, to have a top-tier conference just around them, just close to them, with a very low price ticket. And we did it. In the last few years, we hosted almost 50 serverless days all around the globe, starting from Australia to Canada to Europe, many places in Europe. And everything began in 2017. Thanks to Ant Stanley. Hello, Ant. Thank you. And a couple of friends, we decided to join them and to start the very first JeffConf. It wasn't named serverless. Serverless name came later. The idea was these new technologies about how to handle application, how to handle workloads without the hassle of being forced to manage infrastructure, to manage servers, to manage databases, to manage all the operational stuff, but just focusing on the business logic of your application, just focusing on what brings value to your customer, to your customers. This idea was so disrupting that everyone was talking about serverless. Just pretty like everyone is talking about AI today. So AI is the new serverless. And the idea was, okay, we can host a conference, we can name the conference basically whatever we want. Why don't name the conference, say, Jeff? And then we started with JeffConf in 2017. We hosted JeffConf London, then we hosted JeffConf Milano. And it was a rush. We decided to join the conference, to join the team at the end of July, and we delivered the conference at the end of September. Then, 1 year after, we decided to level up the conference, and we hosted one of the biggest events in number of participants, number of attendees that we ever had globally. It was 2018, and we have Jan as our keynote speaker at that event, and we also had robotic arms serving beers during the happy hour of the event. And we delivered 300 beer in just less than 1 hour. Then in 2019, we came back, and it was a great event. We leveled up with local speakers that joined international speakers. So Serverless Days started to evolve, started to become a different conference, more mixed between local engineers, local speakers, and international speakers. It became a networking event. It became a place where you can meet people that run very huge workloads, people that are top-tier professionals in the serverless domain all around the globe, just walking into a hotel room or a conference room in the city close to you. Then in 2020, the pandemic came, and we decided to move the conference completely online. We hosted Serverless Days Remote, and we hosted 2 different Serverless Days Remote chapters all around the year. Then we came back in 2023. And last year, it was a huge conference. Last year, it was hosted here. It was hosted in June. Then we decided, we were a bit doubtful about what to do, since serverless as a concept, as a pattern, was evolving. And we were a bit decided, okay, should we host Serverless Days in the coming years or not? And our choice was yes. Yes, we are coming back this year, and we are working with other teams all around Europe and all around the world, even in the US, even in Australia, even in the Middle East, to kickstart new Serverless Days chapters. Because Serverless Days now means everything that is a modern workload, everything that can remove the effort or reduce the effort of managing infrastructures. And when you are dealing with AI, when you are dealing with LLM, so I'm named AI even today, when you are dealing with agents, managing the infrastructure, managing the databases, the persistence is definitely a huge issue. And we have a lot of technologies. And one thing that meant that serverless became mainstream is that in 2017, we had just 1 or 2 main players bringing the idea of serverless. Actually, we have a huge number of players, not only public cloud vendors, but a lot of local, a lot of small players, a lot of medium-sized players, a lot of hyperscale players. They are bringing the idea of managed databases, of managed workloads, of managed AI. But this couldn't be possible without our sponsors. So I want to thank you, and I encourage you to thank our sponsors, Eleva, B#, and AWS, for making this possible. By making this possible, we mean that Even this year, even today, we managed to have a very low ticket price thanks to our sponsors, basically covering all the expenses of such kind of a conference. And I want to give a shout out to our sponsors. Then this year, we have a big news. We have been joined by Overnet in helping us to manage the conference, to manage all the stuff that belongs to a conference. And if you can see, all the leaflets, all the website, all the stuff, or even the app, and Pamela is going to tell you a bit more about that, is thanks to our collaboration with Overnet. And then a big shout out to our community partners that pushed the news, that helped us to reach out as many people as possible. But the second group of people I want to thank you is our speakers. Because this conference, this astonishing day, it is made possible by an impressive lineup of speakers. By people that choose to come here today and to deliver great talks about what they do, about their experience, about the issues that they have faced and how they have solved them. So I want to thank to our speakers. And a personal note, I want to thank all the organizers of this event. This year is more true than ever that Serverless Days is a joint effort of a number of people. Every one of us, every one of the folks that you can see with a red t-shirt, with a fancy Unicode today, has a daytime job. So organizing this conference is not our job. We do that in our spare time, and it couldn't have been possible without the joint effort of a great team of people that gets you covered every time that you don't have the time, every time that you have family issues, every time that you have some work deadline that you have to match. So I want to shout out to the organizer, and they really did a great job. And now I'm passing to Pamela.
Hi everyone, I'm just going to give you some details about how we're going to spend our day together. Like, I guess everybody has enjoyed breakfast. We're going to have another break around 11:15, lunch at 14, and then another break at 4:10. And then, of course, there's going to be serverless espresso. Who has tried serverless espresso already? Not everyone. Anyways, it's a very
Shame
fun...
on you.
Shame on you, yes. And let's go back here. So if you haven't tried yet, it's just the entrance. It's an experience that is totally serverless. You just have to point your phone to the QR code. You're going to get a number, and you're going to get your coffee when you get called. So it's very fun. Just go ahead and try. Let's talk about careers. Of course, if you're looking for a next job, we are here for you. There's a job board right at the entrance, so check it out if you're looking for a new adventure. And of course, if you haven't done it yet, download the Backstage app that allows you to check out the agenda, to engage with the sponsor, and to participate to a contest where you can win the prizes from our sponsors, and the prizes are going to be given out this afternoon. And of course, let's talk about code of conduct. Of course, everybody can have an opinion. Of course, you have to respect each other, and can be much more full than this, but you're more than welcome to read the code of conduct. Just scan the code and...
In the last 7 years, we never had any kind of issue, so please be nice and don't break the tradition.
And yeah, I think that's it. Have fun. I went super fast because, of course, it makes sense that you spend your time listening to the speaker than me talking about logistics.
Yeah, and I will welcome Yan Chui for our first keynote. Yan is a great speaker. He has been CTO technical lead of a number of worldwide global enterprises, and he is the owner of the serverless, the Burning Monks serverless website. So I think that very few people are skilled as Jan to talk you about all the things belonging to serverless, all the pitfalls and all the stuff out there. It's a very great personal pleasure to have you on stage again, and welcome home to your Serverless Days Milano, and you will be always welcome within us.
Test. Okay, all right. I think this sounds fine. So yeah, well, thank you very much, Luca, and good morning, everyone. And let's talk about serverless, the hard part. We've got the rest of the conference to tell you the easy part of serverless. Just kidding, but also the good part of serverless as well. So I thought I'd start by just talking about some of the things that you may find, when it comes to serverless, things are a bit difficult. And I work as a consultant, so I work with a lot of customers who have told me how they find this, serverless being quite difficult to work with. And so the other day, I was chatting with my new best friend, trying to get a better perspective on why are people struggling with serverless, right? And for some reason, my best friend was all sassy. He was like, it's easy. What's wrong with you? So I thought, okay, all right, you're no help. And let's go to social media and ask for my friends to tell me, what do you find difficult about the serverless? And of course, all of you were just super, super helpful. So, can't rely on AI, can't rely on humans, so let's just do this myself. I thought, all right, fine. So my name is Jan. I've been doing this AWS thing for a long time. And nowadays, I help the Rumigo team with developer advocacy. And Rumigo, I think, is still the best observability platform when it comes to serverless for sure. But I also work as an independent consultant where I help other companies adopt AWS and serverless. And this is where I get a lot of, insight into what are the things that people struggle with when it comes to serverless. Maybe the number one thing is just the name itself. Because while the name serverless has been interpreted in many ways, and every time I say serverless, somebody reminds me that, but they're still servers, which of course is entirely besides the point. And I think Goiko says it best that the serverless is serverless in the same way that Wi-Fi is wireless, even though with Wi-Fi, you still have routers, right? You still have cables, so it's not entirely wireless. But the point is, when you use a Wi-Fi connection, you don't really care about those cables. And serverless is serverless in exactly the same way. Yes, there are still servers, but those are not our concern when we use serverless technologies. So to me, serverless means any technology where I don't have to worry about scaling, I don't have to worry about managing, provisioning, and patching those underlying infrastructure. And ideally, I don't have to pay for it if nobody is using my system. But as you heard earlier, serverless is just a name. In fact, the joke was that, we could just call it anything. Might as well call it Jeff. And that's why the whole Serverless Days conference came up. Initially, it was called JeffCon. And Ben Cahill wrote about this a few years back, that serverless, the name, has started to lose its meaning, and I think it's a good thing, and I largely agree with Ben, because the sooner we can get away from the marketing term, the sooner we can just start using those technologies and think about the characteristics of serverless. That's the thing that's actually important. Things like having built-in multi-AZ redundancy. Even though on days like yesterday, when the whole US East 1 region was down, you might think, okay, multi-AZ is just not good enough anymore. Then you can stay on after this and listen to Daniele talk about how you can build serverless multi-region systems as well. So you got a built-in multi-AZ redundancy, which is definitely something that we want, but you also have got that built-in security as well, where AWS is now managing and securing not just the physical infrastructure itself, but the virtual machines, the networking, as well as the operating system, as well as your runtime, perhaps. So there's far less things for you to worry about as an application developer. And also, you get that built-in scalability. You can go from 0 to handling thousands of requests per second without having to worry about scaling thresholds and setting up different scaling parameters, or having to worry about those underlying infrastructure, those virtual machines, and how to provision them, how many instances do you need in each AZ so that if one goes down, you're not impacted in terms of your capacity. And ideally, I don't have to pay for all of that redundancy. So I only pay for when my system runs. Of course, the pay-per-use pricing is a bit of a double-edged sword depending on your context. When you're running just a few requests per second, it's a lot cheaper than, say, rent the entire VM for the whole hour. But if you're running at scale, maybe you find that the pay-per-use pricing is just not very cost-efficient compared to paying for uptime. So the important thing here is that don't just think about your AWS cost. Instead, always think in terms of your total cost of ownership, which includes, of course, the AWS cost, but also your staffing cost and also the opportunity cost of what you could be doing if you're not spending 70% of your time just thinking about virtual machines and patching them and managing them, which is what I was doing back in 2010, working with EC2 and spending most of my time just managing infrastructure instead of building the features my customers want. Nowadays, that's completely switched around where I spend most of my time thinking about the business requirements and building for those. The tricky thing about total cost of ownership is often that what gets measured gets optimized. And guess what's the easiest thing to measure in your total cost of ownership? Your AWS cost, because AWS tells you how much you're spending every single month. So what's easy to see and easy to measure gets optimized and thought about much more than other stuff, even though when you think about your total cost of ownership, this is a quick mind map, you got your operational cost for the infrastructure, you got your time to market, your maintenance cost, but also your engineering cost, your staffing cost. And this is where most companies spend most of their money on staffing, on the engineers, on the offices, and hiring engineers, and the managers to manage those engineers, and so on. And if you're dealing with infrastructure yourself, having to think about how to do multi-AZ redundancy, security, scalability well at scale are very, very difficult. And that's why you often need a large team of people just to help you manage your infrastructure. So this is where serverless can really shine with the pay-per-use pricing. However, as I mentioned earlier, as you scale up in terms of your traffic, maybe at some point it's going to be cheaper or more cost-efficient to run containers and pay for uptime instead. But the question is, where is that threshold for you? And this is where it gets a little more complicated because we talk about the staffing cost. Well, if you need to, say, go from managing a cluster of Kubernetes and you need to run your own compute platform, then yes, you can do that. You may save on your AWS cost, but then if you need to go out to the market and hire a team of people to help you manage that, you may save, say, $1,000 a month on your AWS bill, but if to hire a team of people, it's going to cost you 10 times that, then you're in the negative on the net total cost of ownership terms. But how much that's going to cost you, that depends on what skills you already have in the organization and what's the cost of you going to the market and hiring those talents and skill sets to help you manage your Kubernetes cluster. In terms of the technical side of things, when it comes to serverless and specifically when it comes to Lambda, the one big question that everyone asks is, what about cold starts? That's the thing that everyone reads about, and one of the challenges that people often have when it comes to thinking, is serverless or Lambda the right fit for my workload? The first thing you've got to think about is, well, is my latency even user-facing? If I'm just doing some background data processing where no one's going to notice an additional, say, a second of processing time, then yes, that's cold start, but it probably doesn't affect you because it doesn't, in fact, it's not user-facing. And also, if your workload, say, you've got some APIs and you've got a nice bell curve traffic, then also you probably don't have to think about cold starts because all of this traffic is going to keep all of the Lambda function execution environments warm anyway. And in production, typically we see less than 1% of the Lambda invocations being actual cold starts. So even when they do happen, they happen very infrequently. And since AWS has been doing a lot of work to optimize the duration as well as the frequency of cold starts with things like the proactive initialization, where when you deploy your Lambda function, a couple of years ago, every time you do a deployment, you're going to see a jump in the number of cold starts because the Lambda is going to create a bunch of new execution environments to handle the next request after you deploy. But since they introduced proactive initialization, what they do is during deployment, they're going to see, oh, right now your function has got 10 instances running, so I'm going to create proactively 10 instances to replace those 10 we're going to take out of service so that cold starts still happen, but it happen in the background and no longer user-facing. And this same thing happens in a number of other use cases, situations where you can see those proactive initialization. Go read a blog post by AJ Stovenberg from Datadog. Really good explanation to the different situations where this kicks in. Okay, so we talk about when cold start is no longer the issue for you, but if you've got something that's, say, quite spiky in traffic, maybe like a social network, where you don't know when some influencer is going to do something and drive a bunch of traffic, then, okay, whenever those spikes happen, you are going to see a spike in cold start. There are different ways to solve this, and one of the ways that we've seen this is from Vercel, where they actually introduced a concept called in-function concurrency. So this is where instead of every single execution environment only handles one request at a time, and therefore when there's a spike in traffic, you have to create lots more execution environments to handle that spike. What you can do is reuse those existing execution environments so that when you're doing I/O, you can reuse the same execution environment to handle another request. So you have concurrency inside the instance as well as across the entire function platform. So this is something that works really well, and I'm sure AWS is working on something similar. So keep an eye out for that for reInvent, Julian. But yeah. So if cold start is an issue for you, this is where you got to think about what runtime I want to use, because the cold start is most impacted by the runtime you choose. If you use, say, Java, then you have a much different experience when it comes to cold start duration compared to, say, Node.js or Python. Or if you're James, then let's go Rust all the way, and you have a brilliant, really short cold start when you have Rust functions. There are also other solutions to help you mitigate some of the worst impacts of cold start. For Java, for example, you can use a Grail VM, or you can use a snap start, which takes a snapshot of the memory and the disk space of what your function is going to look like at runtime, and so that when Lambda actually creates those execution environments, it doesn't build the entire environment from scratch. Instead, it's going to take that snapshot it took during deployment and then create the environment from that. There's also provision concurrency as well, whereby instead of paying for and creating execution environments on demand, what you can do is you can almost pay for a server, pay for those concurrencies so that you always have a number of instances available for you, so that if you've got a baseline traffic, I can handle with 10 units of concurrency, then I'll just pay for uptime for those 10 units. This, of course, comes with trade-offs. So depending on your traffic and also your kind of cost projection model, this may be more expensive if you're not using all the most of that concurrency that you are provisioning ahead of time. So that's cold start. Another question I often get about using serverless for your workload is, what about those long-running things, ETL jobs that have to run for more than 15 minutes, which is the maximum execution time you have for a single Lambda invocation. The solution there is either you implement some kind of a durable execution with step functions, where you can break up your long-running task into smaller business chunks that you can run in kind of like almost like a loop. Then you can use step functions to drive that loop so that you can process them in parallel, especially using something like the distributed map state, which can scale your ETL job and make it much faster if you can process different parts of them in parallel. So that's just talking about the characteristics of serverless and when is it a good fit for your particular workload. In terms of thinking about how do you do development against the serverless technologies using things like Lambda, DynamoDB, API Gateway, and so on, you've got to also got to think about the developer experience, specifically the loop between development, making code changes, and testing, so that you have that fast feedback loop that we're used to and we still love, and we should still get that. We shouldn't just say, oh, because we have all the benefits of serverless at runtime, let's just forget about the developer experience or pull up with it. We don't have to, and I'm going to show you a couple of ways you can get good local development experience when it comes to serverless as well. And also, after you make your changes, you've tested it locally as much as you can also want to deploy that to your AWS environment and maybe do some more testing over there and eventually push it all the way to production. And once in production, you're going to make sure that you have some way to see what's going on in the system, understand when there's a problem, be alerted, so that you have an easy way to troubleshoot and debug things as well. So again, when I went out to ask people what are the things that are difficult about serverless, a lot of the answers centers around the testing, local development, as well as the debugging and so on. But of all the answers I got, I think Daniele also gave the best answer to just, follow me and learn best practices. Easy. All right. So around that dev test loop. We want that fast feedback loop, and this is where often I hear people tell me that, oh, when it comes to serverless, there's no local development. You have to do all of your testing in the cloud, which is just not the case. I'm going to give you 5 different ways that I've used to get that local development experience when working with Lambda and other serverless technologies. First way is what we call hexagon architectures, otherwise known as a pods and adapters architecture. So essentially, you often see people depict hexagon architectures in a hexagon, which is a vestagon, whereby you have your core business domain logic in the middle, and then you can wrap that domain logic, think of them in terms of like Java classes or JavaScript modules inside your application layer. And where your domain needs to reach out to the outside world to talk to a database, to get some data, or to receive a request from, say, API, then you expose port to allow the outside world to allow your domain to interact with the outside world. So, for example, if I want to say host my application inside a Lambda function, I can create an input port and connect it to an adapter that converts Lambda's execution arguments. So things like the event and context arguments into some domain-specific components, things like create user command. So it's not just a Lambda invocation event, but a create user command that our domain understands. So you can execute, and later we can say, okay, now I want to move my code into a container instead because the pay-per-use pricing is no longer good fit for me. I can create a different adapter for the same application and same domain logic, but have it, say, connect a Express.js app running in the Fargate container instead. So this creates a portability where you may not be, say, you may not need it today, but tomorrow you may have to run your workload in a different execution environment because your business has evolved, your context has changed, and now you need to choose a different technology and evolve your architecture. Same goes to when your domain needs to talk to the outside world, to say like a database, you can have an output port and adapter that connects it to, say, a DynamoDB table, or when it comes to local development and testing, connect to a mock, where you can write tests that exercise your application logic, but when you need to talk to the outside world, you're just going to talk to a mock instead so that you can develop and test your system locally. Or maybe tomorrow you say, okay, DynamoDB was fine to start with, but then now our model has changed as much more complex now, so let's move to RDS. Again, you don't have to rewrite the entire application or your business logic, just hook it up to a different adapter that's going to read and write data from RDS instead. So hexagon architecture, a really good way to structure your code so that you have that portability in terms of being able to move to different technologies, both in terms of the compute, but also in terms of databases and things like that. But based on my description of serverless earlier, serverless is not just Lambda functions, right? It's also things like your DynamoDB tables, which are your serverless databases, S3 for your serverless storage, Cognito for serverless user authentication, and so on, and Bedrock and things like that for AI. And the good saying we had from the start of the whole serverless movement was that you should use Lambda functions to transform data, not to transport data. And part of it is because within AWS, many services can integrate directly with other services without you having to write custom code just to, say, move data from one place to another. Take, for example, you can API in API Gateway. I can have API in Gateway integrate with Cognito for user authentication. And if I want to just build some really simple CRUD API to, say, take some post endpoint and take the body and just dump it into DynamoDB, API Gateway can do that for me without me having to write a Lambda function just to make a call to DynamoDB. And once the data in DynamoDB, I also want to just export that and put it into some kind of domain event so that other systems can handle this. So I can also do that with event bridge pipes and take the event from the DynamoDB stream and publish them to, say, event bridge, event bus, or to call some third-party API. And if I need to transform the data to convert them from, say, DynamoDB insert events into something more domain-specific, something like a user-created event, I can also have a transformation Lambda function that's attached to the event bridge pipe to do that transformation so that I'm using Lambda to transform data, not to transport them from one place to another. When you have when using direct service integrations like this, hexagonal architecture is not going to help you, even though it's going to help you create that portability and it's a really good way to structure your application. It's not going to help you when your serverless architecture is just a bunch of different AWS resources connected to each other. Because hexagonal architecture is about your code and how you structure them so that you can easily change the different environments that your code is going to run in. So what do you do then? Okay, option number 2 is to just simulate things locally using something like LocalStack, which is by far and away the best option when it comes to simulating AWS services locally. So if you take the example I got here, you can run the whole thing on LocalStack. And one of the value add you get from using LocalStack versus, say, just testing the whole thing in AWS is that since version 3, they got this thing called IAM enforcement, where you can simulate IAM permissions locally. And this is where if you ever have, say, EventBridge pipes talking to EventBridge or some other target, one of the tricky things to debug is when you got permission issues. Number one thing that can often go wrong, but it's also quite difficult to debug when, say, integration between different services fail because IAM permissions, because there's just often no good way for you to find those errors. But if you're simulating them locally on LocalStack, then you can see as you run the end-to-end test or run some kind of a test, the history API, local API, you're going to see an error pop up in your console log that says, oh, EventBridge pipes doesn't have the necessary permission to put event into the event bus. So in terms of debugging, it can also help you with that as well. And of course, if you've got that transformation lambda we talked about, you can also run that locally so they can put breakpoints in your code. You can also then quickly iterate on any logic changes you have in your lambda function without having to deploy them to the cloud and test it end to end. So local simulation gives you much better coverage in terms of different services you may use to build your serverless architecture, but it's still a simulation, so it's never going to be 100% accurate. You may find edge cases where some APIs are not covered, or maybe the behavior is slightly different to the real thing. This is especially true when it comes to some of the error cases. Some of the, I guess, the way you handles error oftentimes is slightly different from the real thing. And also, it doesn't remove the fact that you still need to know how to write tests for your application, how to test them so that you can run those tests against the application running on LocalStack. Also, recently, AWS released, I guess, the LocalStack integration in the VS Code, so you can now using the AWS VS Code plugin to also see whatever you have deployed on LocalStack as well, which is very handy. So that's option number 2. Option number 3 is, okay, well, if we don't want to simulate the whole thing locally, we can also structure our application as what we call a Lambda lift. Basically, you run your entire Express.js app or whatever web framework inside the Lambda function. Nowadays, this is a really well-supported pattern thanks to things like the Lambda web adapter, which allows you to just basically include it as an extension to your Lambda function, and you can then convert the Lambda invocation event into normal HTTP2 requests so that your web framework can understand them. There's also frameworks like Serverless Express, as well as Breath for PHP and Zappa for Python. So again, really well-supported pattern and something that many people are using, partly because this is something that we're used to. We're used to using those web frameworks. And if we can take existing web frameworks and just move it into Lambda functions, then we avoid having to rewrite the entire application, but we get a lot of the benefits of using Lambda in terms of that built-in scalability, the multi-AZ redundancy, the better security, and so on. However, this is still just about your code, right? Your code running inside Lambda functions. So if you are building serverless architectures, by using what we call a functionless approach, whereby we try to use services to talk to each other as much as possible, then this approach still not going to help you test those. And also, there's some additional penalties in terms of cold start when it comes to using large web frameworks that are maybe not designed for the constrained environment that Lambda has, or the fact that if you're building something that's not an API, this is also not as well supported in terms of the tooling, the ecosystem around it. There's also some penalties around cold starts for using something like the Lambda web adapter as well, because I think for my testing, you add about 100 milliseconds to your cold start just by having the Lambda web adapter. That's why, if you can, use something like the Serverless Express framework, which doesn't have that post-start overhead when it comes to performance. And finally, because you're taking your entire web application just running in Lambda, you're going to lose some of the fine-grained metrics and alerts you get from API Gateway. So you can make up for this by yourself by creating those custom metrics from different endpoints so that you don't just have one greedy API Gateway route and one Lambda function that handles all the different routes so that you have one alert and you don't know when that alert is fired, if it's one endpoint having a problem or do you have a bigger systemic issue. So if you can create those custom metrics for each endpoint, then again, you get back that better observability, the fine-grained metrics for your system. Another way to get local development experience when it comes to working with Lambda is just to use a framework that gives you that ability. So things like the server framework, SAM, SST, all have this ability to invoke function locally or to run your serverless application locally as well. And you can also have the debug terminal open so that you can get that breakpoint and then to get that feedback loop back into your test, which is nice, but this is all tied to the framework. The good thing is that the framework is doing everything for you. So if you're using SST or server framework, you literally just develop your serverless application and then run a command. And there you have it. You can put breakpoints in your code. You can, you can run things locally. But then what about people that don't use those framework? If you're using Terraform, okay, suddenly you can't get any of that. So as a consultant, I like to look for solutions that's going to work for as many people as possible. And so oftentimes this is available, but then I don't tend to use this just because, yes, it helps some people, but there's also lots of other people that are not used the same tools. And also, this is still just about being able to run your code locally and put breakpoints around that. But if you've got direct integrations between different services, then again, it's not going to help you. And this is where the kind of different styles or different architecture styles we have when it comes to serverless can also be a limiting factor as well in terms of what we can do. And also, the fact that you can run the SAM local dev, which is great, that allows you to test things locally, but it doesn't, that's useful when you're exploring a solution space, when you're building something new and you're trying to figure out if you've got the right code, if your code is doing the right thing. But it's not something that you're going to run every single time, make a code change, right? So we still need to know how to write those repeatable automated tests that's going to test our system and catch anything that's breaking. So with those commands, you are able to easily debug your functions locally nowadays as well. Since with the AWS toolkit for VS Code, they've also introduced this ability for you to do the same thing that you get with things like SST and serverless framework and so on. So this should hopefully, again, make it more accessible to more people. This ability to invoke your function locally and put breakpoints in your code and get that information coming back from the remote running Lambda functions. So the last approach, and the approach that I actually use most often, is what I call remote code testing. This is where you run your code locally against remote resources. So this will be running your Lambda function code locally, but have it talk to the real AWS services, things like DynamoDB and so on, hence the name remote code. And this is because when it comes to local testing, so running your code locally, you get that fast feedback loop, but then you often have to write your test against mocks. And the problem with mocks is that they are prone to giving you false positives. I can't tell you how many times in my career where I've seen the entire test suites all green, but the first time you run it in AWS, it breaks because you got some misunderstanding of what, say, the DynamoDB response looks like. You bake that misunderstanding into your mock response, so your test passes, but your code breaks in the runtime. And this compares to when you're testing in the cloud where you've got a much more realistic test case. However, every time you make a small code change, oh, I forgot a comma. I have changed the comma, now I have to wait for deployment cycle before I can run that test again. So if you take local testing and remote testing and combine them and get the best of both worlds, you can just say, run my code locally. So I get that fast feedback loop in terms of when I make a change, you can run the test straight away. But have my code talk to the real thing instead of mocks, then I also can test the integration between my code and those AWS services I'm talking to. So this approach is applicable to pretty much anything, so that doesn't matter what frameworks you use, doesn't matter what language you're using, you can do the same thing, but it's all just about testing your code, not so much the integration between different AWS services. So that is still a challenge. And also, for you to be able to say, run your code locally and talk to remote resources, you do need to have those remote resources, right? Which means that you do need to have some way to say, create an AWS environment where I can run my test after I make my changes without impacting somebody else. So this is where we can use ephemeral environments, which works really well with this style of testing, whereby every time I start working on a feature, I create a brand new environment just for that. So when I need to make changes to the DynamoDB schema and change the code at the same time, I can do that against my isolated environment without impacting anybody else. So the main thing I want to take away is that when it comes to local development, there are different ways for you to get some local development experience when it comes to serverless, and of course you can combine them as well. For example, how you write tests in terms of writing remote code tests, you can do that against local simulations if creating a real ephemeral environment inside AWS is a problem or challenge for you today. You can kind of sidestep that challenge by using local stack instead. So moving on to deployment. And this is where oftentimes the challenge is having people move to adopting the serverless mindset instead of how you think about your architecture. And again, got students that love my courses, which is always good to hear. And so the mindset change we're talking about here is when it comes to AWS, you got all these different services, you create all these different AWS resources, and not all of them should be considered infrastructure. In the real world, infrastructure are things like your bridges, like your roads and things like that. And the applications, the cars and the buses, they drive on those infrastructure, right? In the cloud, infrastructure are the things like the VMs, the networking, the disk storage, the operating system, all of that stuff. Those are infrastructure that you deploy your application components onto them, like your load balancers or your databases or your actual application code. But what about things like SQS? There's nothing to deploy. There's no infrastructure there. You just configure the queue and use it. Same goes to your SNS topics, Event Bridge buses, DynamoDB tables, and even your Lambda functions. Right? With Lambda, there's no, I don't have to worry about the storage. I'm not deploying my application components like your load balancer stuff into my Lambda function. Instead, I just configure the function and use it. Even my code, I just upload it to S3. And then when I configure my function, I point it to where my code has been uploaded. And when I say go from one version to another, AWS got a whole mechanism to making sure that the old code, that old environments running the old version of my code garbage is collected and replaced with the new version, so you get built-in blue-green deployment out of the box. And under the hood, there's a whole mechanism for allocating and creating those new execution environments and making sure that we're always running the latest version of your code. And Julian, who you're going to hear from later on today, also does a really good talk every year. Are you going to do it again this year? Okay, yep. So at reInvent, Julian's going to do another updated version of the basically Lambda under the hood talk, where it talks about how Lambda works under the hood. So the key thing here I want you to think about is that when it comes to serverless and the serverless technologies, they are not really infrastructure per se. They are your application. They are the components that makes up your application. You just configure your queues, your buses, and your databases as opposed to deploying your databases onto some infrastructure. And this brings up an interesting question of what do we do and what do we think about when it comes to infrastructure as code. And if you think about the kind of typical infrastructure as code tools we often hear about, it sees everything as a resource. There's no distinction between, say, a queue versus EC2 instance, maybe. And so things like Terraform, CDK, and Pulumi kind of falls into that category where everything that you're configuring is just an AWS resource. Whereas I think there's another category of infrastructure as code tools where they're more for application development, where many of the underlying mechanisms in terms of, say, when I've got a Lambda function, I wanted to have a trigger by API endpoint. There's underlying mechanisms for managing permissions, like the Lambda permission objects and things like that. Those are implementation details that are not really relevant for me when it comes to developing an application. So you can basically build those application frameworks on top of the basic primitives like CloudFormation or Terraform and CDK and so on. And that's where you have things like the server framework, SAM, and serverless stack, which are built on some of these underlying primitives for infrastructure as code. but they are much more designed around building applications. So the vocabulary that you have in terms of this, configuring the different components of your application is at a high level and hides away many of the underlying, implementation details that you may have to deal with when you're using things like Terraform and CDK and so on. So this is where you want to choose the right tool for the job, depending on what your team or what your specific responsibility is. So on the left side here, for the application development frameworks, those are great for feature teams and the teams that are building your APIs, your user features. Whereas on the other hand, you may have platform teams or infrastructure teams that are building your VPCs, that are building your actual infrastructures for your that runs your application. Then I think things like Terraform and other things like that makes much more sense. And sometimes when you need to share information between different teams that use using different tools, I think SSM parameter is a really good way to do that. So if I'm creating your VPCs with Terraform, then I can share the VPC ID and ARNs for things like that as SSM parameters, so that on the application side of things, I have an easy way to reference them for my say, server framework or SST and whatnot. So when it comes to deployment, this is where the question becomes how can we support parallel feature development so different people in the team can work on different things at the same time without stepping on each other's toes. And ephemeral environment is a really, really good way to do that, whereby I can say create a new environment. And by environment, I don't just mean AWS account. You can, of course, have accounts for each developer, but you can actually have, when it comes to your account organization, you think you should have at least one account per environment at a minimum. So don't put everything into one account so your production is running side by side with your dev. Instead, have one account at least for each of your environments. For larger teams, organizations with different teams, then you want to go a bit further and have at least one account per team, per environment. So this will be, my team has got several services, and I will have my dev, test, staging, and production account that's separate from another team's dev, test, staging, and production account. And if my team has got different workloads, some of them are more business critical or higher throughput than others, I also want to go a step further than that, so that my business critical workloads have got their own set of dev, test, staging, and production accounts, so that they are isolated from whatever else is going on in other services that I'm running as part of my team. So when it comes to ephemeral environment, basically for the server framework could be creating a new copy of my application. So when I come into the office, get my coffee, and then I want to start working on a new feature. So if using a server framework, I can just create a new environment, a new stage for my entire application that I want to work on. I make my code changes, I run my tests, and I'm going to run my remote code test against this temporary environment I've just created for this feature. And then once I'm happy with the code changes, I'm going to create my PR, I'm going to submit it for review, and once everything goes through and merged, I can then just run serverless remove to delete this ephemeral environment I've created just for this piece of work I'm working on. So, I'm doing my thing, I can do it in isolation, everything's good, and I don't have to worry about, making changes that's going to impact somebody else's work, somebody else who's doing something else at the same time. And when I run my tests, I also avoid polluting those shared dev environments and staging environments and so on, because they're all part of the running against my ephemeral environment. And the good thing about the pay-per-use pricing is that there's no additional cost for using all these environments. I can have one environment or 10 environments, it doesn't really matter. It's the number of requests I'm making that counts. I can also use the same technique for my PR, so that instead of running all of my tests against dev, doing a PR GitHub action for GitHub action run, I can just create a temporary environment just for the duration of that pull request, so that you run tests against that environment and then delete it afterwards. So if the way I think about my environments and my accounts, I've got one account for per environment, but dev is where the developer is going to work, so I can have all of my ephemeral environments created in the dev account as well. And for my environment, it could be represented by different CloudFormation stacks, or if it's a CDK app may have different stacks. So a CDK app may represent a single application, so that when I create a new environment, I'll deploy an entire CDK app with that same for that environment, or maybe some combination of different things, including SSM parameters and things like that. And then finally, after you deploy your changes, after they've been thoroughly tested in production, you also need to have good observability as well. And this is where, when it comes to serverless architectures, many of them are also event-driven architectures as well. And troubleshooting event architectures can be more complex. And this is where you can build your own observability stack. But oftentimes, they're not as good. They're not as good for fit for purpose. And picking the right vendor can be much better when it comes to giving you the ability to quickly debug things. So, to recap, in terms of the different things people struggle with serverless, my recommendation is to forget about the name serverless to begin with and focus on the things that are actually important, the things that serverless gives us in terms of the multi-AZ redundancy, in terms of better security, and also adopt the serverless first mindset. It's never going to be serverless only or containers only. Think, can I build this with serverless? If not, then go do something else. And understand your traffic pattern and your performance requirements to see, okay, is cold start an issue for me, and therefore, is serverless the right fit for me? And if I've got long-running tasks, can I break it down into smaller chunks so I can automate that and drive that with step functions? And then using one of the approaches talked about to get that local development experience to give you that fast feedback loop when you're working on your serverless architecture. And remember, serverless give you the building blocks for your system. It's not just about infrastructure anymore. It's about finding and defining your system in terms of those serverless components. And figure out how you can do ephemeral environments, whether to deploy them into AWS account directly or to use something like local stack if you can't do that in the real AWS environment. And then finally, find your observability stack based on what your requirements are, depending on whether you're building event-driven architectures, which may be more complex to observe compared to APIs. And once you've done that, hopefully you should have a much better way to actually fulfill the serverless promise to be able to focus on business logic as opposed to infrastructure. And yes, I just spent like 40 minutes talking about the serverless having hard parts, but don't forget, the stuff that we haven't talked about, those are the real hard parts of building systems that have to run at scale. Things like redundancy, security, and scalability, and so on. So yes, serverless has hard parts, but it's still damn sight easier compared to something else. So with that, thank you very much and welcome to ServerlessDays Milan. And I hope you guys enjoy this, and I'm going to be around later if you've got any questions.
Okay, just a quick note. Now we are kickstarting three different streams. Here in the main stage, we are going to have one stream of conference, and then downstairs you have the delivery track with other stream. Please check out the agenda for the upcoming talks, and I'm going to lend to Pamela to introduce our next speaker.
Ma quindi, perché vorresti venire a lavorare in B Sharp? Cloud. Ho sempre sognato di lavorare sul cloud.
La sensazione da subito è stata proprio quella di avere dei colleghi in più, che erano più senior di noi e che ci potevano dire tante cose interessanti.
Tante persone che si sono rese disponibili, ci hanno aiutato, hanno tradotto le nostre idee in tecnologia in primis, ma soprattutto in step di avanzamento, e quindi da un'idea è diventato un progetto.
Sono partner di AWS e quindi sono bravissimi.
Ho come la sensazione di aver dimenticato qualcosa.
Se l'hai dimenticato, allora non era importante.
Hanno tutte le certificazioni che servono, e questo che cosa vuol dire? Che per esempio per noi come startup si occupano di tutta la parte di infrastruttura, noi non ce ne dobbiamo occupare.
Quali obiettivi? Ne avevamo troppi. Avevamo proprio una visione di startup in cui, ok, non ci sono competitor, ok, non ci sono realtà che possono fare quello che facciamo noi, ok, noi siamo più bravi, più belli, quindi lo faremo meglio di tutti.
Momento. Pronto?
Riuscite a capire le esigenze e poi a tradurle effettivamente in risoluzioni di problemi.
Hello again. Let me introduce you the first speaker of today, Daniele Frasca. Daniele has several years of experience building and architecting serverless applications for millions of users. Recently, he is pushing the limits of Rust to get the extra milliseconds required to give better experiences to final customers. Today, he will discuss serverless applications at scale because customers are watching TV right now, not planning to watch it tomorrow.
Yes.
Welcome, Daniele.
Thank you. Hello, everybody. So, thank you to be here with me. I will tell you a story. This story started 1.5 years ago when my company asked me to scale our streaming applications. I led a team of 2 with no experience in AWS, and we tried to solve all our issues, availability, scalability, and resiliency. So today, I will show you some pattern that we did. There is no a blueprint that you want to follow. So it's just a lot of learning, iterations, until we make things to suck less. Very simple. Now, this was the original architecture. It's very simple, very high level. So we have a company bus that is Kafka, and we have a team, in this case was content discovery with multiple services. We have a worker that subscribe the Kafka topic, store the information in a database, and we have the API part behind the GraphQL get bombarded by our users. So there is nothing wrong with this architecture when you do it right, but we learn that technical depth usually is in code. But this architecture didn't scale, it didn't grow with the company requirements. When we start to looking into this, we notice multiple things. Deployment take up to 1 hour. The auto-scaling of a Fargate couldn't even handle spikes. Before we get a task to provision, it takes 3-4 minutes. At that point, the spike was gone. We had huge instances of RDS, a single node. So we were using actually RDS as a very expensive cache. So when we got 5-6 different services all in this way, we decided to do one thing, move to serverless. We didn't move to serverless because it's cool. It's only because we delegate the hard problem to AWS, availability, resiliency, and scalability. So this is we end up to an active multi-region services where we virtually solve all our issues. We solve, because now Lambda just scale. It's fast to deploy. We introduced something that didn't exist before. That was DLQ. So we handle issues in our worker with all the dead letters. And we solve also the database problem because we use DynamoDB, Aurora Serverless. So we didn't need to think about provisioning and think about, oh my God, if today I have 100,000 users and I have a spike at 300,000, what's happened? So everything magically works. For people that doesn't know me, I'm Daniele Frasca, I'm Italian, from Rome, and I'm living in Germany, working at ProSieben Sat.1 Media. That is actually become Mediaset now. Practically, we are building the same things of what we have here in Italy, that is Mediaset Infinity. We call it Join. Join is a streaming application that runs in multiple countries, Germany, Austria, and Switzerland. And this is our motto from our manager. Very simple to say, everything needs to be scaled, and it needs to be resilient and cheap. It's pretty much impossible, and especially when we as a developer, as a builder, we forget to improve our infrastructure during the years. The expectation of our user is very simple. They want to open the app, they want to play the video, they want to have everything in real time across platforms, and they don't care if we have the Bundesliga in Germany, and this takes all the resources. It's not acceptable anymore. In this business, actually, it's very simple. So the architectural quality reflects the user experience. When something does not work, you see it immediately because things are down. Maybe you are not loading your list of videos and everything. In fact, every single decision becomes a strategic talk between performances, reliability, and cost. But one thing is certain, you cannot have both, right? You cannot have high resiliency, high availability at cheaper cost. So you need to do some sort of investments. So I divided the talk in two parts, data quality, because we had a lot of issues with consistency, and scalability and resiliency. When we took over the team, scalability was easy. We just scaled vertically everything and hope for the best. The real problem was data quality. So again, very simple architecture. We have Kafka, and we have the ACS with a worker. Now imagine this in multiple services. The previous team didn't implement any DLQ. So when you're using Kafka, practically you need the DLQ of Kafka is another topic, right? So this probably is too complicated. They didn't want to do it. So some teams start to handling error in a different way. Some throw, some swallow the error, and some store it even in a DB. So they will start to using DLQ in a RDS. So it was completely not standard all around. And this was a huge issue because we have data inconsistency all around. Imagine that you are on the app, you see a video, you click for the details, you go on the other page, sorry, this video does not exist. And something that should be 5 minutes debugging, it was a nightmare because there were no standard across all the services. And this is how we solve the first problem. We introduce hub-spoken pattern, or event mesh, as you will, has 3 components. Kafka, that is our event store where all the events are living, and Event Bridge to fan out to our services. Between Kafka and Event Bridge, we have pipes, that is a point-to-point service, that is the medal in the middle. We intercept all the event. We can transform thanks to the enhancement features. And in this way, we fan out the same event all around all our services. All our services have Event Bridge. They expose Event Bridge. So now, instead to know if a component or another service has SQS, SNS, or whatever, the component only communicate with one interface, Event Bridge. And this event is routed through rules or internally, or on different services, or back to the company bus. These also solve another issues that we saw. Practically, the previous architecture was exchanging internal state through the company bus. In this way, now we are completely isolated, and the company bus works for what it is, no? Moving around events that need to be there. There is completely isolations. This also gives us the source of truth, because now in this service we can intercept the data, validate, transform, and all the upstream services all see the same things. Because we are working with Kafka, there is actually a limitations when we are using Amazon AWS services, the sites. And this is why we need to talk about the two types of event. No? We have sparse and full state. Sparse is the bare minimum event. You have an ID, or you have other information, and you move this over. So this is very fast. You save in storage, networking, and everything. But the upstream service need to fetch the data. So theoretically, you can end up to bring down the source. Full state, you have everything there. Practically, you are coupling source and subscriber, because if the source change a field, you start to have breaking changes. You need to be a coordination through multiple teams, and as Ian said, there are multiple ways to change the event with the versioning. Not all of them works, no? Very complicated. So in the end, we use the sparse event. This is because Kafka can go up to 30 mega, 40 megabyte. And if you're moving this kind of event into pipe or event bridge, of course it crashes, because there is a limitation of 256 kilobytes, and you will never know. At least 1.5 years ago, when event bridge or pipes didn't have any type of logs, you couldn't know all this kind of stuff. At least now you will see an error and you can figure it out. So we apply a different pattern for this case, and this is called the claiming check pattern. That is very simple. We intercept the message with the enhancement feature of pipe, store it in S3. And we are moving at this point the key of the S3 key to event bridge we found out to all our services. And now all our services access S3 as an interface. So this also means that we don't need to build any API, need to do maintain anything, because S3 pretty much scale out of the box. We talk about event-driven, right? So this is what you always see in the last 3, 4, 5 years. But there is also an alternative that is replicating data through data replications. Now, there is a reason why you don't see this often, but imagine that you're receiving the Kafka event, you normalize this event into RDS, no? Multiple tables and everything. So now, instead of finding out the event through event bridge, you are replicating this data through data replication. It's called P-logical replication. It's a feature of Postgres. And this means that all of the upstream services need to have Postgres, and you can move the data all around. So imagine if the event can normalize in 100 tables, maybe you can move only a few of those tables all around. There is a reason why you don't see this often, and I try to summarize this on this table. With event-driven, practically you are completely isolated. So you emit an event, the service can store it in any type of service, and until you keep the interface, you are free to refactor your services. You can do everything. You can store it in DynamoDB, RDS, Excel, text file, whatever. With data replication, instead, you have one database to rule of all. So practically, once you move to Postgres, all the other services must have Postgres. And the source become the bottleneck, because all the upstream service must have the same instance or bigger instance of the source of the source. And at scale, if you start to have a lot of events, the only way is to scale vertically this database. There are other type of coupling that is networking. So now you need to think about the CDR, VPC peering, all this kind of stuff, that if you have one team, easy. But once you start to have 3, 4, 5, 6 teams with multiple environments, it starts to become an issue. While with event-driven, you just emit event, everything is down. But at the same time, it gives you SQL query that you can use to investigate any type of issues. So this actually was the reasoning to how we solve data consistency in our services. From this, once we solve this, we can move to the other problems, availability and scalability. So now imagine that everybody show up at once. Our architecture has only two choices: or fail spectacularly, or scale gracefully. And the problem was that even if a lot of people say, oh, cluster are better than Lambda and so on, they don't realize that even Fargate takes time to scale. From my experience, the task in Fargate can be provisioned after up to 5-6 minutes sometimes. And if this is the time, well, at this time, all the requests start to time out the application load balancer. When the Fargate keep up, maybe RDS or the database become the bottleneck. Also because previously we didn't use any type of cache, and we didn't use a RDS proxy, right? So we have all these cascade issues. And when we hit the limit, the application goes down. And when the application goes down, you have issues in Germany, Austria, and Switzerland. It's not a nice to have. So we solve, based on the initial slide, all our problems with a combination of those services. CloudFront and Global Accelerator, similar, no? Just to make it simpler. The difference is you cache a CloudFront, the request is intercepted at edge point, and you are routed inside the AWS network. From this, we routed to the front door, that is application load balancer or API gateway, and this route to our computational service, Fargate or Lambda, and here we have cache and one of those databases. There are multiple databases to consider, but I make it simpler with DynamoDB and Aurora and RDS. Okay. Because we are building for scale, availability is not just a nice to have, it's a requirement. And to my surprise, I always start with serverless first. API Gateway and Lambda are actually not the most available service. It's actually an application load balancer and Lambda. So those are theoretically numbered, and this just gives you the foundations, but the best practice like circuit breaker, retries, timeouts, they are the technique that allow you to reach those numbers. The same things apply even to the database. The database usually are the most complicated part of our services. You can build everything with relational database. I was doing this 20 years ago. I can still do it now. I'm old. And so here on this table, you see mostly DynamoDB and DSQL, the real serverless database. You don't need any type of networking. You just use it as a library, file forget, and they just work. Everything else, like from Aurora and the RDS, they are coming with some operational complexity, VPC, or this kind of stuff. And if you're thinking multi-region, RDS become even more complicated than Aurora. There are other things that you need to consider that usually are not coming out from the proof of concept that we show to our manager. Everything in this table works. No? I put RDS single node plus replica. But, well, there are some issues, some trade-off that we need to consider. On this table, we are trading operational complexity for cost, but also we are trading reliability for simplicity. So practically, as you can see, all of those options can work in production, but simpler is the infrastructure, more ways are to fail. In fact, with RDS, a single node, there are like issues for the single brain scenario. There are the version upgrade. So here the question is not which one is working better, is which one how long are we willing to be when a problem happens, right? So it's always a trade-off. Practically, Aurora come with a cost, but we pay AWS to do all the jobs that you should implement with the simple configurations. So, again, these are trade-offs that we are considering when we build our applications. And in the end of the day, we reach a similar type of services. If you multiply the SLA for all of these services, you get the availability of your service. There is I want just to show the numbers, single region with multiple region. Again, a theoretical number, but this is the difference between customers that are going to complain in the socials all around, and a barely noticeable downtime, right? So something to consider. And I mean, 44 times improvement in availability, only moving to a second region. Now, this is our template. And this template has two principles. Never go down and recover gracefully. The key benefits of this service template, how I call it, is no service management, automatic scaling, there is building redundancy and fast deployments. I use, in this case, Momento as a cache because also we didn't want to get provisioning about the cache, but you can see this as a Valkyrie, Redis, or whatever. So this is the outcome of the 1.5 years work. But the question is, how can we make this infrastructure more resilient? At a single region, of course, you have API Gateway, application load balancer, Fargate, Lambda. They can all fail. How can we do some improvement? So we start with a single region. The first pattern that we apply was the cell-based architecture. As you know now, we have Austria, Germany, and Switzerland. So we start splitting the traffic based on the nationwide. We also have paid user, free user. We apply also this kind of routing. What actually means for Lambda. For example, Lambda gives from 0 to 1,000 concurrent Lambdas in milliseconds. You get another 1,000 every 10 seconds. Instead of asking AWS, oh, give me 3, 4, 10,000 Lambda, we cheat. So practically we deploy the same Lambda multiple times, a Lambda per path. So if you imagine now 3 nations, 2 type of user, we already have 6 Lambda. So we have a potential 6,000 concurrent Lambda. If we are going through deeper with the platform, we have other 5 platforms, we have 30,000 Lambda that we can achieve. Of course, you need to change the quota, but now in this way we can reduce the blast. So what actually means? Imagine iOS, Germany, there is a spike of user. We can limit the blast radius to our application. Only this path can go down, maybe the Lambda throttle, but this also applies to Fargate. Usually people do one service for everything. We apply the same logic to Fargate. So we have 3 services or multiple services based on the platform, user, and now they all can scale up and down, fail in completely isolations. The same pattern applies to cache and to database. And this is when it gets tricky. With Fargate and Lambda, it doesn't really matter because you don't pay much. So instead to have 100,000 requests in one place, you split it all around. But for cache and database is where AWS make a lot of money. So the cache, we solve it, gave it away to Momento, that is a third-party services. So we are paid for operations and not for the number of cache. So we don't need to care about configuring a cluster. For the database, we decide to not do, so we do the full isolation when we are using DynamoDB or possibly Aurora DSQL, that are the fully serverless service. For the rest, like Aurora, normal Aurora, or OpenSearch, we still have one database to cover all. Now, this can be the single source of failure, but we get around all of this with the next things that we introduce, caching. So nothing new, but in the previous architecture, there was no cache at all. So we have three types of cache. We have CDN, we have in-memory, and we have the cache on front of the database. The three cache combined can handle almost 90% of the hit during prime time. So this means that instead of having huge instances with RDS or OpenSearch, we can have way smaller instances, allow us to save money. And this brings us to the next step when we move to multi-region, if we want to do global tables or active-active configurations, because this gives us a lot of options in terms of cost. Another thing that we invest before moving multi-region is automations. So our infrastructure is CloudFront, Route 53, application load balancer, and the Lambda or Fargate, right? So with application load balancer, we plan for failover. Now, we can do a lot of things, like I can split the traffic equally through all the Lambdas or the services, or I can say, oh, when this Lambda fail, maybe go to this other Lambda. The same for the services. When the database or the region has a bad day, with Route 53, we intercept it and we move the traffic immediately in the other region. So practically, we create an infrastructure that does not need us. Because we create a lot of alarm, we can have events. Based on the events, we move it to Eventbridge, to Lambda, and from there we decide what to do. One thing that we did is splitting traffic through Fargate and Lambda. So Ian say Lambda is very expensive at scale. Well, it's not really true, but based on the traffic pattern and the situations, we are splitting the traffic through CS and Fargate, CS and Lambda. So we always keep 10-20% of the Lambda active with active traffic to overcome the overflow in case of Fargate is failing. And when I say when, it's always happening. It can be CPU, it can be memory, it can be a sudden AWS recycling of the task. So practically, in this way, we can have small downtime, small blast radius through the cell isolation, and everything is automated between 30 seconds and 1 minute. So at the time that something happened, I receive an email, I log in, I go and check, I woke up, it depends from the time, and the problem is gone. So once we did all of this, we start thinking multi-region. Now, 2025, multi-region is not for everybody. We have a streaming application. Imagine now Mediaset is moving. So Mediaset bought my company, by the way, right? So you will have Mediaset Infinity in Italy, Spain, Germany, and most likely in other regions of Europe. And the multi-region argument is coming, right, internally. So I found that the multi-region is not technically difficult, it's more a mindset. In my company, at least, it's because people say, oh, it's complicated, I don't want to do it, so I let everybody else do it. This everybody else usually is SRE team, and SRE team is always busy with a lot of stuff, and they say, oh, no, we don't want to do it. So we always play the card, AWS never go down. Apparently something happened yesterday. And, well, when it got down, we just brace and wait for the problem to go. I think this is not technically acceptable anymore because it's not very complicated. If you're using serverless, you don't need to do anything. You just deploy the same stack in the other region, route the traffic, and you pay exactly the same money. Because instead to send all the traffic in one Lambda, you send it maybe in 2 regions, So the total cost is always the same. Where you're paying more is database, cache, all this kind of stuff. And this is where the real question are, the hard questions. And this is, I refer to the managers. Do they understand the problem? So my job is usually to bring them to a table, to a decisions. What if we have 1 hour prime time, during prime time downtime? Are we willing to accept it? If, no, I mean, now imagine once, imagine twice. If this cost or the social complaint is acceptable by the company, be my guest. I can put a TXT file for a database. I don't care, right? But this is where the discussion with the manager must come. If they're willing to get a downtime, yes. If they are not, this is where multi-region can help you. And this where all this pattern, CloudWatch, or the cell isolation help you to reduce the blast radius. But of course, multi-region is more expensive, right? There is no doubt, because there is the data transfer, there is data replication, all of these things. The question is, how do we make affordable? So there are techniques. The simple one are remove API gateway and use application load balancer. You get a 90 scale, always. You get a 90% reduction in price. Why AWS doesn't change the price? I don't know. You can ask Julia. Other techniques are maybe Lambda and Fargate. So we build I call it a traffic controller that based on the traffic split the, I don't see it if you want to show me something. Well, it's fine. So we build a traffic controller that split the traffic through the services. So this doesn't give us also resiliency, because Fargate and Lambda are going down at the same time, so luckily. But it gives us around 60% of cost saving, because we are swapping the traffic to Lambda during the night when there is very low traffic, because the traffic is very spiky. And during the day, maybe the traffic is 90% on Fargate. So it is all automatically. The other things that we did is investing in automation. So when there is an incident, there is SRED, there are the front end, there are the back end, there are managers, there are the CTO. All of this costs money. So we spend hours trying to figure out what's going on. We never figure it out. And this is just money. So when you're building an infrastructure that gracefully recover, you don't really need all of this. So practically here, we are not eliminating the cost, but we make it reasonable for the protection that we provide, okay? And this brings us to the last slide. So what we achieved during this 1.5 years. What do we achieve? So practically, we reduce the blast radius. We don't have any incident in terms of resiliency, scalability, and so on, unless something very bad happens in AWS. The only issues are the ones that we human introduce, because we don't do testing correctly. All of this is not about serverless, it's not about cell isolation, it's all about delegations. We actually start to we have serverless first and managed service second. And serverless first, we always go in loop, because building and solving all these problems is very hard. So we gave it the responsibility to AWS. And the results are amazing, because we actually have multi-region services cheaper than single region services. This is only because we swap maybe from a single node RDS that costs 10,000, 15,000 per month to DynamoDB, global tables. So there are all these little things that we need to do that make multi-region reasonable for the company. And now, let me be very clear. Not all the services need to be multi-region. Multi-region is coming with active-active, that is the most expensive. We are talking about disaster recovery, but there is also active-passive. We have services that if they are down, the application is down. Imagine the streaming application, no? Mediaset, right? Okay, all the same. all the data, when you're moving all the pages, they all have in common one, two services that are the metadata. No, even if you're playing a video, there is always some metadata that is so. If this service go down, the application stop. Now, moving this application, only the service maybe to active, and the service maybe will cost you double, the worst case scenario. It covers the cost of being down for 1 hour, 2 hours during the year. So just this 1 hour, 2 hours, if you include all the revenue and everything, it's cheaper than spending maybe 10, 20,000 more in an infrastructure pattern. And with that one, I finish on time. Is it? So thank you. If you have any question, I can answer now or later. So I'm Italian, so you can speak in Italian to me. You are not going to allow it. Yes.
I noticed one of the things that you said in your dimensions. I noticed one of the dimensions mentioned earlier in terms of how you isolate the traffic. One of them was interesting, was user based on paying user or free user, right?
Yeah.
So that's interesting because then what happens when some becomes start with a free user being a pay user? Do you then migrate data from the pay user, free user cell to the paying user cell?
It depends. So if you're talking about the data is the same. It doesn't really matter if you are, because in our case,
right,
the cost does not justify the isolation of RDS in multiple cell.
Right.
When we are doing DynamoDB, yes, we get the event, we move the data. If we are storing the event, if you are storing something for that user, but usually free user does not have anything personalized.
Okay, I see.
So it's stateless probably.
Okay, so basically, even though your databases are also cell-specific, because the free user don't have anything that you store in DynamoDB, so it's basically a non-issue.
Yes, so sometimes in media, if you are anonymous, you can watch, for example, from Italy, you can watch some video in Germany by law, so you have 14 days, this is media portability. We are tracking the user devices and everything. If you are registering during that time and changing country, the data is moving with you in case of the database.
Okay, so moving data from cell to cell.
Yes.
Okay, gotcha. Yeah, because my follow-up question was, what if they go from paying to free user? It's not
again,
but
so
if you copy data, that's fine.
If you're paid, you have like the watch list, bookmarks, this kind of stuff. If you don't renew the subscription, you're losing that. Right. So it gets deleted at the end of the subscription time.
Okay, all right, cool.
Okay, cool. So, anybody else? Is anybody from here from Mediaset? No? Good. Otherwise, I want to talk to you.
Ma quindi, perché vorresti venire a lavorare in B Sharp? Cloud. Ho sempre sognato di lavorare sul cloud.
La sensazione da subito è stata proprio quella di avere dei colleghi in più, che erano più senior di noi e che ci potevano dire tante cose interessanti.
Tante persone che si sono rese disponibili ci hanno aiutato, hanno tradotto le nostre idee in tecnologia in primis, ma soprattutto in step di avanzamento, e quindi da un'idea è diventato un progetto.
Sono partner di AWS e quindi sono bravissimi.
Ho come la sensazione di aver dimenticato qualcosa.
Se l'hai dimenticato, allora non era importante.
Hanno tutte le certificazioni che servono, e questo che cosa vuol dire? Che per esempio per noi come startup si occupano di tutta la parte di infrastruttura, noi non ce ne dobbiamo occupare.
Quali obiettivi? Ne avevamo troppi. Avevamo proprio una visione di startup in cui, ok, non ci sono competitor, ok, non ci sono realtà che possono fare quello che facciamo noi, ok, noi siamo più bravi, più belli, quindi lo faremo meglio di tutti.
Momento. Pronto?
Riuscite a capire le esigenze e poi a tradurle effettivamente in risoluzioni di problemi.
Welcome back, everybody. Let me introduce you to the next speaker, Rafael Saraceni. He's a software engineer specialized in AI-powered B2B SaaS with more than 10 years of experience building digital products from startup to enterprise in Latin America, Europe, and Australia. Today, he will present an open-source AI agent he created to help music producers to use Ableton Live. It's one of the most popular software for music production. Welcome.
Thank you. Hi, everyone. Before I start, I would like to thank for the people who are organizing ServerlessDays Milano for the opportunity to be here and share this project with you. It's like one of the projects I'm more proud of, and I hope you guys like it. But before I start, I'd like to ask you guys, how many of you ever felt overwhelmed trying to learn a new complex software without visual guide? Has any one of you? I see some hands. Yeah, me too. It happened to me. I'm just going to go briefly through this. I have already been presented, so I don't think there's much need to spend time on this. But also, besides being a software engineer and all of my tech background, I'm also a guitar player. I love playing guitar. I play guitar since I was 14 years old. And recently, I decided I always play guitar on an amplifier. But then I started to travel a lot. I have lived as a digital nomad for 1 year. So I said, okay, I cannot just carry an amplifier up and down. I need to find a way to play my guitar in a way that I could play the guitar in a hotel room without disturbing anybody. So I realized I can buy an audio interface, which is a piece of hardware that allows you to connect instruments to your computer, and you could use some digital audio workstation to emulate effects on your guitar. You put on phone, so that's it. You can go full slash 80 Van Halen on the guitar, and you won't bother anyone, just you hearing that. And what happened is, when I bought my audio interface, it came with Ableton Live, a license for Ableton Live. Ableton Live is a music production software. It's actually the most used on the world. People like Daft Punk, DJ Tiesto, they use this guy. And it was really cool. But also, it is very complex to learn. You can do pretty much anything. You can connect instruments. You can play effects on the guitar. You can connect synthesizer. You can emulate synthesizer. You can use this to make classical music, you can make electronic music, rock, mixing, you name it. This is insane. But, as you might have imagined, something that complex also requires some time to learn. So, I started to dig a little bit into Ableton to understand what I could do, what I could not do. I was overwhelmed about how many tutorials there were, but they were really long tutorials. You had 20 minutes, 30 minutes tutorials, just to make basic stuff. And then I decided to take a look also on the documentation. They had a quite decent documentation, but again, lots of stuff. I was getting a little bit lost every time I wanted to make some changes on the effect on the guitar to understand how do I make something that I haven't tried before. I was overwhelmed about the amount of information. So what happened is, okay, I have this the manual, the site, everything. Why I just don't download the PDF of the manual and I just put it on Notebook LM or on a custom GPT? Problem solved. Seems reasonable. Well, I gave it a try, to be fair. So this is actually the Notebook LM screenshot that I did with the documentation. I asked it, I don't know if you guys can read, but I asked it, how can I apply a groove on a MIDI task? It's a simple effect, simple thing that you can do when you're playing music, but it came with all of this saying to me okay, you can use the drag and drop from the browser, you have to get this AGR file and put it somewhere else. Use the clip view, you have to double click on the MIDI clip, main clip, groove, pull this, okay, calm down. I have no idea what these things look like. I have that huge interface, I have tabs, I have stuff, I don't know where all of this is. This doesn't solve my problem. This is actually not what I want. What I really, really want is something like this. Again, the same thing. How can I apply a groove to a MIDI clip? Oh, this is nice. This is a groove pull. Oh, this is what that groove pull he was talking about looks like. Cool, I can drop clips here, stuff nice. Oh, I have this browser here, I have this section with the groove. And then here I have the groove. So this is the thing, I can get the groove and drag and drop. And this is the thing he was talking to on the clip, that there's this groove button that I can use this. okay, this is actually useful for me. This is actually what I wanted. So before getting into details on this, I want to give you guys an overall architecture of this. I know we are on Serverless Day, but today I work as a lead front-end developer on a company. I came from a strong front-end base, even though I'm more like full stack with my knowledge. So because of this, I decided to go like with React and Next.js. These are the technologies I'm most comfortable for building web apps. And I realized when I was doing some research, I realized like for AI agents, for this kind of application, Python dominated the landscape with LangChain, small agents, you name it. You have like so many stuff. But since I was like already working a lot with React and Next.js, I realized that Vercel, the company who built Next.js, they also built this AI SDK. It's an AI framework for AI agents with a lot of stuff included, and I decided this would be the perfect opportunity to learn this new AI SDK of them. For my database mapping, I use Drizzle ORM, quite straightforward, very easy to use. For my agent, I use the model 4.0 Mini of OpenAI because he's really fast, he's really cheap also. So I realized for this use case, 4.0 Mini would be a good fit. And for hosting, I used Vercel. Since I was already doing something in Next.js, Vercel was the easiest solution. And for the DB, I used this service called Neon, serverless PostgreSQL, that is really straightforward to use. It already is integrated with Vercel. I might be mistaken, but I think Vercel bought them, something like that. So they're really tied up together. And for my RAG pipeline, again, straightforward. For my embeddings, I use the Gemini embeddings. I found it like very good. Also, the cost of them was very low, so it worked perfect. For my web scraping, I use this service called Firecrawl. They are very easy to use. They have like an insane free tier. I was able to scrape almost 500 pages without paying a cent. So they give you already like the scraped data in Markdown, so it's so easy to use. I really like it. So I swear they're not paying me to say any of this. I really like them. And for my vector store, well, I already have like my serverless PostgreSQL database on Neon. So I decided like I'll just install the vector database extension and use also the same database. It was easier. I know there are some trade-offs, but for this use case, I realized it could work fine. And for the image description, when I built this, I used Gemini 2.0 Flash. Again, very fast, cheap, I would say. But today, I'm evaluating migrating it to Gemini 2.5 because I realized they have like a really better description algorithm. So this might be on the next phase of this implementation of this project. And again, when we were building like AI agents, this kind of applications, the quality of the data you get will drive the quality of the responses you get. So the first thing I need to know, okay, where can I get the data, the best data possible that my user can use to learn how to use Ableton Live? And for sure, it was the documentation. And I can show you guys here how it goes. This is the documentation of Ableton Live. I'll just put it here like right oops, sorry. Yeah, this is the documentation, and you have like all the URLs here. You have like so many stuff. Every time you click one of those sections, you have again image stuff. It's a lot of things. And I was like, okay, how can I get all those URLs? I mean, I could make a script, use a regex, but I went to the easy way. Like I realized, okay, what if I just come here? If I open the developer options, I came here, I grab this piece of HTML, and I just give it to, I don't know, Gemini, any AI, and say, hey, I have this piece of HTML, I'm looking for all the URLs that match, I don't know, Ableton Live manual, and I want you to give me a list of all those URLs without duplicates, one per line. Boom, easy, impossible gets easier than that. So this is pretty much what I did to get the URLs. I mean, you can do this like the way you're more comfortable with a script, anyway, you name it. Cool. Now that I have the list of URLs, I need to scrape them. Okay, so I created a script that for each URL, I would use Firecrawl. I would call Firecrawl API. He would give me the markdown content of the page, and I saved in my DB an object called resource that would have the markdown content of this page. This one was saved on my relational DB on Neon Serverless PostgreSQL. But I would also create the embeddings, and I was use the vector store to save my embeddings. And again, it was actually a very good idea to save the markdown content, because this way, if I have to generate the embeddings again or do anything, I don't need to scrape the data again. I can just go straight to the database, get the content to the drop-downs. If I need to debug the data that is coming to, I can just access again this data and markdown on my database. And also, if you have, if I decided to use a model that has like a bigger context window, instead of using the embeddings, I could just put the content of the whole thing on it, and you'll be fine with it. Okay, for my chunking strategy, since I was working with a markdown, I had like a minimum size of chunks that I wanted to have, and I realized that in this markdown, in this documentation, the content was like, usually it has like a header, some paragraphs, maybe another header, some paragraphs. So I realized that like most of the content that is related, it's between headers. So my first chunking strategy was like, okay, from where I am to the next header, do I have enough content to make a chunk, or is it just like too small content? Because it's not worth to make like millions of small chunks. If I didn't have enough content, I would try to go to the next header. If it was too big, I would try to go to the next paragraph or the next sentence. So pretty straightforward here. So again, once I have all this information saved on my DB, now it was time to extract the images and generate the descriptions. So again, for each URL, I created another script that for each URL, it would fetch the resource on my database because it will have the markdown content for this URL. I realized by looking at the documentation of Ableton that most of the URLs that had images, relevant images of the interface, which is the thing I wanted to use, they had like two patterns that I could grab them using a regex. So I had two regexes that would grab like all the URL of images that were relevant of the interface, and now you would use Gemini 2.0 Flash to save this information, to get the description, and I saved on my DB a media object that has like the resource that contained the HTML, the markdown, the URL of the image that I was describing, and the description of the image. Pretty straightforward here. And again, like when you're describing image for this kind of stuff, you have to keep in mind that if you give to Gemini, for example, an image that has like some buttons, a text box, and a checkbox, you just say this is a piece of interface that has some buttons, some checkbox, some text box. So you need to tell him what he's looking at. So I had to tell him, look, you got an assistance, and you are describing images of Ableton Live. Ableton Live is a software production tool, and this image you are describing, it's inserted on this context. It's inserted on this web page that describes this, and this is the snippet of the content where you find this image. This way he knows, okay, so if I see a waveform here, this is not a waveform, this is a sample of an audio clip. If I see a button saying amplitude, this is actually a control for the amplitude. This allows me to get some descriptions like this. The sample clip view is telling me like there's a waveform displayed, you have this timeline, you have bit markers, you have parameters, start endpoints, loop, position, length, signature, groove, controls, pitch adjustment. This is the kind of useful image description that an AI agent can use to provide a useful answer for the user. Again, right now, I have this simple schema, the resource that contains the raw markdown content of each script URL, the media that was the description of an URL, and the embeddings. You can see that the embedding is a little bit grayed out because he's saved on the vector store part on my database, while the resource and the media are on the default relational database. Now I'm going to talk about a little bit of Verso AI SDK. It's quite easy to install, npm install AI. It's really cool they managed to get this package AI. You can imagine how hard it was. And again, on the left, here on the side, we have the part that goes on the client. So all you have to do is use this use chat thing. You can put like your API that will call the chat. It's straightforward. You have the message, send message, the status. All you have to do is map You can send message on your input. You take care of everything. You take care of the history of the message, putting them on the context for you, and streaming the text. So it's important that your answer just don't pop up on the screen, but it goes smoothly streaming as you receive the answer. And on your backend side, all you have to do is use this stream text. You just choose your model. You can put your system prompt here. You have your message here. It's quite easy to use. And again, on my application, I had to make a mix of prompt engineering and tools usage, because I have a lot of tools here. Even though I decided to use the manual of Ableton, I realized that Ableton also has a help center that was very useful. But the thing is, the manual is more updated, is more reliable, but there are some things that might not be present on the manual and might be on the help center. So I had to tell my AI agents, the first thing, what he's supposed to do, and also what he's not supposed to do. Because people would, even if you just let people do whatever they want, they would be enter on your agent and say, hey, how can I launder money? And I don't know, some stuff you don't want people doing with your agent. So the first thing was like, hey, you are an AI agent that helps people, especially music producers, artists, to learn how to use Ableton Live, which is a music production software. Anything your user tries to do besides this, you're gonna block them politely. I'm sorry, but I'm not supposed to do that. If you have questions regarding to use of Ableton, I can help you. And then I have to tell him, oh, you have like the tool that gives you information from the manual. The manual of Ableton is like the up-to-date source of truth. You always try to get as much information from it. If you don't find enough relevant information from the manual, you can ask the help center. It's a secondary source of information that might be outdated. Always give priority to the manual, but you can use also the help center. Again, I have also created a tool to describe the images, because every time he found a URL of an image on the Markdown, he should use the describe image tool to get the description of that image, so he could evaluate how important was that piece of interface, the image of the interface, to the end answer of the user. So here we go, like my basic workflow of my AI agent. The user would ask a question. The agent, he would decide which tools to call to get the content to answer the question. The tool would fetch the Markdown information via rag. The agent will check like for the content and see if it has images. If he found images that could be relevant, he would use the describe image tool to get the description of the image, and then he would know if that image was relevant to the user, to the question of the user or not. And in the end, the user would receive a complete Markdown formatted answer containing relevant UI images. Okay, so now the part of deploying. As I said before, I went with Verso because like was the easiest, straightforward way to deploy a Next.js thing. I know there are some concerns about pricing with Verso, so it's very important you know what you're doing. I mean, I don't have like a huge database of our friends here who work like for huge companies that have like all over the world stuff, just a simple thing. So I'll just go to Verso. I'm not worried about pricing, even though I didn't put my credit card yet, so not my problem. It was quite easy. You just have to import your Git repository, you choose your production branch, and then every time you make a push to that branch, it will build your stuff and redeploy it. And also it has already observability, a little bit of observability and analytics between, so it was quite straightforward for me. Again, NeonDB, another serverless solution for database, and again, I'm using it like without worries because I didn't have to put my credit card, but I know like if you're gonna use this kind of solutions, you have to take in consideration the amount of people using it. Since I was doing this by myself, I was like, okay, there's no way I'm gonna spend so much money on this. I was really fine with the free tiers of these guys. And then I deployed it, I started to use it, I had like to do a lot of adjustments. I started to share it with some friends, they liked it. They started to ask me to do stuff also, hey, you can change here, you can do here. And then I realized I was able to build something that I like to use, I was using, some of my friends like to use, they were using, and I was like, okay, why I don't share this? going to the Reddit community of Ableton Live. I'm just going to write, hey guys, I created this stuff. It's open source. It's free. I built it for myself, but I thought it could be useful to some of you guys. So yeah, here it goes. Do whatever you want with it, and please let me know if you have any questions or feedback. And it was really cool. Like today, this post has almost more than 9,000 views. And I had like 258 upvotes so far, an 80% upvote ratio, 98 comments. It was shared 682 times, and I wasn't expecting it at all. I was like, okay, maybe some people would use, some people cared, might have some feedback, but it was really cool because many people were like, hey, thank you so much for having built this. Thank you so much for making it open source. Hey, can you use your code to do this thing for other digital audio workspace? Can I use your code for this? Can you add this? It was really nice to receive this feedback of something that I built for myself. On the first week, I had almost 2,000 people coming to my app to try it out, to do stuff. It was really nice to have this kind of impact. Today, it answered almost 2,500 questions, and the coolest thing is like I built everything in English. I never told me, hey, you can work in other languages. No, I never give directives to other languages, but even though it was capable to answer questions in pretty much any language, I remember when I opened my DB and I started to see people using it in Russian, in Chinese, in Arabic, in languages that I didn't even know, and he was able to respond in the language to show the relevant information. It was really cool. I didn't expect it at all. And I even, just for fun, I made like a donation link, and I said, hey, if you like this, you can buy me a beer, do whatever you want. And actually someone took the time to go there and buy me a beer. He paid me like $3. I have no idea who this person here is. He just gave me this donation. He said he was very thankful for what I've done. And honestly, it was really cool, like that someone, you don't even know who he is. I hope it's not my girlfriend, but someone took the time to pay me this $3. And again, what I learned building all this? Well, if you have a problem, now we have like so many solutions that help us build apps. If you're not satisfied with how this problem is solved today, you can build something for yourself. If you build something for yourself and you like it, and you share it with your friends, talk to people who has also this problem, you might see that, hey, actually I built something cool that could be useful to other people. And if you find this, you can share this with people who really care about this, and this is very important. Who cares about this? Because if I had shared this app that I did on a React community, no one wouldn't care. There are millions of free open source React apps for RAG and all of this. If I have shared this on, I don't know, an AI developers community, no one would have cared. There are millions of open source AI projects over there. But Ableton Live users, these people are not developers. They are musicians. They are producers. Even though some of them might be developers, if their main use, they use Ableton for work, they are focused on using Ableton for work, not in developing stuff. So when I show them, hey guys, I tried to do this. This is something that might help you. Please let me know. Wow, for free, for open source. They liked it for sure. Because many people, they just spam their project everywhere. Look, it doesn't work. You have to know who really cares if you want to do this. And again, use tools you're comfortable with. Because when I started to search, like everything was pointed to like use LangChain, use this Python SDK, use this. But there were tools that I wasn't comfortable. I was like, look, if I have to build something for fun, I want to build it like in the tools that I'm most comfortable with. This is why it worked. And haters gonna hate. Even though I did this for free, many people liked it. There are many comments of like people saying like, oh, look at this guy. He prefers to spend 2 days building an AI to show him how to use the software than to take some time to learn the thing. Oh, again, like all kinds of comments like this. I was like, okay, fair enough, but this is not the people I'm building this for. No matter what you do, how cool is what you do, you're gonna get some hate. Don't worry about it, okay? Again, really nice to connect with you guys. I left the QR code of my site here, my LinkedIn, my Blue Sky. I don't have Twitter, I quit that, sorry, but it would be really nice to get in touch with you guys. If you still have some minutes, I can answer you some questions or show a demo of my app, whatever you guys think is better. Thank you.
So no questions? No, there's one.
So I'm interested on how did you evaluate the agent solution that you built? So how do you test it and how did you manage to improve it? So I'm interested in this part.
Sure, that's actually a nice question. To be fair, the first version of the app still didn't have an evaluation method. I just put it and hope people liked it. But then I decided, okay, like there are some things that are not going, I need to be able to evaluate this. So I created a button, a feedback button that the user can evaluate if the answer is good or not. I did something a little bit manual that I created a list of questions that I knew how the answer should be. And every time I did some changes on my algorithm, on my chunking strategy, I would pass the app on this list of questions and evaluate if there was some change. There are actually questions that I knew there wasn't an answer on the documentation. I wanted to know if it's very cool, very interesting cause because we always think our agents will have the answers, but in our case, he doesn't have the answer, and he has to tell he doesn't have the answer and not hallucinate. But still, I know this is not the optional, scalable solution. I'm still working on it, but for now, it is like what I'm doing and help me keep going slowly because I'm doing this all by myself while working full time. No problem.
Any other questions? As I think we have time for the demo. Timekeeper? Yes.
Okay, so here we go. All right, so here is my Ableton Live agent, some straightforward interface. We have some elements here. I already left a question here. This is actually something that was useful for me. The other day, like I had some, when you play guitar, you have lots of effects you can put together, and the order of these effects matter. Like if you put one effect before or the other before, it changes completely. So I wanted to know, like, okay, when I have a chain of effects and I'm using overdrive, the amps, phase, and reverb, how should I put them together on Ableton to get the best sound of it? Yeah, maybe I would need help from my friend over there to make it faster. Yeah, that's true. Ooh, it worked. Okay. So you can see, like, it shows me the elements of the interface. It shows me, yeah, like, sure, like the overdrive. I should start with the overdrive. He looks like this. The amp, he looks like this. The phaser, quite straightforward. So if you guys had any question, you want to give it a try? I know, like, more music production stuff, but that's fine too. Okay, I think that sums it all. Thank you very much.
Thank you, Rafael. We're going to take the break now, and we're going to be back at 20 past noon.
Welcome sight it is to see you. All I want is to be with you, honey. When you coming home, seeing you again. on the goodness of each other. Constantly in awe and wonder of all the little things that make up the magic between us. Seeing you again is a welcome sign.
Try to stop the talk ticking, ticking. Turn up, turn up, turn up, we still got the music loud. The only way we're gonna get through it. So don't nobody go stop the rock hitting, hitting. Leave the fever outside your cabin. Seize the moment, reach out and grab it. If we're gonna get higher, set it on fire. It's now or never. If we're gonna go crazy, let's go together. Even if we lose our heads, it's alright 'cause we got friends. If we're gonna go crazy, let's go together. Look up, look up, look up, look up at all of that blue sky now. There's a piece of it for everyone to do what they want with it, with it. Live up, live up, live up to who you know you're meant to be. I know you got the invite, 'cause we all got the invite. The fever outside your cabin. Leave it and go! Seize the moment, reach out and grab it. Come on, reach out and grab it! If we're gonna get higher, set it on fire. It's now or never. If we're gonna go crazy, let's go together. Even if we lose our heads, it's alright 'cause we got friends. If we're gonna go crazy, let's go together. Let's go together. You and I, we got all the time. If we're gonna go crazy, gonna go crazy. Gonna go crazy! If we're gonna get higher, set it on fire. It's now or never. If we're gonna go crazy, let's go together. Even if we lose our heads, it's alright 'cause we got friends. If we're gonna go crazy, let's go together. If we're gonna get higher, set it on fire. It's now or never. If we're gonna go crazy, let's go together. Even if we lose our heads, it's alright 'cause we got friends. If we're gonna go crazy, let's go together. Let's go together. Let's go together. Let's go together. Let's go together.
I know myself. When the moon comes out, there's nothing else but you in the night. When the record's playing something right, I know a place we can go when it all feels too much. Moving our bodies, it takes us places we can't touch. Don't say you love me. Tell me in another way. Oh, don't say you want me. I know if you dance with me, so dance with me.
Okay, please take a seat. We are starting back. I need to give you a very important information. Before leaving today, please go to the front desk and get your t-shirt. Because the serverless t-shirt is back this year. So just
And now we are introducing to the stage Shani and Yuri, both AWS employee. Yuri is a veteran with 8 years of experience in AWS, and Shani started working in AWS as his first job. They are going to talk about AI and how to start with creating an agent with the Amazon SDK. Give it a huge round of applause for Yuri and Shani.
Hello, everyone. So thanks for joining us today. And today we are going to talk a bit about how to build agents in the cloud using Strand's Agents SDK. And why we chose this topic? We basically chose it because probably most of you are going to use it in the next few years. And Gartners predict that 33% of the enterprise software is going to include agents until 2028. Last year it was around 1%. Sorry, less than 1%. So I guess that most of you, do you need me to stop a bit? Okay. And 50% of the day-to-day decisions in the work are going to be made by agents. So probably most of you are going to build agents until 2028. So before we are going to start, nice to meet you. I'm Shani. I'm a go-to-market specialist for serverless and containers. I'm living now in Madrid. I just relocated. I'm basically here for you. If you need anything related to serverless, you can reach out to me after the session, LinkedIn, whatever. Everything works. And today with me is Uri.
Hi, everybody.
Okay. Good. Okay, so Uri is a serverless specialist, SA for serverless, from Israel. And today we are going to start with a short introduction. I know that everyone knows what are agents, but we are still going to want to have a baseline and to just set the boundaries. What is an agent? Then we are going to build one. Nice. And then we're going to talk about how to scale it in the cloud. So let's start. So what is agents? Agents are autonomous software systems that leverage AI to reason, plan, and complete tasks on behalf of humans or systems. So let's break it down. So it's just a software, right, that can leverage AI to reason. It understands things, it can plan, and it can complete tasks on behalf of myself or other systems. But it didn't start that way, right? It started back then with something like that. We saw a nice UI that we can chat with, so we could send the prompt to AI assistant, that sent the prompt to an LLM, which is large language model that were trained on massive amount of data, internet-size data, and then it can generate response for us. So it was nice, it was funny. We can ask questions like, please write me a poem on serverless, and it could generate a nice response. It was funny, it was nice. We could also use it to summarize our things, content, help us write emails, right? But if I wanted it to actually help me in my day-to-day planning or tasks, we got something different, right? We encountered the limits that LLMs have. So for example, what is the time right now? And what is the weather? So the response will be probably, I don't have access to real-time information because LLM were trained in a certain time, and that's it. If it's real-time or future, they didn't know it, right? Okay, if I need data that is specific to my company, so for example, I need sales data of my departure, the answer will be probably I don't have access to your data. So decisions that I need to make by with the data that my company has, I couldn't use LLM for it. Okay, let's book a trip to Paris with LLM, and again, you got it. It can't do actually tasks on behalf of myself. But agents, today GenAI is not like this, right? So that was the beginning, and we understand the limits. So LLM doesn't know what they don't know. They are trained on until a specific point in time. LLMs are stateless. They don't remember between interactions, and LLM can generate content, but they cannot take actions on our behalf. Okay, this is how we start. Let's move forward to the future. Okay. To move forward to the future, let's try to inject some context. So how much is 1 plus 2 plus 3? So the LLM answers correctly. 1 plus 2 plus 3, it's 6. Let's spice it up. Let's assume that 1 is an apple, 2 is a peach, and 3 is grape. How much is 1 plus 2 plus 3? So the LLM answers correctly. We're going to build it until these days, until agents. Okay, so instead of just adding a prompt, we can add context. So let's add system prompt, and the system prompt is basically the personality of the LLM. So I'm setting his personality to be the best French chef. Okay, so I added this system prompt to the user prompt, and I get the composite prompt. And let's see what is the answer right now for this. More enriched prompt, and then the LLM can actually kind of remember me in my interactions. Let's spice it even more and add data of private data of my company. In my company can save my private data in a database, specifically vector database. And before I'm sending the prompt to the LLM, I can enrich it with context from my private data in my company, and then I can get much more accurate answer. So I need a final sales data for my departure, and now the LLM can actually create a beautiful answer for me, which is much relevant to my needs. Okay, so, but we still didn't solve the tasks, the actions that you can take. So let's move forward and we are starting to get into agents. Okay, so I'm asking now, what is the weather in Milan today? And the answer will be, today is cloudy. He is right. He is right. Today is really cloudy. But how we knew it? How we know it? How the LLM knows that today is rainy? He was not trained on this data. So let's look at the sources. And the sources are actually weather websites. So the LLM had the ability to search over the internet and to look for real-time information. How we did it? So instead of just AI assistant, now we are moving forward to agents, to agentic assistant. And instead of just adding more context to the prompt, I'm adding also tools. I'm sending him the prompt, what I want him, the text, and I also explaining him what can the LLM ask for. The LLM is looking at the prompt. He understands, he reasons what tools he needs, what extra context he doesn't have, and get back to the agent with an ask, please use this tool, I need this information. And the agent is going to call to the tool itself, which probably connected to a data source or an MCP, get the result back to the agent, and add the result to the composite prompt. Now, if the LLM needs more context, it still doesn't enough for him, we will repeat this loop over and over again until the LLM have enough content to generate a good response, and we are giving the user the response back. So in a nutshell, this is the agentic loop. We are sending the LLM the prompt, the input, and the context, since the prompt, history, and so on. The LLM understands which extra data he needs, which extra context he needs, and he picks the tool. I need weather, please. I need real-time weather. I need your location, please. And then the agent execute the tool, update the context, send it back to the LLM, and so on, until the LLM doesn't need any more context, any response back with a good answer. Cool. So we finished with the intro. Let's start building one. Okay, so I want to build a travel agent that can help me book my flights, business for my employees, while enforcing corporate travel policies. So we have several things here, right? We have a travel agent, so we have a personality. We need to book a flight to actually take an action on behalf of myself or my employees, and I wanted to enforce my company policies, meaning it needs access to the company data. Okay, let's start. So I'm starting with my function, and I'm setting up the parameters, so I'm setting up the system prompt. You are a travel agent. I'm setting the RAG context, the company data, private data that the LLM was not trained on. I'm getting the tools, the different tools that the LLM can use, and I'm building the composite prompt, which include everything. Now it's not an agent yet. And now we are starting with the agentic part. While true means while the LLM still needs more data. So I'm calling the LLM with the prompt. I'm adding the prompt and the LLM result to the history. And if the LLM needs more data, if the status is call tool, I'm going to the tool. I'm asking him for more context. I'm adding it to the prompt and sending it back to the LLM. And I'm doing so until the status is stop being call tool, meaning the LLM have enough data, he have enough context, and I'm sending back the result. Now let's look at it. It will look different if I'm choosing another agent and not a travel agent. except from the system prompt that I can definitely do it as a parameter or as an input from the user, it will look the same in every agent that I'm building. And if I'm doing the same thing over and over, I'm writing the same code, I probably need to do it in more standard way, right? So yes, this is a boilerplate code, and I can use a standard tool for it, and here is a Strands agent SDK tool that was built in AWS for internal usage. It was built for Q developer teams. To get to agent into production, it took them back then months. And they built this library, they built this SDK for internal usage, and it got them to get agent to production in weeks instead of months. And they open sourced it. So it's free, everyone can use it. You can choose your own model. You can deploy it wherever you want, if it's in your local machine, AWS, whatever. It includes very cool things outside of the box, such as monitoring and observability and so on. We will talk about all of those in the next few slides. But yeah, so let's see how we are doing the same thing with Strands Agent SDK. So I'm importing the model and the agent, and I'm setting up the model. I don't have to. It's actually have a default, which is Claude. But if I want a specific one, I can choose as well. And I'm building the agent, and that's it. I can start using it. So let's ask the agent, how can you help me today? And we are getting this very generic answer that every LLM will generate. So let's give you more context. You are an agent, travel agent for my company. Please help us book business flights and enforcing company policies. Let's see what the answer will be now. Much more relevant answer, right? So we gave him a personality. We didn't touch the user prompt. The user didn't change anything, right? But we got a completely different answer, much more relevant. Okay, now let's see what I'm getting when I'm asking him, gave him a personality, I'm asking the LLM okay. I tell the LLM, I always dreamt of visiting Tokyo. What language do they speak there? Now, there is the key word. What is there? If you remember, the LLM doesn't remember between the interactions, and we have two interactions, right? So for the LLM to understand what is there, it needs context. It needs more data. Let's see what we are getting. So we are getting that I'm an enterprise travel agent because of the system prompt. I can help you book a business trip to Tokyo. And in the last line, we can see that in Tokyo, they are speaking Japanese. So the Strands Agent SDK have already the history built in. You don't need to do anything. So this is nice. We like not doing anything. So we are getting it out of the box. Okay, so I built an agent on my local computer, but real life doesn't work like this every time. So now Uri will explain how to do it in the cloud or scale.
Thank you. It works? Great, thank you. Thank you, Shani. Hi, I'm Uri. So Shani explained how to build an agent using the Strands Agent SDK. Simple process, writing a few lines of code. You have everything you need. You want to run it, deploy it on the cloud. She already mentioned that the Strands Agent maintains the session history, right? So we need to maintain it. Now, when we are having a chat conversation, we're sending a message, we're getting a reply, we're sending another message, and so on. We want to maintain that entire history, and that history is saved somewhere on the agent. And that's how, when we deploy it on the cloud, that's usually how it will look. We're going to the user talking to the agent running in the cloud, and the agent maintains states. But usually, typically, when we look at it, when we deploy applications to the cloud, we want to be highly available. We want to be scalable enough to support many requests. So we're going to have in more than one instance. We're going to have many instances running in the cloud of the agent. What happens when we have multiple instances? The number of instances can grow, can go down based on usage. Instances can go down because they crashed or anything. And the history, if it maintained in each one of them separately, when the user sends in the next request, it might get to a different instance. So we will not have the actual user history, and we don't want that. Usually when we deploy applications to the cloud, the applications must be stateless. And how do we do that? We externalize the state and we save it somewhere else. And that's something that we usually do when we deploy applications to the cloud that you want them to be scalable. The agents don't save the state locally, they save it somewhere else. So let's see how we do it. First of all, what is the state? We already mentioned the state is the interactions that happen. All the messages that are sent to the LLM and the responses received from the LLM are saved in a history. If you go to the agent.messages, that's the attribute that maintains the entire history. It's a JSON, it's an array of JSON objects that contains all the interactions. And that's what we need to externalize. Now, how usually we would do that? We have the agent code that we interact with. So every time we get a request, we first go and retrieve the session state from S3 in this case. I chose S3 because S3 is very scalable. It's cheap. It's highly available. It's great for use to save state. I retrieve the session state from S3. I then make the interaction with the object. I update the state that I retrieved, and I save it back into S3. Great, that's how you should do it. But should we write the code itself for doing that? Of course not, because TransAgent SDK already includes an object, a class called S3 Session Manager, that you only give it the session ID that you want. You give it the bucket where to save the interactions and the prefix, an optional prefix. And then when you initialize the agent object, you also give it a session manager. And that's it. Once you do that, automatically the agent will retrieve the state before it starts. It will update the state after the interaction. And then it will save it back to S3 as we expect it. So what is missing now? We have a user talking to the travel agent. So the travel agent needs to know, just a second, maybe some of the corporate policies are that employees may travel coach and managers can travel business. Or we want only the employees to be able to access the agent. So how do we make sure that the agent knows who the user is? Okay? We need to add authorization and authentication to our agent so the users can interact with it in a user-aware. So we are going to use Cognito. Cognito is our serverless user management system. So the user, before it can interact with the travel agent, is going to authenticate with Cognito. It's going to get a JWT, a JWT, a JSON Web Token, and then it will send a JWT when it interacts with the agent, and the agent will know that it's Alice, and it knows that it's Alice and what it can do with it. Now, when the travel agent now becomes identity aware, and it can save the state specifically to Alice, so we have the history, and we can save it forever if we want to. How do we do it inside the code? Very easily. When we instantiate the session manager, we append the session ID, the user ID, sorry, to the session ID so that the objects that are saved to S3 are going to include the user ID, so we save the interaction for that specific user in somewhere. And now, when the agent talks to me, it can say things like, "Hi, Alice." It knows who I am, and it can have a more personalized user experience. Okay, so we built an application, right? And an agent. We took care of the session management. We want to deploy it now to the cloud. We can run agents locally. We have a lot of agents running locally. If we look into QDeveloper, the Kiro, the new IDE, a lot of those agents are running locally on my machine in the IDE or the different places. But there are some agents that run remotely. If I'm not mistaken, ChatGPT, for instance, runs remotely. You interact with something in the net. But we want to run remotely, so we want to deploy it to the cloud. So where do we run it? On which compute option will we use for running our agent? We must remember, an agent is just a Python application. And we know how to deploy Python applications to the cloud. We have many options to do that. We can use Lambda, of course. We're ServerlessDays here, so we're going to use Lambda, probably. But it can be also ECS, Fargate, or on EC2. It can be EKS. It can be the new Bedrock, Amazon Bedrock Agent Core, a new feature, a new service for running agents and tools, MCP servers, and much more. Again, it's only a Python application, and that's what we need to remember. We know how to run Python applications on the cloud. We're going to go serverless, of course, because that's what we are here for, and we're going to use Lambda, but regardless of what options we use, we usually want to write our agent, or any application for that matter, in a portable way. So we're going to create a business logic in one place, and then we are going to have the interfaces for the different compute options in some other code that interacts with the agent the business logic itself. So in that case, we'll be able to run on Lambda and API gateway using the Lambda interface, using the handler, the Lambda handler, and so on. And ECS, EKS using an HTTP interface on, as I said, Bedrock, and also run it locally just using Python, agent.py. The idea here is that we might have different interfaces, but all of them call the same agent logic, and that's how we do it. How does it look? Sorry. For instance, we create the business logic in one file, my awesome agent. We call an agent. All it needs to receive, I think it's this, yes, the user ID and the user prompt. That's what it needs for the interactions. And then this is our agent code, as Shani showed it. Get the state. Actually, this is done automatically with the session manager, the agent stuff, get the response, and so on. Now, if we run it inside Lambda, we'll have a Lambda handler that extracts the user ID and user prompt from the event object, okay? And then it calls the LLM, calls the agent, sorry, with the user ID and user prompt and returns a response. But if we run it on ECS, we'll have the app post annotation, /chat, and so on. We get the user ID and user prompt from the request or from a header, and then we invoke the LLM, the agent again, the same way. So we build it in such a way that it's portable and we can run it and test it in different places. So we deployed to AWS. We decided to use Lambda for this case. How do we expose a Lambda function to users? Through API gateway. So we put API gateway in there. We indicated before that we want, the Lambda itself, the agent, needs to interact with Bedrock if you chose the Bedrock model, but it can be any model, right? Strands Agent SDK is not restricted to use the Bedrock or Amazon models. It can use any model. If you want to use OpenAI, that's fine. You can use Claude, whatever model you want, you can use it. It doesn't have to go through Bedrock. And we chose the S3 session manager, so of course those sessions are used from here. We want authorization, so we're going to use Cognito as our IDP, and then we'll use a Lambda authorizer to verify the credentials. It doesn't have, in the case of Cognito, we can use the built-in Cognito authorizer in API gateway, but if you use some other third-party IDP like Auth0 or anything else, then we'll need a Lambda authorizer. But what is missing? What about observability, CI/CD, governance, and so on? As we said before, this is just a Python application. Everything you know about running applications on AWS stays the same. You don't need to do anything special. So you have, if this is the application we built, actually there are many more services that are in use here. You use IAM for the interactions between the API gateway and the Lambda function, between the Lambda function and S3, and so on. You might use a certificate that you use and that you want for custom domain names, which is stored on Certificate Manager, KMS for encrypting things, CloudWatch and X-Ray for observability, tracing, logging, and so on. So all the services and many more are used by your application, just like when you run any other application. This is just a screenshot of the observability you get, the dashboards that you can create, the logs that you get from Lambda, and so on when you run this application. So let's test this agent that we built and deployed. Book me a business trip to Paris, a few days, and so on, starting from Monday. And then it will tell me, I'm sorry, thank you, I want to do that, but my current tools do not allow me to directly book the international trip. What does it mean? We created the agent, right? We know that agents can interact with tools, but we actually didn't provide it any tools to do the actual work, to do the actions on behalf of the user. And that's important. We must do that. So let's see how we create tools inside to be used by your agent. So let's start with an easy one. Which city I'm currently in. Sorry, I cannot determine your current location. The agent doesn't know where I'm running from. So let's create a tool for that. Let's create a tool that will allow us, the agent, to know my location. So I'm going to create a function, but actually, you might already have that function in your code somewhere, right? This is a very simple function, get user location. You give it an IP, and you call some API, and you get another location. All you need to do to make it a tool is annotate it. Add tool, right? You give it a name, get user location, and you must give it a description. Retrieve user's location should be based on the IP address, okay? Why is the description important? The description is crucial because that is what is used by the LLM to know how and when and which tools to invoke, okay? If I just give it a tool, how does it know that that's the tool that it needs to get my location? So I need to tell it what this tool is for. So I create this tool, I annotate it. Sorry, what's going on? Okay, so as I said, I created annotation. The function itself calls some external resource, but it could be something else. And then creates the response and send it back to the agent, so the agent can pass it back to the LLM, and the LLM can do something with it. And how do we give the agent the tool that it needs? That's easy. Here, you see the tools when I create the agent object. In addition to the system prompt, the previous messages maybe, the session manager, the model, and so on, I can also give it the list of tools, okay? In this case, I only gave it a single tool, get user location, and when I create the composite prompt, I also include the user IP address. That's something that the LLM doesn't know. The agent knows it from the interactions from the user, from the request that it receives, so it knows what IP to send to the LLM so that it can tell the agent, call the tool and give it this IP address, and then it will do that. Great. So this one, so if I ask it which city I'm currently in, so it will tell me you're in Austin or Milan or whatever. Great, we did that. The nice thing about Strands agents, it's not that it's so easy to create a local tool inside the agent, it's also the fact that it comes with a pre-built set of tools. There are a lot of tools, as you can see here. There are file operations, and shell integrations, and memory, and HTTP client, and so on. A lot of tools that are already built into the agent. So I can, when I initialize the agent, and I provide it the list of tools, I can just provide one of those tools, or some of them, or many of them, without the need to actually go and create them. So that's a big win, because it saves me time for doing things that are not very important for me. Now, sometimes I will use internal tools, the ones that I want to create, but if those are not enough, I want to create, if those tools are not enough, I want to create custom tools. So there are two ways. One of them is to use the internal tools, as we saw before, with the get user location, but also there are external tools. External tools are tools that are exposed through the MCP, the Model Context Protocol. I'm not going to get into MCP right now. This is not the session about MCP, just a few words. MCP is a standard way for agents to invoke tools, okay? So there are MCP clients running inside the agent, and there are MCP tools, which are external processes, and the MCP servers can host tools and resources and other things, and the agent can use them over the internet or locally on the machine, but it's a separate process. And then when all I need to do to use an external tool is to instantiate an MCP client, in this case, give it the information on how to connect to the MCP server. Okay, the MCP client is the component that talks to the MCP server. I instantiate an MCP client. I call the MCP client list tools. Okay, so I'm getting the list of tools provided by that server, and then I can give the agent the list of the list of tools, and then the agent is able to communicate with those tools as well. Okay. How do I invoke an MCP server? Again, an MCP server can be also a function running inside a Lambda function behind an API gateway that provides a list of tools. Not a lot to it if it's run remotely. It can also run locally on the same machine. I'm not going to get into that now. We already talked about making the travel agent identity aware. Let's talk about making the tool also, the MCP server identity aware. Because we want the MCP server to accept requests from the travel agent, maybe in some cases, but we don't want it to accept requests coming directly from the user. I don't want the user to bypass the agent. I wanted only the agent to be able to communicate with the tool. So how do we do that? Same way. We are going to use Cognito. We're going to use, the travel agent is going to generate a token with Cognito, but the token that it generates not only includes the identity of the agent, so the MCP server knows that it comes from the agent, it also includes the username of the user that asked the request. That's a way for implementing it. It's not the only way. And then when the MCP server receives the token, it knows that it comes from the agent, but it also knows for which user the request belongs to. It can do things differently for different users, okay? So, sorry, what happens here? Okay, so for instance, in my agent code, I can have a function like get MCP tools for user, and then what I do there is I generate a token for a user, specific, as I said, a token that includes a user ID. I create an MCP client that I pass in the header, and I include the header, authorization header, which contains my MCP token, and then I can say list tools. So I might get a different list of tools for different users because the agent now, the MCP server knows who the user is, so it can give me a different list of tools. And once I have that, of course, I can, when I initialize the agent, I can send the tools and the other tools that I got from the MCP server, and now the agent has access to more tools and can provide better answers and more actions. So let's summarize. This is what we showed today, right? We have a user talking to API gateway to an agent. That's easy. We've seen it. But it doesn't have to be a user. It can be some other custom application. So it can be some other server component. But it can also be maybe some other scheduler or event that can invoke the agent directly. So it doesn't have to be a user that interacts through API gateway. It can be something else that calls the API function. It can be also messages on SQS, kinesis, objects to S3 that generate. It can be other options. So you have a lot of flexibility here because of all the integrations that exist inside AWS and all the different services we have. Final thoughts. You need to know what you're doing, right? How to build the application and so on. You need to understand how agents work, so you need to be able to provide the right tools and the system prompts and so on. You need to provide great context, right? The right descriptions for the tools, for the system prompts and so on. Garbage in, garbage out still applies, right? If you don't give it good prompts, you're going to get bad answers. So it's good to provide the right information. And we're all developers, I'm guessing, or a lot of us are probably developers. We love to write code. Don't do the mistake and go and write all the agents yourself, all the agentic code. That exists inside Strands Agent SDK. It's already built and tested, and no need for you to invent the wheel. Invest the time in the places where you provide value, which is your business logic, your tools, your system prompt, and so on. We have here a list of different, I don't have the links here, but we have a lot of resources you can find on AWS. Maybe I should have put a QR code next time. With a lot of resources you can find on how to create MCP servers and agents and strands and different examples on Git and so on. And thank you very much. I hope that you enjoyed it and you learned something. Done?
Ma quindi, perché vorresti lavorare in B#? Cloud. Ho sempre sognato di lavorare sul cloud.
La sensazione da subito è stata proprio quella di avere dei colleghi in più, che erano più senior di noi e che ci potevano dire tante cose interessanti.
Tante persone che si sono rese disponibili ci hanno aiutato, hanno tradotto le nostre idee in tecnologia in primis, ma soprattutto in step di avanzamento, e quindi da un'idea è diventato un progetto.
Sono partner di AWS e quindi sono bravissimi.
Ho come la sensazione di aver dimenticato qualcosa.
Se l'hai dimenticato, allora non era importante.
Hanno tutte le certificazioni che servono, e questo che cosa vuol dire? Che per esempio per noi come startup si occupano di tutta la parte di infrastruttura, noi non ce ne dobbiamo occupare.
Quali obiettivi? Ne avevamo troppi. Avevamo proprio una visione di startup in cui, ok, non ci sono competitor, ok, non ci sono realtà che possono fare quello che facciamo noi, ok, noi siamo i più belli, quindi lo faremo meglio di tutti.
Momento. Pronto?
Riuscite a capire le esigenze e poi a tradurle effettivamente in risoluzioni di problemi.
welcome to this lightning talk. This is going to be only 20 minutes. We are going to have Marco, that is an AWS certificate professional and serverless specialist with over 20 years of experience in the industry. He's an author of the book Serverless Life, of the blog, sorry, Serverless Life, open source contributor and AWS community builder. Today he's going to speak about how to lose data using serverless even without knowing. A huge round of applause for Marco.
Thank you. Yesterday, AWS showed us how they can mess up your systems, but that was just a rehearsal for today's talk, because I will show you how to do it yourself. I'm Marco, and I joined a war against servers 8 years ago, and I write a blog called Serverless Life. And here are my open source projects: Serverless Spy, Lambda Live Debugger, and CDK Booster. The tool that is most useful for you is Lambda Live Debugger for remote debugging Lambda functions. It's free, open source. It's the simple solution for a really hard problem that Jan talked this morning. It supports old frameworks. How to lose your data? Well, serverless is like a holy grail of software development, but it comes with steep learning curve. Additionally, AWS have quite some quirks, and altogether it might result in you losing your data or getting invalid results without even knowing. So, first example. What's wrong with this code? Well, we have a DynamoDB table with list of conferences, and we are using filter to find the one in Milan. Why would this code not work in some cases? Well, to figure that out, let's look how filter works. You send request to DynamoDB, and DynamoDB reads up to 1 megabyte of data. And then, and only then, apply a filter. And if no records match, you get no results. And that's it. And that is highly misleading. What you should do is take the last evaluated key that you received with the response and get another batch of results, and you continue to do so until you get all the data you need. But the first response with no results can be really misleading. So here's the fixed code. It's just a simple loop. Or you can use paginate scan, a helper function which is part of SDK, which does the same thing, but the code is much nicer. There is also paginate query if you would like to use it. Or even better solution, don't use filter, especially not in large data sets. You probably noticed that we use scan. Scan means reading the whole table, and if table is large, that is highly inefficient. So for that reason, use indexes to narrow down results, and then use filter if you really need it. Another DynamoDB example. You write a record into the database and immediately are reading it. What's wrong with that? Databases are meant for this case. Well, DynamoDB is eventually consistent, meaning you might not get the data you just wrote. And the delay can be especially long if you insert a lot of data and then use global secondary index to read it. Yes, you can enable strong consistent read, but note that this is slower, more expensive, and more chance of throttling. And even more important, it doesn't work on globally secondary index, where it's the most needed. Another DynamoDB example, and this is my favorite. So you're batch inserting, or into totally different process, batch reading some records. What's wrong with that? Well, you might expect that if you don't get an exception, all the records are correctly written, or all records are correctly read. But that's not the case. In case of batch failure, you don't get an exception. You just get a list of failed items, and you should retry them yourself. I know it's confusing, but that's in documentation also. And not only that, DynamoDB is not the only one that behaves this way. If you batch insert into SQS, SNS, InventBridge, Kinesis data stream, Firehouse, etc., in case of partial batch failure, we're talking about batch operations, you don't get an exception, you just get a list of failed items. And you should retry them yourself with exponential backoff and jitter, which basically mean not retry them immediately, but with some random delay. Serverless systems are usually event-driven. To simplify, we send a message, an event from system to system asynchronously. And the key characteristic of every such system is that message can lose order or can be duplicated. Let's look at the order. Some of services guarantee order. Those are SQS FIFO, SNS FIFO, DynamoDB streams, Kinesis data streams, and some others. SQS FIFO and SNS FIFO are just a special version of SQS and SNS that are a bit more expensive and has less throughput. So think about if you really need them. All other services don't guarantee order. Next topic is duplicated events. And here is a very tricky question. Which of AWS services guarantee asynchronous or pull-based invocation of Lambda with the same payload exactly once, meaning no duplicates? I'm not talking about synchronous call like API gateway. I'm talking about SNS, SQS, InventBridge, Kinesis, etc. So which of those services will not duplicate message? None. And that could be really confusing, especially if you know that SQS FIFO and SNS FIFO offers deduplication, meaning you throw the same message into SQS FIFO and it removes duplicates. But when SQS calls Lambda and Lambda timeouts, or there is a system error, and you never know if the message was processed or not, well, the call will be retried, and here is your duplicate. So what you should do is design your system to be idempotent, meaning you must take care yourself that duplicated messages are processed only once. And what is also really important, you can find duplicated messages in less expected services. So a common pattern, you use Firehouse to load a lot of data into DynamoDB, and then use Athena to analyze it. You might expect, well, Athena has SQL query language, behave like a database. There is primary key that protects me from duplicates. No, there's no primary key in S3. And when you insert data into Firehouse, there is no way you can ensure there is no duplicate because of retrying. So if you're using this approach to store financial data and your balance doesn't match, well, that could be the reason. But it's really simple to solve since Athena has SQL query language. It's easy to remove duplicates, but you must be aware of the issue. Let's look at another design pattern, the transactional outbox pattern. It's a really great pattern. I love it, and you should use it. What it solves, well, you want to write data to DynamoDB and so also some other, and you want to do it atomically. You want both to succeed. So what you do, you attach Lambda to DynamoDB, and when the record is written to Dynamo, Lambda writes it to external system. Very simple, scalable, efficient. But what happens if external system fails? Or there is a poison pill message, meaning a message that cannot be processed. Well, obviously, DynamoDB stream will retry. But for how long? Well, for up to 24 hours. Then the data is gone. Well, it's a simple solution for that, add that letter Q. But there is a catch. If you use SQS and SNS, those messages in that letter Q don't contain actual data, just a pointer to DynamoDB stream. And yes, DynamoDB stream is gone after 24 hours. But if you use SD as that letter Q destination, then it actually stores the data. But that's quite a new feature. Another thing it's important, if you throw messages in that letter Q, you, of course, lose ordering, which is one of key features of DynamoDB stream. So we started talking about that letter Q pattern. It's a common pattern in event-driven system. When you pass message from system to system, if it fails, after some retries, you throw them into that letter Q. Usually, you use SQS, but you can use other services, depending on configuration and availability. What is important, if you use SQS, you can store their records only up to 2 weeks. So configure alarms, and even more important, don't miss those alarms, which you probably will. It's really challenging to correctly configure that letter Q. So buckle up, this will be a ride. First example is simple. You have SQS, just attach another queue to the main queue. That's it. What about if you asynchronously invoke Lambda? Then you attach that letter Q to Lambda. Or you use Lambda destination, which is basically the same thing, but you also get error message. You can use SQS, SNS, Event Bridge, Lambda, S3, all of those. But if SNS or Event Bridge invokes Lambda, then you have two dead letter queues. The first one is attached to SNS subscription or Event Bridge rule, and this one gets the messages that fails to deliver to the Lambda. And second dead letter queue if the Lambda fails. So in this setup, the second one is more important. But if the target is like API destination, the first dead letter queue is really important. Now, the last example regarding dead letter queue, we already talked about it. DynamoDB streams. Kinesis data stream is the same. With also the same issues. As I mentioned, if you use SQS and SNS, records in dead letter queue don't contain actual data. It's just a pointer to the stream. And for DynamoDB stream, that's valid only for 24 hours. Kinesis data stream is also only for 24 hours unless you configure it, which can be up to 1 year. And again, you can use S3 that get actual data. The easiest way to lose your data is by overloading your system. Every system has its limits, and if you exceed them, the system will throttle. Some of the limits you can raise by sending requests to AWS service support, but it's really hard to figure out which one you might exceed. So I strongly recommend you to do load testing. And Grafana K6 is an amazing tool for that, especially because you can write tests in JavaScript. Simple to use, very efficient. Serverless is challenging, but extremely rewarding. It's the easiest and probably in most cases also the cheapest way to build scalable and reliable systems. But it comes with some surprises. Thank you. No more servers.
Thank you. Now we have a 5-minute break, then we will get back with Enrico.
Ma quindi, perché vorresti venire a lavorare in B Sharp? Cloud. Ho sempre sognato di lavorare sul cloud.
La sensazione da subito è stata proprio quella di avere dei colleghi in più, che erano più senior di noi e che ci potevano dire tante cose interessanti.
Tante persone che si sono rese disponibili ci hanno aiutato, hanno tradotto le nostre idee in tecnologia in primis, ma soprattutto in step di avanzamento, e quindi da un'idea è diventato un progetto.
Sono partner di AWS e quindi sono bravissimi.
Ho come la sensazione di aver dimenticato qualcosa.
Se l'hai dimenticato, allora non era importante.
Hanno tutte le certificazioni che servono, e questo che cosa vuol dire? Che per esempio per noi come startup si occupano di tutta la parte di infrastruttura, noi non ce ne dobbiamo occupare.
Quali obiettivi? Ne avevamo troppi. Avevamo proprio una visione di startup in cui, ok, non ci sono competitor, ok, non ci sono realtà che possono fare quello che facciamo noi, ok, noi siamo più belli, quindi lo faremo meglio di tutti.
Momento.
Riuscite a capire le esigenze e poi a tradurle effettivamente in risoluzioni di problemi.
Hello. Now we are going to have the last talk before launch. Enrico is an experienced backend engineer and a researcher in storage and high-performance computing areas. He's a co-founder and CTO of IP, and is also active in the community as an AWS community builder. Today he's going to discuss how to navigate networking and security in serverless and software as a service platform.
Thank you, Marco. Thank you, Marco. Thank you all to be here. It's a real pleasure to be in this conference because I always was on the other side in the previous editions, so now it's very nice to be here. Today, as Marco introduced, we will talk about networking in serverless SaaS softwares based on my experience in IOP. I will do a very small introduction about me and IOP in order to give you context, and then we will go first with the basics networking both of the various cloud provider and the serverless service. It will be focused on AWS, but I will try to compare with the differences in Google Cloud and Azure also. Then we will go with some use cases, and we will discuss about security and scalability planning with a specific focus on networking also. We will close with a case study, and for Q&A we can do during lunch that everyone is hungry, I think, so we can do it later. So as Marco said, I'm a computer science engineer. I'm very passionate about serverless and DevOps especially. I'm experienced in the data fields, and I'm CTO of IOP that I co-founded 5 years ago with my friends Giacomo and Vincenzo. Now the team is big. What we want to do with IOP, and this also connected with the talk, is to rethink about the data infrastructure and the data flows that all the various softwares are doing. In order to do it, we were specific, we take the concept of serverless and we try to adapt it to the data. So you will see during the presentation that the service I will explore and I will go in details are very focused on this concept, like try to abstract the serverless ideas in order to make it work with data also. We will see then at the end. Thanks also to the Jan keynote and the Daniel intervention, because why networking and security matters. Serverless, as we said, is not just operation. It's not easy. It's not always easy and simple as we think when we approach to serverless at the beginning. Basically, there is a hidden complexity, especially for the networking and security part of it. And there is also high stakes. Imagine if you misconfigure a security groups or you make it wrong, a route path between two VPCs. The cost of it, not only monetary cost, but also the general cost of it could be very high. In order to do this, we will explore some solutions and best practices that I found during my experience with IOP in order to give you some feedback and best practices. So let's start with the basics of networking. As I said, I will start with AWS, but then we will try to see also the comparison and the differences in the main cloud provider, Google Cloud and Azure. Basically, what is a VPC? I think most of you already know it. Is a logically virtual network inside your AWS account. A VPC is inside a region. Yesterday, I think anyone that is in the cloud environment now know what is a region after the outages in East 1. Basically, inside the VPCs, there are subnets. Subnets are just a portion of the VPCs that you can configure in order to deploy instances inside it. Basically, there are two types of subnets, the public and the private. AWS didn't have a specific, let's say, differentiation between it. The main difference between public and private subnets is that the public subnet usually have automatically redirect the traffic to an internet gateway. Instead, the private ones usually use, in order to communicate with the internet, a NAT gateway that then redirect the traffic to the internet gateway. Last one, not the last, but another important concept are the route tables that basically define the path and the route that our data, our information direct. So imagine in this case, as I said, the private subnet that is redirecting the traffic to the NAT gateway when go to 0.0.0/0, so to the internet, that then redirect to the internet gateway. All these rules are defined in route tables, basically. The last important concept about the networking basics are the elastic network interface. The elastic network interface are some virtual resources that are attached to specific services or specific instances in order to give them information about, for example, private IPs or other networking and communication information, basically. And they are very important, especially for serverless, and we will see why. In this example, you can see the complete path. So the route tables that are redirecting thanks to the private IP network interface is the traffic between an ECS Fargate, an Aurora RDS, and then to the internet or to the application load balancer if, for example, you have to serve a front end. We will see then in the use case a more specific scenario about this. Another important concept about networking, the firewalls. Basically in AWS there are two layers, two concepts about firewalls. The first are the network access list that define the traffic and the rules at subnet levels. So imagine it's like a traditional firewall, you have a stateless packet filter numbered with the entries that have both allow and deny and both IP addresses and ports, and basically are evaluated by the lowest numbers to the highest one. And then we have the most common, and this is how it reflects to the original image, the network access list, so defining what is allowed inside and outside a subnet. And then there are the security groups that are most known because usually go on application level, not usually, go on application level, the security groups. Usually when you build with AWS, you are almost ignoring the network access list, allowing everything inside the access list, and then fine-grained the security groups. The security groups differently with the access list are stateful and also don't have an evaluation. Basically, you define a specific IP or a specific range and a specific port, and this is just evaluating if there is a rule inside your security group's definition. So, as I said, let's do a comparison about network and firewalls in the other clouds. So, basically, we talked about VPCs. The same concept, in different wording, exists on Azure and Google Cloud. Same for subnets. Basically, they are both called subnets in this case. It's a very general terms. And then the route tables. User-defined route tables in Azure and VPC routes in Google Cloud. Network interface exactly the same, just different wording. In firewalls, there is a small differences in Google Cloud because AWS and Azure have these two layers, as I said, network access list and security group, Azure firewall and network security groups in Azure. Instead, Google Cloud have just a service that is managing the two aspects, is firewall rules. At the end, the result is the same, it's just that on AWS and Azure you have two different layers, in Google Cloud you have just one, but the result at the end is almost the same. Let's see now some serverless service. Let's go more deep in the serverless components of our cloud. So, AWS Lambda. Usually when you start with Lambda, you start with a non-VPC Lambda. So you write your code, maybe it could use some specific services inside your cloud, it could use some specific services thanks to Boto3 or other libraries. but you don't need, at the end, communication with it. So basically, what you are doing is not configuring a VPCs. But then, for example, you start to need to access to private resources that could be, as in this example, an RDS, but it could be an EC2, it could be whatever service you think. At this point, what happens is that AWS, you can attach a VPCs, a subnet, and a security groups, one or more subnet, to be honest, or a security group to your Lambda functions. And what happens behind is that basically every time that you are executing a Lambda, you are attaching a network interface, basically, in order to attach the Lambda with the VPCs. For that reason, sometimes when you are running Lambdas with VPCs, within a VPCs instead of no VPCs, they are slower, a little bit slower. Sometimes it's not perceived, but in practical they are. And also, as I said, you can configure subnets, security groups, multi-availability zones in your Lambdas. Going to API Gateway, also API Gateway have two different flows when we think about networking. It depends a lot of the endpoint types. Basically, if you are going with a regional or edge-optimized endpoint types, you usually go to the public flow. And usually the integration, the most common integration for API Gateway is with the Lambda, so this flow that you see on the left. But then, if you need the API Gateway in order to build something internal or that needs also private communication, you use the private endpoint types. And at this point, you need other services in order to make it both callable and to start some different flow with the API Gateway call that are the VPC endpoint and the VPC link, basically. In this example, I put a network load balancer and a Fargate API code in order to show how a private flow could be. There are some security control that you can do with your API Gateway, like WOF, that allow you at application level to define basically some specific rules, but also to block the most common application level attacks like cross-scripting or SQL injection, for example. Another important control that API Gateway allow you are the JWT that you can put with, well, honestly, you can put a basic access key to your API Gateway, but then you can add JWT with Lambda custom code or simple Cognito integration. And also, you can use resource policies in order to restrict a specific aspect of your API Gateway. Let's go with the third service, AWS Fargate in serverless, because there are two ways to execute Fargate. The main difference is exactly in the networking mode, because when you are running Fargate within an EC2, you basically inherit all the EC2 networking. So everything that is running, all the various container tasks and services that are running inside an EC2, basically shared the security group, shared the subnet, etc. But when you are running in Fargate in serverless mode, you are using the AWS VPCs networking mode. And basically with it, every Fargate task has its own security groups. It could be attached to a specific subnet and also have a specific network interface. So every task of your ECS Fargate is acting as an EC2, basically. And as I said, you can apply directly security groups. And another nice thing is that as they have their own network interface, you can use service discoveries and assigning it a DNS thanks to CloudMap. So as you can see in the example, I assigned API.internal and app.internal to my two different services and tasks. Let's go again with the comparison. In this case, it's almost the same, the three services that we saw both in Azure and Google Cloud. Of course, they have their own peculiarity because, for example, in Azure, they are always putting an Active Directory. In Google Cloud, there is more a service account / resource-based approach when you are working with authentication mainly. But in theory, Azure Function, Lambda, Google Cloud Function, and API Gateway, API Management, and API Gateway also in Google Cloud, and ECS, Fargate, Container Apps, and App Engine are working also from a networking point of view in the same way, more or less. Here you can see some details. I will not go deep into this because, as I said, everyone wants to eat. But let's see how AWS offers in order to manage connectivity, and not just simple connectivity in public. And let's start it with a use case. Basically, we are running a SaaS application that run on our Lambda, and is deployed in a VPC in a private subnet. Then we need to access to an Aurora RDS database that is deployed in the customer account, imagine. So have its own private subnet, its own VPCs. This is the scenario, basically. We have two different accounts with two different VPCs, and these two private resources, private services, needs to talk. The easiest service that AWS offers is called VPC peering. It's very nice, it's very simple to configure, but of course, there are a lot of limitations. The most high limitation is the fact that it's not allowing CIDR overlap. That means that if the two VPCs that you are connecting with VPC peering shares just one IP address, imagine that they are both 10.0.0.0/16, this cannot be applied. You cannot use this service. So usually it's a service that is suggested when you have control of both VPCs ranges. I go back. So in order to solve this problem, AWS offers another service that is called the Private Link. Private Link is very powerful because allows either allow overlap of IP addresses, and basically is doing it by creating like a double NIT simulation. In the customer account, for example, EU is using VPC endpoint, and on the other side is using, for example, a network load balancer, and then private link configuration allow to see these VPCs and these VPCs like they are in a local network. Imagine it's more or less like they are in a local network. How is doing? From that one side, with the network load balancer, basically detect as front doors as for private link. Private link at the end is just a configuration of information about all these different services. And basically offer high availability, scalability, and IP preservation. And also enable this scenario of cross-VPC private communication. But the most important service in all this flow are the VPC endpoints. The VPC endpoints are basically virtual device, with a high availability and redundancy. And there are two types of VPC endpoints. One that are the interface one that are used for private link. And the interface one, as you can see in this image, support a lot of services that could be connected. I made the example with the network load balancer, but basically almost all the services of AWS that are attached to a VPC, that could be attached to a VPC, support interface endpoint. And then there are the gateway endpoints. Regarding the gateway endpoints, I want to do another example. Thanks to the AWS fundamentals GIF, because it's not just a matter of networking and security, it's also a matter of cost. As you can see in the image, when we have, for example, our EC2 that want to access to an S3 bucket and we don't configure VPC endpoint, the flow that they are doing is go to the NAT gateway, go to the internet gateway, to the internet, and then to the S3 bucket. But if we configure a gateway endpoint, as you can see, the communication is private and is also allowing you to avoid all the network cost and data cost on the net gateway and internet gateway, basically. So it's very important to use VPC endpoint when you have private communication with some services like S3, DynamoDB, basically service that you don't attach directly to a VPC. So let's see our use case could solve the problem with these two services. As we can see, I combined both because VPC peering, because we have control of the VPC IP range, so we use it with a partner, for example, or with another account in our AWS organization. But then, if I have to communicate with a customer account, I use private link, basically, in order to use also VPCs that overlaps with IP that overlaps. And the benefits of using both is that the simplification, especially when you're using VPC peering, but also the security from other side, because you can control how the traffic is going between the two private services. Let's go with another use case. The scenario is the same, but now our database is on an on-premise network, on an on-premise data center. So what AWS offers in order to do this, site-to-site VPN, the very common and famous VPN flow. Is a traditional flow of site-to-site VPN. The main difference is that you are using the physical device like the router or the gateway that is inside the on-premise network. You are virtualizing it thanks to this component customer gateway. And then inside you can use both virtual private gateway or transit gateway. In this example, I used transit gateway in order to interconnect my VPCs and allow VPN connection site to site. So, as I said, the architecture consists of these three main components. The VPN connection, as you can see, there are similarities with the private link, is just a list of the information about transit gateway, customer gateway, and tunnel information that are created in order to allow this. Let's go more specific on the transit gateway. Basically, transit gateway is a centralized hub that allow you to interconnect all the different network flows that you have inside your account or your organization, because it could also manage different VPCs in different accounts. And it's very important because allow you to centralize the cost to scale, because it's scaled by default. And also, for a security reasons, it's very important to use transit gateway when your use case allow it, because give you a specific control about your network flows and your communication, basically. So, our second use case, now we added the transit gateway in order to add the serverless app and the serverless core and to make them communicate, more or less similar to the VPC peering that we saw before. In order to allow access to the on-premise database, we will use a customer gateway that, as I said, represents the virtualization of our physical device. And basically what work with the transit gateway, as I said, but also with virtual private gateway, and support redundancy, because you can configure, imagine, multiple tunnels, so that when one tunnel is blocked or there are problems with these specific tunnels, it automatically redirects the traffic to the second tunnel of the VPN. So it's very, very powerful and allow us, as I said, to communicate with our database in a private way, let's say, because VPN is not fully private, but basically it's a very secure communication. There are a lot of different options, of different combination of these and other services that we will not see today, like Direct Connect, that allow you, for example, physical networking between your on-premise network and AWS Cloud. Here there is this paper that outlines all the possibilities. I really suggest it. If you found in Google Amazon Virtual Private Cloud Connectivity Options, you immediately found it. So let's see what offers Azure and Google Cloud. Also in this case, basically the services are one-to-one. For the private communication, we have private endpoint and private link that works more or less with some peculiarity, but works more or less as private link in AWS. For the VPCP, for the VPN, side-to-side VPN, we have VNet peering and VPC peering that allow you to create the VPC. And then we have VPN gateway and Cloud VPN from one side, and ExpressRoute and Cloud Interconnect for the VPN and Direct Connect similarities of services, basically. Let's see some best practices and suggestions very quickly about security, also especially when you work with networking. One is, of course, try to always use the assume role approach in AWS. Basically, there is this service called Security Token Service that you can use in order to define in the trusted policy of your AWS EAM role some specific information about what account or what role needs to access to this specific role permissions. And in this way, for example, you have a Lambda. You call AWS EAM Security Token Service in order to give temporary credential to access to this S3 bucket, for example. The example is with the S3 bucket, but also, for example, DynamoDB or either Lambda allow you to do this. Lambda to Lambda, for example. Another feedback is to always try to, of course, encrypt and secure all the communication channels that you have in your services. From a TLS and certificate point of view, thanks to AWS Amazon Certificate Manager that is basically free, and now also allow you to export the certificates and use also on-premise, for example, because before it was just inside AWS they use. To enforce, when possible, HTTPS everywhere, of course, using the same certificates. To try to do in your code the mutual TLS in order to require the client certificates or two-way authentication, and to, of course, encrypt as much as possible. The last security feedback that I want to share is, of course, the use of secrets management and the way serverless applications, especially for networking purpose, store the information about, for example, a database. There are two ways, basically: Secrets Manager in AWS, Secrets Manager and Parameter Store. Secrets Manager is very useful, especially with the database, because provide you also automatic rotations of the keys without updating the different databases. So imagine that you have an RDS database. Using Secrets Manager, you can automatically rotate the credential. When you rotate the credential, the Secrets Manager is updated, the Secrets Manager value is updated, and then if your application is using for authentication the credential for Secrets Manager, you don't have to do anything, and you will automatically connect to the database always. There is also the parameter store option that basically it's used for less used, less frequently rotated also secrets. The best practice in both cases is to use least privilege access, to give least privilege access to the service that are accessing to this information, and of course, as I said, encrypt as much as possible, but of course both services have some automatically encryptions, so thanks to KMS. As I said, also in this case, one-to-one comparison with Azure and Google Cloud. Basically, the services are called and have a different philosophical point of view based on the cloud concept that are the base of Azure and Google Cloud, but at the end, the services are more or less doing the same work. So you can perform identity and access thanks to managed identities or service accounts. You can do secure communication thanks to service encryption, storage service encryption, or with Cloud KMS. And you can do secrets management with Azure Key Vault and Secrets Manager. Also, in this case, they try to reduce. Usually, AWS is always offering different services with some peculiarity for, at the end, doing similar actions. Instead, Azure and Google Cloud try to uniform and to use less services. Also, in secrets management, this is true. For the scalability, this is very interesting because, especially for Lambdas, there are two main concepts about networking scalability that are very important, and are reserved concurrency and provisioned concurrency. Are some options that you can configure directly in the Lambdas, and are important because reserved concurrency ensure network interface availability when there are spike traffics. Imagine, in order to do a comparison, that you arrive in a park and you already have your parking spot reserved for you. Let's imagine like this. Instead, the provision concurrency pre-warms the network interface and reduces basically the IP consumption. In order to give a metaphor, once that you are in the parking, imagine that you arrive at your desk and your PC is already Wi-Fi connected, already logged, and you arrive, you sit and start to code. For Fargate, it's also important to remember for scalability purpose that, as I said, every task that starts with Fargate serverless mode contains a network interface, so basically is handle all your subnet CIDR where the subnet attached to the service. Also, a nice feedback it could be if you have multiple Fargate tasks that are running, that up and running always, to try to automate the security group assignment with a Lambda, for example, in order to maintain the isolation of every task if you need this specific capability. Regarding API gateway, as I said, for the scalability, it's important to consider that there are some limitation of usage plan, and you can also add some limitation. Imagine for a specific API, try to cap the call for a specific client. And of course, also WAF have some limitation in order to prevent and absorb abnormal traffic for shielding. A nice thing is that I had in the previous conference, a nice question that I had is, what is the difference between shield and WAF when you are using APIs, API gateway? The main difference is that, also as I said, they are working at different layers. WAF is working at application layer and helps you to reduce the cross-site scripting, the SQL injection. Instead, Shield, that is automatically enabled for some services like CloudFront, works for at network and communication layer. So, for example, prevent you for DDoS attack. Some limits about the networking. So, as I said, for availability zone, this is the limit on network interface in AWS. There is always address capacity based on the VPCs you are defined for the subnets, so it's important always to remember. API gateway, depending on the endpoint, have some limitation about the RPS, so basically the calls you can do in parallel. And then also the security quotas limit the VPC endpoints plan I don't remember exactly the point, but limits the count of VPC endpoints that you can have inside your account. Here there is the page where you can see all the limitation, and some of these quotas you can manually adjust or also automatically adjust based on the needs. For example, you can think about a script where you see your actual usage of a specific quotas, and you, for example, call the API of this service in order to request the quotas adjustment. Remember, but that this quotas adjustment is not automatic, but in most of the cases is manual. So someone at AWS is manually seeing your request and approve it. So there could be some times before you request the adjustment and then receive reflected in your account. Basically the same concept also for Azure and Google Cloud for auto-scaling. Also they have some consumption and concurrency limits, both on Azure and Google Cloud for the services we saw before. And also they have some limit for the networking, especially for the outbound connection and private endpoint count. And also these quotas change a lot based on the region. This is true also for AWS. Depending on the region, you can have different quotas. So let's wrap up a little bit. As I said before, we in IOP, we are building this serverless data platform. And so all these concepts that I shared with you today are very important because allow us to easily connect privately with our customer data sources and easily also provide just the capacity needs that they need in order to retrieve the data, enrich the data, or perform specific operation on the data. Thanks to, by applying these principles, we were able to do this number. For example, more than 30,000 data delivery every month, more than 40 terabytes of data, 100 of location, different SQL database, NoSQL database services that we are able to support. And we automatically provide this and reduce the connection time with these data sources. We were able to reduce also 80% the time to live speed up, because we noticed that usually the problem is always in the connection of the data source. Some actionable insight in order to wrap up. Always do a networking checklist before starting with your VPCs, mainly with your service and project. So always try to think about a VPCs in order that separate public and private layers and declare it with subnets, with specific subnet and specific route tables. Always audit the network interface usage because it's very limited to the region you are using. You can set up easily a CloudWatch alarms that is automatically done and is called network interface available. And you can audit and querying it in order to check if it's allowed to your needs. When you are using S3 DynamoDB in your private services, implement VPC endpoints because it's reduced a lot both on the cost but also on the time to reach to these services. And always try to think about the service. Today we saw VPC peering, we saw private link, we saw site-to-site VPN, but there are other, as I said. Try to always imagine also your connectivity needs when you are building your VPCs. Regarding the security, as I said, always enforce the least privilege EM roles. I know that is something that is always repeated in these talks, but it's very important. So remember always to scope the ARNs and the EM principles when you are defining the policies and the roles for your service. Apply the security group for every service. Try to automatically tag, for example, it if you need specific behavior depending on the security group scope. Rotate all the secrets when they are needed, for example, in the database. Secrets manager do it automatically. Private parameter store can be configured and easily done with a Lambda. And also always think about the scale you need. So Reserve and provision concurrency for lambdas, for example. Subnet CIDR for also for Fargate, because remember, every task is a specific network interface when you use Fargate in serverless mode. Review the API gateway usage plan and apply correctly the WAF rules, and especially monitor always all the quotas that your cloud provider gives in your region, in the region where you deployed it, and you can also automate it thanks to the service quotas APIs. So, thank you all. That's all. There is time for questions during the lunch, I think. So if you have some feedback about this session, you can scan this code and give me some feedback regarding some specific section of the talk, so I can improve it for the future conferences. So thank you again, and
thank you, Enrico.
clock is it. Everybody gotta stop the talk ticking, ticking. Turn up, turn up, turn up, we still got the music loud. The only way we're gonna get through it. So don't nobody go stop the rock hitting, hitting. The fever outside your cabin. Seize the moment, reach out and grab it. If we're gonna get higher, set it on fire. It's now or never. If we're gonna go crazy, let's go together. Even if we lose our heads, it's alright 'cause we got friends. If we're gonna go crazy, let's go together. Look up, look up, look up, look up at all of that blue sky now. There's a piece of it for everyone to do what they want with it, with it. Live up, live up, live up to who you know you're meant to be. I know you got the invite, 'cause we all got the invite. The fever outside your cabin. Leave it and go! Seize the moment, reach out and grab it. Come on, reach out and grab it. If we're gonna get higher, set it on fire. It's now or never. If we're gonna go crazy, let's go together. Even if we lose our heads, it's alright 'cause we got friends. If we're gonna go crazy, let's go together. Let's go together. You and I, we got all the time. If we're gonna go crazy, gonna go crazy. Gonna go crazy! If we're gonna get higher, set it on fire. It's now or never. If we're gonna go crazy, let's go together. Even if we lose our heads, it's alright 'cause we got friends. If we're gonna go crazy, let's go together. If we're gonna get higher, set it on fire. It's now or never. If we're gonna go crazy, let's go together. Even if we lose our heads, it's alright 'cause we got friends. If we're gonna go crazy, let's go together. Let's go together. Let's go together. Let's go together. Let's go together.
I know myself. When the moon comes out, there's nothing else but you in the night. When the record's playing something right, I know a place we can go when it all feels too much. Moving our bodies, it takes us places we can't touch. say you love me. Tell me in another way. Oh, don't say you want me. I know if you dance with me. Oh, don't say you love me. Tell me in another way. Oh, don't say Why don't we hop in that jalopy of ours and go see what's out there to see? So pack the bags, we're going on a road trip. Just you and I all weekend to have a good time. Well, there's a full tank of gasoline and our favorite playlist full of hits. So let's push play, put it in drive and road trip. First stop, we should try that cafe, the one everyone's talking about, and grub until we can't feel our feet, then go and lay down somewhere nice to watch that sunset settling under the streets, that hang with the locals, get a whole lot loco with everyone that we meet. So pack the bags, we're going on a road trip. Just you and I all weekend to have a good time. Well, there's a full tank of gasoline and our favorite playlist full of hits. So let's push play, put it in drive and road trip. Well, there's nothing better than 48 hours, wide lines and what's ahead. The perfect sidekick, my co-pilot, this is as good as it gets. Seeing the world with the wind in our hair, no place we gotta go. Got the speakers on 10, a 2-day weekend, you and I in the open roads. So pack the bags, we're going on a road trip. Just you and I all weekend to have a good time. Well, there's a full tank of gasoline and our favorite playlist full of hits. So let's push play, put it in drive and road trip. So let's push play, put it in drive and road trip. So let's push play, put it in drive and road trip.
Look into my eyes, look into my eyes. Doesn't matter if they're blue, green, brown, they flash like fire. Colors of the earth, colors of the earth. Take your flag and stick it where you like, I'm reaching higher. Oh darling, and if you think the planet's grip can hold me back, I am a rocket, there's no way you could stop me if you tried. I never felt so free as I do right now, no way that I'm ever coming down. I'm on my way to leave the atmosphere, it's all coming clear. Say your au revoir, baby, I was made for the stars. Listen to my voice, listen to my voice. Coming at you like a lion's roar, I won't go quietly. Take a picture now, take a picture now. Go on, point the hubble at me, don't lose sight, I'm high society.
excited is to see you. All I want is to be with you, honey, when you coming home. Seeing you again is a welcome sign. Seeing you again is a welcome sign. Let the sun shine down on the goodness of each other. Constantly in awe and wonder of all the little things that make up the magic between us. Seeing you again
quindi perché vorresti venire a lavorare in B Sharp? Cloud. Ho sempre sognato di lavorare sul cloud.
La sensazione da subito è stata proprio quella di avere dei colleghi in più, che erano più senior di noi e che ci potevano dire tante cose interessanti.
Tante persone che si sono rese disponibili ci hanno aiutato, hanno tradotto le nostre idee in tecnologia in primis, ma soprattutto in step di avanzamento, e quindi da un'idea è diventato un progetto.
Sono partner di AWS e quindi sono bravissimi.
Ho come la sensazione di aver dimenticato qualcosa.
Se l'hai dimenticato, allora non era importante.
Hanno tutte le certificazioni che servono, e questo che cosa vuol dire? Che per esempio per noi come startup si occupano di tutta la parte di infrastruttura, noi non ce ne dobbiamo occupare.
Quali obiettivi? Ne avevamo troppi. Avevamo proprio una visione di startup in cui, ok, non ci sono competitor, ok, non ci sono realtà che possono fare quello che facciamo noi, ok, noi siamo i più belli, quindi lo faremo meglio di tutti.
Momento, non momento. Pronto?
Riuscite a capire le esigenze e poi a tradurle effettivamente in risoluzioni di problemi.
Right, so we're back. We're a bit late, so we're gonna give you a bit of time back, don't worry. Hope that everyone had a good lunch. So to start our afternoon, we're gonna have one of the best, one of the foremost serverless developer advocates in the world. Not only an exceptional advocate, but also an amazing speaker and presenter. So please give a warm welcome to Julian Wood.
Wow, that puts the pressure on. Is everybody okay after lunch? We were at Serverless Espresso, so I hope everybody's had a coffee this afternoon, at least to stay awake during my talk. So if you do fall asleep in this talk, it's because you didn't have the coffee, not just because I was boring, hopefully. Just hands up quickly, who's here for their first Serverless Days in Milan? That is cool. And who's been to more than one then? I suppose everybody else. Excellent, excellent. It's nice to see how this community is growing and thriving. Well, today we're going to talk a bit about development and stuff you can do with Lambda. So first of all, hands up, who of you spend more time actually debugging code than architecting it? Some people, some people. Okay, who are developers in the room? Most people. Okay, so we've got a decent amount of people who architect more code than debugging it. But now, one picture on the left is obviously what all of you look like when you're debugging code rather than the right, correct? It all works perfectly, everything's fine, it's all really easy. Yeah, no, didn't think so. Because obviously things are frustrating. You have this expectation, you want to build your features, you want to get your stuff done out into the market, but the reality is there's all the stuff that goes wrong. You've got all the testing and you've got the deployment and different environments you're going to run. And it's just not as easy as it said on the tin. But actually, the part on the right that we want to get right is all about developer experience. And this, whether you believe Deloitte or not, they came out with this survey. It said companies that actually focus on best-in-class developer experience get 60% higher revenue growth. This basically means if you give your developers more and you help your developers have better developer experience, it's better for your business. And this sort of ties in like why serverless, because the whole point of serverless, forget that there are no servers in serverless and all that kind of thing for a moment, but the point is it's a faster time to market. So it's quicker to get your things into production, so surely developer experience is part of that. If you can improve the lives of your developers, get them more enthused, get them more proactive with the tools that you're running, you can do better with serverless and do better for your business. I'm Julian, I'm a developer advocate. I do work for AWS. I've been part of many serverless days. I'm super frustrated that I've never done a Milan one before. So it was good today to be able to rectify that. But yeah, I've got my contact details will be at the end as well. So if you want to hit me up for any questions and any comments afterwards, or chat to me afterwards. So obviously when we talk about development, there is a development loop. And we've actually got the part of the inner loop, which is what you basically do on your workstation or on your laptop. It's about writing code, compiling code, I don't know, maybe even using your GenAI tools to create code. And then there's this outer loop concept. Once it's all been tested, debugged, working, you push it somewhere else. It could be a CI/CD pipeline, it could be a direct deploy, somewhere else, and it happens in the cloud. And so you've got this sort of two different parts you need to work with, the stuff that you do locally and the stuff that sort of handles remotely. And obviously, when you're doing serverless applications, there are even more services. There are more things you need to interact with, so that inner loop isn't just a monolithic code base and you deploy it somewhere. It's all these other services that you've got to connect with and interact with. And in a way, that does make things harder, even though the benefit of serverless is be able to use the right tool for the job. And so there's this sort of local way of thinking and the cloud way of thinking. And in a way, you can translate that into using things in your local ID or things you're going to do in the terminal, and then things you're going to do in the AWS console. Now, I know that doesn't quite map directly to the outer loop, because that is all about, often about CI/CD pipelines and getting things into production. But this part is, you've got stuff locally and you've got stuff doing in the cloud. The things you manage locally, is in your local ID, and the things you often manage in the cloud is with the AWS console. But there are obviously benefits, cons and pros between each of them. So obviously the console, zero setup required. It's just easy to get up and running, and it's always up to date. But things are manual. You don't have any sort of automation. You haven't got version control. Things can get out of hand and can get out of drift. Well, on the local side, you've obviously got powerful editing, all the tools that you've set up, those sort of key bindings that you've done to the perfect thing that have followed you around about 700 companies, exactly the way that you're going to work. But obviously, that's hard to set up. You've got to set up all these kind of things. It's difficult to simulate AWS services. You've now got this way you need to keep your local and your cloud in sync. And obviously, permissions and roles is not the same on your laptop as you want to do it. So ideally, you actually want the best of both worlds. You want to at least have a way to transition between the two and sort of have a better experience when you're working on your laptop station and then developing into the cloud. With the sort of third part of the thing as well is that you actually really want to be trying to move things to infrastructure as code for all the benefits they have of repeatability. Jan talking this morning about ephemeral environments without infrastructure as code. So it sort of all works together to be able to do kind of things. And just infrastructure as code, we have plenty from AWS, many third-party things. You really want to be building serverless applications using an infrastructure as code tool, because it just gets rid of a whole bunch of stuff and makes life easier for you. And so the idea is you sort of want to get into this sort of crawl, walk, run, and then fly mode, where you can start at the console, do some experimentation, be able to do stuff in your IDE, get good infrastructure as code things, and then, super automation that you can build stuff into your environments. So the rest of this talk is mainly about demos of the cool kind of things that we've hopefully built in Lambda. That's going to be useful for you as well. So I have actually recorded a bunch of demos. I thought I could do it live, but I've only got 30 minutes, and we know it takes time to deploy kind of things, and the demo gods may not be behaving, especially with the weather yesterday. I can't believe I'm blaming the weather. But anyway, I have recorded them, and I've cut them up slightly so they can go a little bit quicker, but I promise you it is all true and all sort of happening. So let's start and sort of think about, maybe you're going to start in the Lambda management console. Maybe you don't even really know much about Lambda. You just want to explore, or you know enough about Lambda, but you quickly want to build something and you haven't sort of got stuff done. So I've built a new function in the console, and I've called it new function, and I can now look at all the different kind of things. It looks like VS Code. So this looks like your local IDE, but now running in the cloud with an update we did earlier this year. See, I've also got a big file. So previously, you could only have 3 meg up in the console. Now you can actually display code that's up to more than 3 meg. Now you can display package sizes that are up to 50 meg in the console. So people are thinking, yeah, you don't have Lambda functions that are necessarily 50 meg. But no, anyone worked with Node or Python dependencies, how big do those dependencies get? They are huge. And wasn't it so annoying when your function is only sort of 4 lines of code and you couldn't see it in the console because the dependencies are so big? Well, this helps with that. So now you can actually see your functions in the console, even if you've got a large package size. I'm going to head over to this side because it's going to be easier to not block all the screen. And so the next thing we've got to do is we have our large package size. Has that gone to the next one? No, there we go. So if we now look up some other kind of things, we've got some functionality to look at as well. We can see it's VS Codes. We've got some extensions. We've got some keyboard bindings and some kind of things that you can do. So if you're Vim and Emacs, that's all good. The command palette, just like VS Code, you can type Lambda and look at all the various functionality that is exposed over there. We've also got some profiles, and we've also got some settings that you can do, normal VS Code kind of settings, like your local environment, but sort of a smaller version in the cloud. Obviously, very important, you need to change your color theme. People get very interested about different color themes. So here, we've do it onto full screen. Remember, I'm in the Lambda console with my dark color scheme. It looks very similar to what I've done within my local console. So hopefully it doesn't have that sort of jarring thing of being able to go between remote and local. So the next thing up is environment variables. You can actually edit environment variables much more easily now here in the console. So I can set the environment variable to my very important settings, save that, and we can see now on the left-hand side when I scroll down that you can actually see that the environment variables are directly right next to your code. Code on the right, you've got your environment variables on the left, able to see what they are. That's going to be far quicker than having to jump back and forth between where the configuration is. So the other thing we can think about looking at is testing. So we can actually create a test event over here. I can just give it a name. I can give it a private or a public one if I want to be able to share it. And if I'm using an API gateway, I can just grab an existing API gateway event, and I can scroll down and change anything I want to do. So let's say I'm going to change those query string parameters to my name, and then I'm going to be able to just save that as a test event. And I have a test event. I can save that. That's all ready to then use. I can then invoke my Lambda function in the cloud, and you can see that that is then going to invoke, and you can see I then have a hello from Lambda. So really simply, I've grabbed a test event. We've got all AWS events from there as well. You can create your own test events. You can amend them. You can actually share them. You can actually read them locally as well. So we've also beefed up the test event experience creation. So obviously, everybody is using a bit of GenAI. I don't know if you've tried Amazon Q, but Amazon Q is in a lot of different places, or if you're using Kira or Windsurf locally. But actually, in the AWS console, in the Lambda console, you can use Q directly. So here, I'm just doing a comment saying, get API gateway query string parameters from the event. I just hit tab, and there it goes. In lovely JavaScript, it's just going to pull out exactly what that query is going to be. I didn't have to write anything myself. I can say, well, I'm just using tab complete over there. And it's now going to change my response object to include that query string parameters. I'm going to add another comment as well and say, let's get that environment variable, the my variable one I set before. There you go. It's just going to find exactly the code that you're going to need to be able to get your environment variables. So quick and easy. It's not obviously the full functionality of a GenAI code editor, but right in the console here, just by being able to do some code complete, saves you jumping back and forth to try and remember that parameter. So I can go off here, I can then invoke that, and you can see here I've got the environment variable and that parameter from the query string that I had on my input object. So again, we've got the invoke thing right next to your code, right next to your environment variables. Everything's on the same screen. Hopefully that should make life a little bit easier for you when you are building. So another thing we've got in the console as well is being able to live tail your logs. So it's interesting because I can go over here and I can just open the CloudWatch live tail from the debug section on the left, and then I've basically got to start a live tail session. And so this starts a session, it basically attaches it to CloudWatch logs, and then this is going to wait for the logs that are going to arrive. Now, I can invoke the function over here, and the logs are going to arrive. You're going to see that as well. But you can also see that if I have maybe a Lambda function with an API that you're connecting via curl, I'm not testing via the console, connecting via curl, or I've got a an SQS event or a Kafka event, or I don't know, event from anywhere else, that live tail is actually going to pick that up, pick that event right up over there. So that's a really easy way, rather than having to jump to CloudWatch logs, to be able to see that live tails directly here in the Lambda console. I can see exactly what is going on. So now we've done a bit of stuff in the console, but we've spoken about that actually where a lot of your really cool tools are and everything is in your IDE. So how can we transition between the two? So in the same pane, you see I've got two options. I've got this download the code in the SAM template, and this is actually just going to take a download of the code in the SAM template, and you're going to be able to open it up on your terminal. But the other cool one is actually directly open in Visual Studio Code. So click a single button, I've got Visual Studio Code set up. I can just select to open Visual Studio Code. I'm sure that is doing something. There we go. So allowed to open. And this is now going to download my Lambda function into my Visual Studio Code. And it's going to have all of that. There's that big file. It's got my index file. And this is just downloaded directly into my workspace. I didn't have to download it. I didn't have to unzip it. I didn't have to look at anything else. This is super useful because I've got my code directly from here from my Lambda function. I can use Amazon Q directly within my IDE as I would or another code editor. Here I'm just saying, why not add something to install something. Now the cool thing is I can now actually add dependencies locally in my IDE. And what I can do is I can go and have a look at the package.json. It says, yes, that Axios file is over there. I look at my index file, and I can then use that Axios library within my function code and be able to use that. I click on save, and it says, well, do you want to sync this with Lambda? And so this is going to upload that whole Lambda function, zip it up for you, including that Axios dependency. And so this is something that you weren't able to do before. Before, you'd have to add the Axios dependency, zip up your Lambda function, upload it to the cloud, and do all of this. All I've done over here is I've installed everything locally, and I literally click the save button, and the IDE toolkit realized that it had been updated and automatically synced my code up into the cloud. So that is super cool. If I go back to the console, it says, yeah, well, now your cloud version has been done, so I can refresh that, and that's then going to come up with the latest version of my code. And I can go and invoke that as well, and you can see now I've got that current IP address happening over there. So yeah, a really quick way. I've just been able to go from my console, just click on the single button, it opens up in my IDE, make some more fully fledged changes in my IDE that I can't do in the console, like installing dependencies, click on save, and up it syncs to Lambda. So the next kind of thing to look through is some of the observability things that have come out recently. So if we look at the monitor tab, a whole bunch of stuff basically from CloudWatch logs and metrics are in one place. So I can look at my invocations, durations, my error counts, all that kind of thing. And I can just have a look at things right in the Lambda console and see if anything that's going wrong. I can see actually the most recent invocations and the most expensive invocations recently just down over here. And I can also see a service map, which is using X-ray traces to be able to show what's exactly going on. And if I was to then select on one of the services, and maybe if it was talking to Dynamo or something else, that would also be represented over there. And of course, I could click on the trace, which would take me directly to X-ray to that trace. So yeah, really easy way, without again having to jump out of the Lambda console, I can get a whole bunch of functionality. So the next thing is, well, what happens if we're actually starting to build functions in your IDE? This is where developers work. I don't even want to handle with that funny console place. Everything is where I want to start in my IDE. So we do have the AWS toolkit for Visual Studio Code, which is what we were using before. And this is just available from AWS for a whole bunch of services. And once that is actually installed, we can see that we've got this new part called the Application Builder. And this gives some information. It's got some helpful getting started guides, so you're actually able to do some installation of the various tools. So the AWS CLI and the SAM CLI and also Docker is a super useful thing to be able to add. We'll be talking about local stack shortly. That's another option that's been added since I've done this as well. So this is a quick and easy way to get started building with serverless on AWS by just clicking on these buttons and installing the tools. Now, I had the tools installed already. If you didn't have them, it's going to prompt you for the information or head you to the page to be able to download those tools. So I've got my tools. I can actually choose a starter template. Let's say we're going to initialize a REST API. Let's going to do it in Python. I'm going to then select a local file folder. And so this is actually going to download a sort of starter package template of a Hello World application with an API gateway. This has got a SAM template, so fully infrastructure as code, with my example application all ready to go to build a little mini microservice, or at least build the application from here as well. So we can see, I can look at the template.yaml. When I open that, this is standard SAM using CloudFormation. There's just some metadata information. I've got an event object it has downloaded as well, which I can edit. And you can also see now this application builder section has now been populated with this, with some quick ways that I can be able to open the template and also look at infrastructure composer. So this is a visual way I can look at my code and look at my configuration. I could click on the details for the Lambda function, for example. I could look at the runtime. I could change the memory and do anything over here. And then that would update immediately within my function configuration as well. What I can do is I can also then jump directly here to my function handler. So here, this is the Lambda function that has basically been downloaded to be able to use. So next kind of thing is I can also use the SAM kind of things from up there. So this is using the command palette just as it was in the console, as it was in the IDE. This is super useful. So the next thing I want to do is I want to then press the button. Next thing I want to do is I want to then build the SAM template. So I can select some settings, specify the flags. I like to have a cache build and a parallel build. It is going to speed it up. I can save the parameters, and I could also choose to use a container where it's actually going to download a specially built Docker container with all the build tools in it, so I don't have to have Node or Python even installed on my laptop. I'd be able to do the whole build. So off it goes, and it's actually going to do a build of my application, and now all the artifacts are ready. Now, of course, I haven't changed this application. I could have changed any code, changed any artifacts, done anything with their dependencies, but basically with one click and setting a few selection options in the IDE, I'm able to now build my code. So the next kind of thing I probably want to do is I want to actually locally invoke and maybe do some debug information. So what I can do is I can, of course, just quickly locally invoke this over there. I can select a local file, so that HTTP gateway event I could use, or the local file which was already been downloaded as part of the template. I can just select that and then add that to the local invoke, what's going to be used. So what I can do over here as well is I can actually invoke it, or I can actually save this debug configuration. So I'm just going to give this a name, and this is then going to automatically create the launch.json for VS Code with all of the settings that I need to be able to use SAM and to be able to use SAM and Lambda for my local invokes. So what I can do is I can go and hit a breakpoint somewhere in my code. So I'm just going to do that on that status code, and then I'm just going to invoke the function. So now, behind the scenes, a whole bunch of stuff you haven't had to do, haven't had to set up. This is then going to download another Lambda emulation environment Docker container. Again, all behind the scenes. It does a quick build beforehand, downloads a good Docker container, attaches the local debugger to that Docker container, and then I can basically live debug my Lambda function that is running locally in a simulated environment. I've got all of the context and event objects on the left-hand side with all the variables, and I can actually then do so I can actually look at that event body from the event that has come in, and then I can actually do some step-through bugging directly in my local environment over here. So you can see I'm building up that return object, display it, and you can see the return object building up over there, and then I can display this. So here I can do loads of debugging locally, and this is a really thing that a lot of people don't think about doing with Lambda. They think, oh, Lambda, it all has to be up in the cloud, you can't do things locally. Even without using a Lambda emulation environment to do that, what is your function code? It's Python, it's Node, it's Java. If you were talking about, say, architectures this morning or anyway, it's just Node code. You could run Node and run your Lambda function with an input file object. You can do run all your testing locally with doing that. This just takes it to the next level that you can actually attach a debugger to it and do that step-through debugging, which is a really helpful use case. So you can see now that I've got some things in the cloud. I actually want to then deploy my Lambda function. So I've got two ways to do this. I can do a sync deploy, which is a quick and easy development deploy that allows me to build my Lambda functions a lot quicker. So I can specify some required parameters to do my build. I need to pick a region. I'm from London, so I will select London. I'm going to select then the CloudFormation stack that I want to use, the name. I'm using a dev stack, and then I can set some of the configuration. So this watch parameter is actually going to watch my local setup, and when any changes are done, it's going to sync that up to the cloud. It does ask for some permissions, and then is going to set that up. It initially does a CloudFormation sync, and then once that has done, it basically says finished syncing the Lambda function. And this is running in the cloud. So now the difference between what we did before when it was syncing back and forth, we didn't have any infrastructure as code. It wasn't doing anything. It was just syncing up it wasn't using infrastructure code. It was just setting up that, syncing up that function, which is not the full thing we want to do. So here we go. I'm then going to remotely invoke this function. I've selected the event object, and I click on the remote invoke, and then off we go. We've got Hello World. This is actually running from our dev stack, running in the cloud, and I haven't actually left my IDE, and I've got the full list. I can obviously go and change that and do Hello Lambda. I just click Save, and that runs a quick build and syncs that function up into the cloud. How quick was that? Even though I'm using CloudFormation, even though I am doing anything to change the function, I'm not having to do a whole CloudFormation deploy. It just has done a sync, and I can do a remote invoke and get the remote IP address. So this is a bit of a shortcut. You wouldn't do this for production environments, but it means you can have the richness of infrastructure as code and that best practices, and also get things into the cloud really quickly, because testing in the cloud can be super useful to be able to test all that functionality. So onto local stack. We've got our gentleman from local stack over here. We've done it. Local stack is a company. It's actually headquartered in Switzerland, so not that far away. And local stack has this amazing service where they can simulate not just Lambda, but a huge amount of AWS services. And the integration, we worked hard, the teams worked hard together to be able to bring this into this Visual Studio environment. And so basically what you can do is you set up local stack, and then the configuration is just set up automatically for you. And then all you actually have to do is just point your AWS toolkit to another region, which is a sort of mocked region called local stack. And then you can run the same deploy. You can deploy SQS, API Gateway, Lambda, Event Bridge, all these kind of things, and it's actually going to deploy it to a mock local stack environment which is running locally, nothing to do with the cloud, and you can test everything locally. Super useful, super brilliant. And so you can see over here, I'm actually looking at the AWS Explorer. I've got an API Gateway, and I've got a whole bunch of Lambda functions, and you can see this CloudFormation output from a deploy from CloudFormation, but not to the cloud, to local stack. Super powerful stuff if you want to do a lot of emulation locally. So we're doing stuff in our local environment as well, but obviously remote debugging is a recent release that came out as well, and this is magic. So basically, I've got a lot of configuration to set up. No, I don't. I just tick on the checkbox, and I can then remotely invoke that Lambda function. And so what it does behind the scenes is actually going to set up a debug session, and I'll tell you the changes it makes to your Lambda function, but it updates your Lambda function then running in the cloud. So what this means is I now have the step-through debugging, and I can look at the event and context object and do step-through debugging, but this isn't local. This is directly to the Lambda function in the cloud. So this can test RDS connections. I can do step-through debugging for things that are connected to a VPC, all the kind of things directly in my IDE. And if you had been paying attention, you can see the IP address of the remote Lambda function is actually an 18 IP address. So I'm not fudging anything here or not lying to you. This is actually running remotely in the cloud. And so there are a couple of changes that make to the Lambda function when you tick on that box. It extends the time out to 15 minutes because you're not going to be able to do a live debug on an actual live running Lambda function in the normal timeout of maybe 3 or 30 seconds you have. Second one is it basically attaches a Lambda layer. This is just a communication protocol, and behind the scenes it actually uses IoT Core. You don't pay for that, that's part of the service. And it uses IoT Core to be able to connect your local debugger to be able to connect to your Lambda function, and that's going to allow that communication, and so that gets added onto your Lambda function. Third thing is to do all of this, it actually deploys another Lambda version, so it doesn't mess up your current running Lambda function, deploys a new version to be able to do this testing, so you don't mess up anything that is coming on as well. Now, I just want to say this is only one of the ways that you can do Lambda function debugging in the cloud. We have a gentleman here as well from Lambda debugging, and that's another whole way that you can actually do Lambda debugging. Slightly different, it's not debugging in the cloud, it's sort of creating a wrapper that goes into Lambda and then runs your code locally. So, it's a really exciting space that there are lots of cool ways that you can debug Lambda functions running in the cloud and running locally. We unticked it, and then let's just stop that debug session. We can see over here that I want to now maybe deploy my production stack. So I'm going to then specify some parameters. I'm going to, my debug is all fine. I'm then going to test a production stack, give it a production name, and that's going to then do a full CloudFormation deploy. It's separate from my development stack, but I've done all my testing, I've done all my debugging. I know my function is going to be all happy in the cloud. So once that is deployed for my production stack, you'll see that my application builder on the left-hand side basically gets refreshed in a few seconds, and then you can see I now have access, there goes to prod, and I now have access from here to all of the functionality in the cloud. I can invoke the Lambda function remotely from over here and do a whole bunch of kind of things. So that is super useful. So I've got my prod stack over there. I can do the remote invoke, select that local file and do that as well. So the next kind of thing is what I can do about the logs in my local environment. So what I can do over here on the, you can see I've got all the stuff in the Explorer, the normal kind of things over there. And you can see I can select the Lambda function, or that's the remote invoke. And then I can also select on the next icon to be able to search the logs. And so this searches the logs that are happening remotely. So if I select on that, I'm able to then do select my region, the logs of all time. And basically then the logs from CloudWatch are then going to stream directly into my IDE. I don't have to browse again to CloudWatch to be able to view that as well. It's a really easy way. Stay in my IDE, I can view my CloudWatch logs as well. And the next part is what I can actually do is I can actually use the live tail. So I can use this live tail. Again, maybe I've got other sources invoking my Lambda function. I set this up over there, just a click, and I can remote invoke it, or I could invoke it via curl or whatever kind of command. And you can see the live tail commands are then going to stream from my Lambda function as it's happening. Again, I haven't had to leave my IDE environment, being able to take advantage of that live streaming. So that's a bit of a quick whistle-stop tour of all the sort of Lambda functionality that's going to be happening. There's a lot more work going on. We're partnering with the local stack crew to do even more things, reinventing around the corner, so there'll be hopefully some exciting things to think about. But yeah, the Lambda team is spending a significant amount of time on trying to improve the developer experience. This is a big thing of work to make things work locally better, and we'd love to hear your feedback on what works, what doesn't work, or what else we'd like to do. So the other kind of thing we've come out this year is the AWS Serverless MCP server. I won't go into a huge amount of MCP, but MCP is basically Model Context Protocol, and it's an API for GenAI that allows a local system to be able to connect using AI to a whole bunch of tools to get information. There are tools and MCP servers from everybody, from Tinybird to Neon Database, Notion. The world's exploding with MCP servers, and you connect them up into your local environment. So AWS Serverless MCP server is part advice, helps you to do all of the local functionality that I did with clicking around and SAM commands, and this just allows you to be able to do that in sort of natural language English. So you set this up basically with a JSON file, so I'm using Amazon Q locally. You set it up just for the sake of time, because I've only got 30 minutes. I'm not going to go through all of the process of this as well. But basically, I could then give it an English prompt. I want to build the backend for a new to-do list application in a new workspace. I want to add, list, and delete to-dos. Would Lambda be a good choice for this? So basically what happens is you run this query, and this is going to come off, and it's going to ask the MCP tool to say, yes, I've got a to-do list application. Would Lambda be a good fit? And it actually comes back, uses the Get Lambda guidance tool, and then comes back with a whole bunch of information whether Lambda would be useful. Yes, in this case it is, because it's event-driven, recommended behind API gateway, and then it has some considerations around cold starts and things like that as well. So this is super useful to just be able to ask questions of AWS. Is this a good fit? Isn't this a good fit? How would you do that as well? And we can extend this to a lot of things. Now, I've got demos for all of these. I'm happy to show you later, but just for the interest of time, these are the English, natural language English prompts I want to put in. I want to deploy the application. Which infrastructure as code tool would be best for this? This comes back, gives some information about CDK and SAM, and then decides what you're going to do. So my next prompt was, please can you create and build this app? And it went off and used the tools to pull down a Lambda function sample, edited that, created an infrastructure as code file for that as well, amended everything to go and do that. And then said, well, can you go and deploy it? It made some mistakes in deploy. It had some issue with the DynamoDB table, realized that when it deployed it had an issue, self-corrected itself, went back, changed the DynamoDB setting, updated it, and it was just basically magic how it just managed to do things. And then I said, well, can you add 5 helpful to-dos? So instead of having to get the curl command, add that in and do that, it did it all automatically. Check the logs and metrics for any issues, and also add observability with Power Tools. And off it went and spent a good 5 minutes adding a huge amount of dashboards and metrics and tracing and all these kind of things, stuff that would have taken me absolutely ages to add myself. So I wanted to show what this looks like, so I said, I'm terrible at front end. Can you write a simple but snazzy front end that I can run locally that then connect to the to-do list application? And so off we go. Oops. And so off we go. Is this not playing? Let's try and work out the buttons. You would think I would know this by now. Oh, is this auto playing? We'll get there. Promise you I'll pretend I know what I'm doing. Whole thumbs, there we go. So, I then install the dependencies because it is running locally. So there's my front-end stuff is all being installed, literally 108 packages that it added, and then I can just run an npm start, and this is going to run my local server, which is then going to connect to my whole backend I've just created in the cloud. This is the front-end it created. I can add some to-dos. You can see I've got those 5 ones I've added, which are stored in DynamoDB. I add another to-do list item, I can add the to-do, and this adds it to a live database. I've done this literally as vibe coding as I could, all using the MCP service to be able to build all of this and to be able to do stuff. So super useful to be able to get information from AWS and to be able to do the whole build, deploy, and lifecycle. All the stuff I was doing in the local toolkit, you type it with English language, and it does. So quickly, we've probably got a minute left. Power Tools for AWS, I've mentioned. Use this really great set of tools for turbocharging your Lambda functions in a number of languages. Serverless patterns collection, it's on serverlessland.com. Whole bunch of infrastructure as code ones. There are over 900 at the moment. So we take community contributions. So the people here as well, I know, have contributed. So they're a great resource. These also link directly into your IDE, so you can actually browse Serverless Land and grab any of these patterns in your IDE. So, some quick tips, we're giving you some info on setting up your local tools, some good advice to get to infrastructure as code quickly as possible, showed you quickly how you can sort of test and debug your business logic, how to move to the cloud and be able to test and debug there, and then also, use the help of GenAI with MCP. So, serverless is definitely faster. We're going to do a lot of work on the inner and outer loops, talking about the console, getting to the automation, how you can do things faster. Hopefully been through a bunch of demos, which are useful as well, and some tools and tips to do things. As always, with the serverless road ahead, we're going to add more fundamentals, improve the developer experience, improve the controls of the experience, and create simpler and better integrations. So that's serverlessland.com, your best site for all things AWS, all things serverless on AWS. And yeah, hope everybody's okay. I hope the coffee kept you awake. A whistle-stop tour. I'm happy to give you more demos and show kind of things, but that's what Lambda can do for you today. And there are other step functions. There's a whole bunch of local stuff. Didn't have time to tell you today. But yeah, enjoy the rest of the conference. Thank you for having me. Oh. I did forget, so if you don't have a Builder ID, super useful to set up. It's going to be even more useful next year when you can sign up for a whole bunch of events. So I'll leave that code. Thank you.
Thank you.
We'll bring it here and you can... Okay. Do you want to take a picture of you?
We have to swap,
yeah.
So if you can, just... Thank you very much.
Cool.
Okay, right. So okay, so our next speaker is bringing a bit of a different type of content. Usually at Serverless Days, it's always dominated by us, but we try to bring in other vendors. So today we brought in an Oracle expert. So please give a warm welcome to Juarez Barbosa Jr.
Good afternoon, everyone. Thanks for coming to my talk about multi-cloud with serverless Java in the Oracle database at AWS, AI database actually now. My name is Juarez Barbosa Jr. I work for Oracle as a senior principal Java developer evangelist. I have over 30 years of experience in software engineering and developer relations. With several different companies, as you can see here, I'm coming from Dublin, Ireland. Actually, today is day 17 regarding my October tour. So yes, I'll be home on Friday, hopefully. Yes, and I focus on Java, 29 years developing in Java, but a little bit of Python as well, cloud, DevOps. I used to be a blockchain evangelist for both Oracle and Microsoft. It's actually my second tenure with Oracle. And I'm a frequent speaker at several technology conferences like this one here, mainly because I work as a dev evangelist. So that's my job. I go to conferences, I organize hackathons, workshops, I deliver meetup sessions, I create live labs, I create blog posts, I write code. Of course, I work for Oracle in the first place, but usually I say that I work with developers and for developers. So if you like my content and if you want to get a copy of my deck, feel free to approach me here at the conference or perhaps reach out to me on social media, okay? And I'm more than happy to share with you. Of course, it's not a talk about my experience and background, so let's get started. This is our agenda for today, okay? I'm gonna talk a little bit about the Oracle Cloud infrastructure, generation 2, by the way. And then move to explore multi-cloud with AWS and also talk about OCI, DevOps, and the resource manager that we have, which is quite interesting because it does not create any vendor lock-in in terms of the way that it is implemented. After that, explore serverless Java, an introduction to Project FN and OCI functions. And after that, I want to walk you through some examples. It's an introduction, of course, but I will point you to some GitHub repositories from where you can get more advanced stuff. Just a quick question, who's a Java developer here? Anyone? Great, okay, all right. And have you heard about Project FM? No? Open source? Cool. All right, so that's good. I think you can learn a thing or two from my presentation then. Okay, so first thing, OCI generation 2, okay? We have this cloud platform. Actually, Oracle used to have one cloud platform called OCI Classic, but in 2017, Oracle decided to design a new cloud platform from scratch, hiring several professionals from the industry, and created a new team in Seattle, and then we started this project. It's a very powerful cloud platform. At the moment, we are the 4th hyperscaler. Possibly you've seen the news about Oracle and partnerships with AWS, but also the other cloud providers. But we have also partnerships with OpenAI, with xAI, and we are part of the Project Stargate announced by President Trump as well. Oracle is building the largest GPU data center in Abilene, Texas, okay? And that's something that I want to highlight. If you are doing AI, Oracle Cloud is the only cloud where you can get bare metal, low-level access to GPUs, okay? Because many cloud platforms, they have it, but they are somehow virtualized. So if you are running CUDA, C++, and all those SDKs, that's perhaps a good option for you. Speaking of the development platform, pretty much all programming languages and SDKs are available for you. Of course, I focus on Java and the JVM-friendly languages, Kotlin, Groovy, Scala, and so on, but they are there for you, okay? So it's a cloud that can accommodate any type of workload regardless of your programming language. And we also work with the main open source, I would say, projects, the ones under the Linux Foundation umbrella, CNCF, Cloud Native Computing Foundation. Speaking of blockchain as an example, Hyperledger Fabric as well. You can see Kubernetes here. The interesting thing regarding our approach to actually having those services as managed services, PaaS offerings, platform as a service, is that we don't create, vendor lock-in, right? Usually we work with the upstream components, the open source components. Of course, we just create some, facilitators. We encapsulate that complexity. We offer you, handy SDKs, APIs, and dashboards, right? But we are not creating mechanisms that will perhaps avoid you from considering, a better multi-cloud approach, right? You can move workloads easily if you start with the Oracle Cloud, and that's our ultimate goal, right? Give a choice to developers and our customers. Yes, I talked about open source. Perhaps if you are a Java developer, you've heard about GraalVM, which is an interesting project created by Oracle Labs in Switzerland, which, by the way, our internal summit and the community summit will happen from tomorrow in Zurich. So I'm going from Milan to Zurich today yet to participate in our summit over there. GraalVM is nice because usually if you compare Java to other programming languages in terms of performance, some people used to say that perhaps Golang or even Rust, are more, I would say, optimized and faster in terms of the execution environments and the general JVM deployments. But with GraalVM, you can just create what we call a native executable and native images, including deployments that target, cloud native, containers, Kubernetes, and so on. And you can achieve perhaps the same performance or even better performance because the JVM is extremely flexible and powerful in terms of allowing you to use switches to go the extra mile in terms of performance optimization, right? Okay, let's talk about this. Oracle AI Database 26 AI. I'll be quick here because I have perhaps other stuff that I want to explore and give you more details about. This is our database. This QR code, actually, if you want, you can just get the developer-free version of it, which is, again, the same database if you go to our cloud platform and decide to deploy it over there. But there's just a subtle difference. It is called Autonomous Database because Oracle started to infuse AI into our database, I would say, years ago. So those recurrent DBA-related tasks like performance tuning and security, patching, index optimizations, and so on, everything is performed transparently by background running AI-supported processes, okay? But at the end of the day, same upstream components. So if you use this database to develop an application and decide to deploy to our cloud, which we have also a free tier for developers, as an example, with 2 instances of this autonomous database with up to 1 GB of storage and several lifetime, always free services. As an example, 1,000 messages, email messages per month on a rolling basis. So each month you get 1,000 more, 1,000 more. So if you happen to have a side project or perhaps, I don't know, you have a startup and you're working on your MVP or some POCs, that might be a good option for you. Okay, the 26 AI database, at the core of it, we have plenty of features. One that I want to highlight is the AI vector search. If you go to Oracle Developers on Medium and if you access the Java tab over there, you will see many blog posts that I created exploring the main Java Gen AI open source frameworks, the likes of Spring AI, LangChain4j. Also, there's a third framework now called the Semantic Kernel for Java by Microsoft, with examples on how to use vector search and similarity search, okay, and semantic search. Because with a traditional relational databases, we used to have SQL NC queries, right? That you can run and have a where clause, and then you have a search key, and usually your result set will reflect, the records that will match the specific search key. But with semantic search, there's something more powerful because now you can ingest unstructured data, basically photos or PDF files, videos, audio, and so on, and create an entity by applying an embedding model. Okay, you create a representation of that entity and the document called vector embedding, which is basically a floating point array, of many dimensions that you get out of that. And with semantic search, then you can actually, I would say, create applications that will not, just retrieve data based on a specific search key, but actually be more powerful in terms of also performing some distance comparisons and similarity comparisons regarding all the characteristics of a given entity as a whole, right? And that will open up actually, I would say, a massive number of opportunities in terms of looking at your business processes and the specific use cases and the functionality, and identifying perhaps the points where you can infuse AI to achieve better productivity, innovate, maybe optimize, eliminate waste, right? In software, we have things like Six Sigma and so on, you know it. So that's a good option for you. Moving forward here, again, many other features for developers. An interesting one, JSON relational duality, a kind of ORM, object relational mapping, a native one, provided for developers as well. You can store the data as relational data, but retrieve it and use it as a JSON data. Throw cache as well, an in-memory cache that is extremely optimized and prepare for mission-critical applications, because when we talk about the Oracle database, Oracle started as a database company back in 1977, and 48 years ago, and we have many, I would say, customers deploying this database at scale for the mission-critical applications and solutions that actually require all the best mechanisms in terms of failover, high availability, and so on. I have no ways to overemphasize it, so again, I recommend you to go and have a look and explore. And all the mission-critical features are here again that I've just talked about. Speaking of multi-cloud and this AI database at AWS, that is actually an interesting initiative and partnership that we have with the main hyperscalers now, including AWS, because maybe if you happen to have a data center with several Oracle databases deployed as part of that on-prem, environment, and you want to migrate to the cloud, but you are running your applications on top of AWS with all the services for all different programming languages over there, including Java, okay? This is a very good option for you, and perhaps a good tool for you to consider and have under your belt, because you can just use the AWS console without disrupting your developer experience. You can provision the Oracle database from the AWS console as a marketplace offering, and that's good because you don't have to actually train your team or seek upskilling opportunities and perhaps paying for specific training in terms of enabling your team to work with another cloud platform, right? You can just use AWS. I'm not going to explore all the specific details here, but just to mention, again, real application clusters, all the capabilities in terms of availability, transparent failover, performance, we have something called a maximum availability, transparent application continuity, plenty of features for mission-critical applications, but it's all about, modernization. And interesting to mention, with this partnership, actually, we have our data centers co-located with the AWS data centers as well, which is a good thing. At the end of the day, we are now talking about this multi-cloud world, right? There's always a requirement for you to use a different service with a different cloud provider, depending on the project. In the experience, again, you can just use the AWS Management Console, purchase the Oracle database from the AWS Marketplace, and you're good to go. Yes, and the database is actually deployed inside the AWS data center. Okay, so we have our equipment and the database and our specific hardware, running inside the AWS environment. And that's good because in terms of data egress and ingress data, and you can reduce costs and save a ton of money because of that. So that's something that might be interesting from a cost effectiveness standpoint. Okay, so again, that's why we are actually being quite successful regarding this partnership. Yes, and in terms of the experience, you can use the AWS tools for all things observability, logging, and manage the entire environment with a common look and feel and user interface. Pretty much, enable a kind of single pane of glass for your operations. Okay, so these are the two options. Primarily, Exadata service on dedicated infrastructure, perhaps the most expensive one, but of course, the one with the number of enterprise features enabled and available for you to, I would say, create the most elaborate deployments. And we also have the autonomous database on dedicated as well. I will walk you through the Java code shortly, and then after that point you to some GitHub repos, but also show you how you can provision the database. 30 minutes maybe is not enough for me to do everything live here. I'd love to, but it is just actually a walkthrough. But all the pointers, all the links, all the technical resources are there for you. Code, blog posts, documentation. For this service, interestingly, you have fantastic documentation provided by Oracle and also by AWS. Yes, and if you compare Exadata, traditional IT on-prem, where you have to pretty much manage everything, right? So the entire IT governance is on you, and that's a problem, not so easy to do, okay? Because all the perhaps non-functional requirements and concerns, you have to pay attention to those. If you are using open source as an example, you have to really check the libraries and the frameworks that you are using to avoid, security holes and breaches and possible cyber-sec attacks. With Exadata, you have some level of freedom in terms of the management and access to the underlying components, but the autonomous database, essentially you just focus on the application at the top and, of course, managing data. So that is perhaps the easiest way for you to adopt this solution regarding Oracle database at AWS. Of course, we are living this multi-cloud world, so we also have partnerships with the other cloud players, okay, which are also being extremely successful in terms of adoption. And even if we, okay, as a shop, a software shop, I focus on one technology or two, or perhaps two different solutions. At the end of the day, at some point, you might need to also create maybe redundancy and failover using a completely different cloud platform, right? You've seen the outages and things that happened recently, so it's always good perhaps to have a strategy where you can redirect your traffic to a cloud platform that is totally different. Yes, speaking of DevOps, because it complements the play regarding functions, we have OCI DevOps as well as a service and the resource manager. What I want to emphasize here, our DevOps platform also in service is extremely flexible in terms of what you can use. As an example regarding the external repositories, you can see GitHub, GitLab, Bitbucket, and so on, okay? We align, again, with the open source tools and the de facto tools like, Ansible, Terraform, PowerShell, Chaff, and so on. This is the typical workflow regarding deployment in a pipeline. I'm gonna skip this one quickly and just emphasize that our resource manager is a service. Basically, we have a concept called stack, and this stack is only about an aggregation of Terraform scripts, okay? And we adopt Terraform as the tool at the core of this service. We also have the initiative called OpenTofu, which is easily adaptable as well. You can see Terraform here, and this is the resource manager, and I talked about the stack, okay, but essentially it's just about using Terraform scripts. Serverless Java. Project FN, it's an open source project, as you can see here, with available components not only for Java, but many programming languages. You see Go, JavaScript, Python here, Ruby, and C#, right? We created this project as an open source one, but it is the core component of our managed functions service called OCI functions, right? Which is the next slide here. It's extremely easy to work with it. We have a CLI, basically the FN command that you can use along with YM file for the specific configuration and description of your application, and you can easily deploy, test, and deploy locally and also target the cloud. And combining that with DevOps, the resource manager, and of course Java, we can say that this, I would say, combination is a killer one in terms of serverless applications. OCI functions, again, you know, it's managed functions as a service, of course, right? We are talking about PaaS.
Specify the app name, you know, with the annotation that you want to use, and actually you point it to the specific subnet. You initialize it, okay, with the target runtime that is actually Java as a programming language, and with that you change directories, and then you can start to actually configure your application, okay, so you can persist this to your local server or environment. Of course, this is just for learning purposes. There are plenty of different ways that you can do things like that. Like when you configure security, as an example, I'm talking about the key KMS, the key management service here. And the Oracle database has something interesting because we also implement as part of Autonomous something called MTLS, okay, a mutual TLS. At the end of the day, you can use this wallet, and the wallet is actually one archive with the public key infrastructure artifacts, you know, certificates and the Oracle configuration files, and then the client and the server will be able to authenticate against each other. So it's an additional level of security as well. We are talking about mission-critical applications again, right? After that, of course, with Java, just the usual Maven dependencies. So you can see a couple of jobs here for the API and the runtime regarding Project FN and the driver for the Oracle database, and that's it. We also have a connection pool. If you are a Java developer using, as an example, Spring, Spring has a connection pool called iQuery CP that you can easily override by using the application properties in Spring or the YM file with you know, some 5 or 6, 7 additional properties. Override it. UCP, Universal Connection Pool, is extremely optimized. You know, decades optimizing UCP as a pool. And you can also use it not only with the Oracle database, but with open source databases as well, MySQL, Postgres, and so on. So I would recommend
you to have a look at UCP. The jar is not here, but it's just one additional jar as a dependency. This is the function code, okay, so I just retrieved some details from my environment, no tricks here, and I have the class name for the data source, which is a pooled data source. You can see JDT pool, Java database connectivity. After that, I implement the function, and I start the data source, right? And this part is kind of abstracted, but the repos, they have the full details and a couple of blog posts that I added as well. And with this connection pool is interesting because when you create it as part of your constructor, we know that with serverless, some of the challenges that we have is the code startup, and warming up, and perhaps reusing access to resources like database connections, right? But if you have a small application with a one-to-one, perhaps mapping to your target database, usually if you do the database connection step as part of your Java constructor, and the container might get reused as part of a pool of containers, but that's not 100% guaranteed. But we have actually one mechanism called DRCP that sits inside the Oracle database on the server backend database cloud that implements a full-fledged connection pool as well. And with that, you can achieve extreme performance and concurrency. Okay, I'm going to talk about that later on. And yes, after that, I just deploy the application, fn deploy app and the application name, and then I can invoke it, test it locally, and you can see the output here of my function. That's actually a simple database query, which is actually, oh, I forgot to add it, maybe? Oh, no, it's here. Yes, you can see the query here. Sorry, I advanced too quickly. So it's just a simple query, of course. So this is just to show you how it works. But then, of course, you understand functions, right? So as part of your function, you can embed any functionality. Maybe better to use short-running, transactions, but you decide. And just talking about hot database connections for serverless functions, the first scenario, to avoid the connection creation and tear down and all the problems with warming up that I talked about. And we have the one-to-one relationship regarding the container side or the function side and the database. But the second mechanism, which I have all the links and a blog post explaining everything, I do recommend you to have a look. Maybe even if you're not using the Oracle database, it's good for you in terms of ideas and approaches, strategies, and design patterns. You can use the RCP, and the RCP will implement, pooling on the database side. You upload it to the database side, and with that, you have no problems in terms of the allocations that take time, and perhaps might impact the general performance and perception in terms of degradation regarding the experience by your customers, okay? All the links are here, Project FN, Functions, Database 26 AI, DevOps Service and Resource Manager. This blog post by my colleagues in the US is interesting. What is multi-cloud? The documentation for database at the AWS and other cloud providers as well. And the examples, how to connect using the wallet that I talked about, security and MTLS, okay, mutual authentication, and two different examples here with Hello World functions with Java, but the REPL actually has examples with all the other programming languages, and our architecture center where we have plenty of solution books that you can easily just, reuse, out of the box. So last thing here, I have, I think, just a couple of minutes. First, I want to show you Project FN. If you go to, I think, tutorials, you will see Go. I can actually maybe increase this font here a little bit. Yeah, so you can see that, of course, Java is here. Okay, I'm a Java developer, developer evangelist, but we have Go, Node.js, Ruby, Python, and even C#, okay? So we are friends with the Microsoft ecosystem as well. Functions, the documentation, okay, extremely complete and, I would say reliable, okay, because this service is around for, I don't know, years now, perhaps a decade. A quick start on Cloud Shell, so all the quick starts here, sample functions. If you go to this rep on GitHub, you will see plenty of examples with samples here with Python, but also Java and, Go, as you can see here, Ruby. Everything is available for you. Observability, of course, that's covered as well. The specific ways that you can create functions and invoke functions, role-based access control as well. Security is here with AAA authentication, authorization, auditing, everything. Function management integration, okay, which is always a requirement for enterprise systems. And the FN project, the open source project, support developer tools, including the CLI. And the example I talked about, the first example, again, it reproduces the steps. Basically, I just create a database table, and then I can run fn create again. The complete example is here. You can just go and download the zip or clone this repo or fork it. Create a function, you move to the directory, you create a config, you download the wallet, again, MTLS, and you configure the security policies. That is something required by the Oracle Cloud, okay? But if it is extremely similar regarding the other platforms, okay? At the end of the day, if you are good working with one cloud platform, you can just quickly get up to speed regarding the others offerings. And invoke, this one here is a little bit more elaborated. It also uses the autonomous database, but a specific type of it, we call it transaction processing, that is for OLTP workloads, and it also, I would say, as a highlight, it has examples. Oh, this is tiny, actually, sorry. Maybe this. But same steps here. Okay, testing as well, how to configure the database connection and the wallet. And this one, you can use Terraform. Okay, so there are some examples with Terraform here. In terms of provisioning, you can use Terraform to provision the database. We did AWS, but of course the console option is available. So a quick step-by-step guide here regarding this blog post, an explanation of the network and how it is deployed in terms of the integration. And the nice thing about this encapsulation in Oracle database at AWS, because security federation and all the network peering and VPN configuration, the entire complexity is hidden, okay? We just, I would say, 3 or 4 steps using a wizard as what I have here, okay? Basically create the Oracle database network, active data infrastructure, the VM cluster, and the container database, and then that's it, okay? You can see it's just about, selecting some few options regarding each specific step, and then you have the database running, provision it from AWS. I'm gonna skip the one for Exadata here. And yes, in documentation, as I said, we have the documentation on the Oracle side, but AWS also has everything there for you. So again, if you are working with a project where Oracle database is the database, or if you have an on-prem system and have plans to migrate that to the cloud, again, this might be a very interesting tool to have under your belt, okay? Everything is documented. Pricing is easy as well. You basically get charged by one side. And I think that's pretty much it. There are just maybe 2 or 3 things that I want to talk about here quickly. Yes, we also have something called Oracle Live Labs, over 700 workshops, free workshops. And you may think, okay, but this is about Oracle technology. No, we have Java, we have Python, we have JavaScript, we have Linux, we have Ansible, Terraform, of course, Oracle Cloud and Oracle Database as well. But free workshops, go to developer.oracle.com/livelabs or oracle.com/livelabs, and you will see the content over there, okay? Again, it's free. Second thing, we have this program for distinguished community members called Oracle ACE with 3 different levels, Associate, Pro, and Director. Actually, there's a new apprenticeship level now that has just got launched, as far as I remember. But anyway, if you are, a meetup organizer, a blogger, or an active community member, and you are interested in becoming an Oracle ACE, feel free to approach me. We can have a conversation, and I will understand how far you are in terms of your contributions. And the good thing is that, of course, it will mean, a closer collaboration with Oracle, access to several versions of our products and services, alpha and beta, and if you progress towards the director level, Oracle may invite you to participate in conferences and deliver presentations to customers at our flagship events as well, like Oracle AI World that happened last week in Las Vegas. And depending on budget, of course, right? Just a disclaimer here, but Oracle might pay your flight tickets, hotel, so it's a good opportunity for you. It's a win-win situation, right? For Oracle and for you developers. Last thing, again, we have the Oracle Cloud infrastructure and the free tier with database instances that you can create and several lifetime services that you can use for your side project or your MVP or POC, whatever. I think that's pretty much it. Once again, thank you very much. I hope you learned a thing or two from my talk. And I'll be around if you want to. Thank you. Thank you very much.
Thank you. We'll be back at 4:30 after the coffee break.
Thanks again.
Welcome sight it is to see you. All I want is to be with you, honey. When you coming home, seeing you again is a welcome sight. Seeing you again is a welcome sight. Let the sun shine down on the goodness of each other. Constantly in awe and wonder of all the little things that make up the magic between us. Seeing you again is a welcome sight. 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 Seeing you again, seeing you is a welcome sight. Is a welcome sight. Seeing you again, seeing you is a welcome sight. Is a welcome sight. A welcome sight.
turn up, we still got the music loud. The only way we're gonna get through it. So don't nobody go stop the rock hitting. Leave the fever outside your cabin. Seize the moment, reach out and grab it. If we're gonna get higher, set it on fire. It's now or never. If we're gonna go crazy, let's go together. Even if we lose our heads, it's alright 'cause we got friends. If we're gonna go crazy, let's go together. Look up, look up, look up, look up at all of that blue sky now. There's a piece of it for everyone to do what they want with it. Live up, live up, live up to who you know you're meant to be. I know you got the invite, 'cause we all got the invite. The fever outside your cabin. Leave it and go! Seize the moment, reach out and grab it. Come on, reach out and grab it! If we're gonna get higher, set it on fire. It's now or never. If we're gonna go crazy, let's go together. Even if we lose our heads, it's alright 'cause we got friends. If we're gonna go crazy, let's go together. Let's go together. You and I, we got all the time. If we're gonna go crazy, If we're gonna get higher, set it on fire. It's now or never. If we're gonna go crazy, let's go together. Even if we lose our heads, it's alright 'cause we got friends. If we're gonna go crazy, let's go together. If we're gonna get higher, set it on fire. It's now or never. If we're gonna go crazy, let's go together. Even if we lose our heads, it's alright 'cause we got friends. If we're gonna go crazy, let's go together. Let's go together. Let's go together. Let's go together. Let's go together.
I know myself. When the moon comes out, there's nothing else but you and the night.
Ma quindi, perché vorresti venire a lavorare in B Sharp? Cloud. Ho sempre sognato di lavorare sul cloud.
La sensazione da subito è stata proprio quella di avere dei colleghi in più, che erano più senior di noi e che ci potevano dire tante cose interessanti.
Tante persone che si sono rese disponibili ci hanno aiutato, hanno tradotto le nostre idee in tecnologia in primis, ma soprattutto in step di avanzamento, e quindi da un'idea è diventato un progetto.
Sono partner di AWS e quindi sono bravissimi.
Ho come la sensazione di aver dimenticato qualcosa.
Se l'hai dimenticato, allora non era importante.
Hanno tutte le certificazioni che servono, e questo che cosa vuol dire? Che per esempio per noi come startup si occupano di tutta la parte di infrastruttura, noi non ce ne dobbiamo occupare.
Quali obiettivi? Ne avevamo troppi. Avevamo proprio una visione di startup in cui, ok, non ci sono competitor, ok, non ci sono realtà che possono fare quello che facciamo noi, ok, noi siamo più belli, quindi lo faremo meglio di tutti.
Momento.
Riuscite a capire le esigenze e poi a tradurle effettivamente in risoluzioni di problemi.
Right, so for our penultimate speaker, we have another AWS expert, a member of the community, a man who has worn many hats, from senior developer to start-upper to, at this point, speaker many times. Please give a warm welcome to Walter Dalmut.
Thank you so much. Hi to everyone. I very quickly present myself, just a moment. Oh. Sorry. Okay, very quickly present myself. I'm Walter Dalmut, I'm a solution architect in Corley, and Corley is a corporate in Italy that is 100% focused on AWS building blocks. So we provide consultancy services for AWS. So what about today? Today, we want to design and realize a real-time application without going crazy with WebSockets. So in order to do that, we want to focus on AppSync from AWS, Cognito, always from AWS, for creating a real-time, secure, and scalable GraphQL API. It's a very simple task. We will go through different things. And first of all, when I start preparing the talk, I just want to reply a question. This is why GraphQL plus real-time. And this talk is somehow boring, sadly. So I tried to be funny, and I try an idea to present something that can reach some attention. So I want to say that the title is this one. And for doing this, I looking for something, and my first idea is this picture. And for having this picture, I have to put the text in the picture. And for doing that, I want to use, I said, I don't know how to use, I insert text in the picture. I don't want to use GIMP, so I try with generative AI. So I prepare a question, and can you generate an image for Dawson Creek? This is a very famous meme. So he replied to me, I can do it. Do you want James van der Beek? So yeah, go on. And then he said, I cannot generate because the copyright problem. And if you want, I can create another original character. You want to proceed in this way? And I said, okay, I ruined everything, and it generated this. And this is the original movie. So it's a very, very strange word. And aside that, why we want to create real-time GraphQL APIs, just because we want to go out the limits that we inherit from REST APIs. So starting with REST is very simple, but it's hard to scale. We have a lot of endpoints, and every client needs slightly different data. There are a lot of reasons why we want to go with GraphQL. My favorite probably is overfetching or underfetching, and now we have real-time updates. So we can work with real-time also with REST APIs, of course with WebSockets. We're also using SSE, so server-side events is the name. So there is a lot of suitable ways to do real-time in application using WebSockets, also in REST. But GraphQL is very useful because the client can reach what the data he likes or he needs, and a single endpoint replaces multiple REST endpoints. Is a very strong typed and is very, very beautiful and works great across web and other technologies. So why AWS for GraphQL real-time APIs? So because the biggest challenge, in my opinion, for real-time application is working with real-time at scale. If you try to scale WebSocket, is not a very simple task. It's not the most complex thing in the world, but it's not very simple. So AppSync simplify all the generation for the GraphQL endpoints. Also, the scalability effects are completely handled by the service itself. So we can leverage AWS in order to have this infrastructure that can lever the scalability that we need without going crazy with the scalability features. What about the pricing? It's a serverless. So we can reach a pricing that is dedicated for serverless application. So okay, of course, you have to check always the pricing page from AWS, but it's a $4 per million queries and data modifications, so the mutations. And for real-time updates, when we reach the subscriptions, we have to pay $2 per million real-time updates. Every single client counts as an update, but it's $2 per million and 8 cents per million minutes of connections. So it's a very interesting pricing page. Another thing is that AppSync can work with multiple resolvers. Resolvers are databases, are Lambda functions, HTTP, so REST APIs, for example, and so on. So we can have a single component that is AppSync, and we have multiple resolver in a single AppSync in order to leverage other elements. Another interesting thing is that GraphQL provides also data federation, so we can have multiple GraphQL endpoints as microservices, for example, and we can work all together in a single dedicated AppSync endpoint. So we can do a lot of things with resolvers. Another very interesting thing is that AppSync is integrated with OpenID Connect, and for that reason, we can also leverage another serverless component from AWS, that is Cognito, in order to handle and provide the authentication, because it's based itself, again, on OpenID as the front end, and works with multiple other identity provider as backends. So, for example, OpenID Connect, OpenOut, or SAML. So AppSync can be also protected and secured by JWT tokens in a very simple way. And for that, we can bring everything together, and we can have resolvers, for example, a database, and then we can have the authentication based from Cognito. So it's a very simple architecture, and we can leverage resolvers in order to obtain data. We can have a single endpoint from the GraphQL technology provided by AppSync, and we can leverage security and authentication authorization with JWT tokens using AWS Cognito without managing the infrastructure. So this is our goal, and this is our goal for today. Thanks to AppSync and the integration with GraphQL, we can also working with some sort of labels in our schema, the GraphQL schema that we have, so we can provide and simplify all the API generation that we want to work with. We have 3 dedicated resolvers for AppSync. One, of course, is mapped directly other AWS services like DynamoDB, OpenSearch, or HTTP APIs, and so on. We can have Lambda resolvers in order to invoke Lambda function for every single call that we made to AppSync, and of course we have the freedom to do whatever we like. And then we have pipeline resolvers, so chain multiple steps in our request for pre-processing, validation, aggregation, for doing a lot of things. So for example, if we have multiple source operation or business logic flows, we can work with pipeline resolvers. So those are the elements that we want to use. So what we want to create together today in order to see how simple it is, and remember, it works at scale. So it works from one single request to millions. So what we want to create a very simple application that we bring here, and we want to test out real-time elements for the application. So when I create, try to create a bigger elements, we have a mutation update machine here, and then when we play, we want to update something in a web page. So first of all, we have to authenticate, because we said there is an error 401, unauthorized, or forbidden, no, unauthorized, sorry. We have this problem because we have to log in. So if I go to my application and I log in this application, sorry. Then I will see an application. Sorry, it's very simple, but it's just to work with. And then I have also 2 applications in the test web console that AWS provides for us. So I try to log in also here. I have to select my Cognito client. Then I can log in, and I place credential. Of course, if it is federated, it works with federation and so on, everything that is provided by Cognito as a service. When now I go there and I update the status from not running, it is not running here. If I update it to running, of course, in real time, we have running here. If I place another, sorry, oh my God. Oh, sorry. Oh, no, sorry. Another response, and I go play. Then we have another response here. It's a very simple page. It's terrible from the front-end perspective, I know it, but we just want to go deeply in how simple it is to create it with AWS Cognito, AppSync, and then we want to manage it in infrastructure as code. And for doing this, we also focus on Terraform. Okay, in order to have a replicable ambient environment, sorry, and so on. So this is what we want to create. So our building blocks are AppSync, Cognito, AppSync for GraphQL, Cognito for the authentication. Then we have DynamoDB as a database, and then everything is secured by EM roles. Every single service discuss with each other with roles. And then also everything is secured by JWT token provided by Cognito. First of all, this is our main Terraform model. And because we want to leverage 4 technologies, the first one is the Cognito, another module should be the database, another one is the AppSync, and another one is the roles that help other services to work together. Those modules just provide variables to the implementation. But this is our main Terraform file. It's a very simple, 4 modules, just this. Then the most important things that we have is the AppSync module brings 2 parameters. One is the Cognito user pool. Another one is the DynamoDB table, because in this example, we leverage as a resolver DynamoDB. So what we have for the GraphQL. So if I go in the AppSync module, what we see, then we have the connection with the user pool. I think that, okay. We have the connection with the user pool, and of course, we have the schema for the GraphQL. So it's very simple. We want to the authentication, and we want to leverage a GraphQL schema. Then how the GraphQL schema is done? Of course, in this example, I work with the machine. There is an object that I want to store in database. And of course, we see that we are able to do queries as GraphQL. We can create mutation, always for GraphQL, and then we have subscriptions. And subscription have a very, Subscription have a very interesting keyword, is AWS subscribe, and we can, in this way, connect the real-time operation. So with AWS subscribe, we can work with mutations. So the add machine mutation is connected to a subscribe, and the update machine is also connected to a subscribe. So it means that when someone calls those two mutations, we can subscribe to that updates, and we can receive updates on our behalf. So how we can connect AppSync DynamoDB? For connecting resolvers, we have to create a data source, a DynamoDB data source for the module AppSync. And we just have to connect also methods. For example, for the query get, we have request files. So we have to map for a database, we have to map request and response. So imagine to have AppSync, you have to understand how do the request to DynamoDB and how the response for DynamoDB should be returned to our customers. Why is that? Because, of course, we are discussing in GraphQL language as input, and we have to reply as GraphQL language as output. So we have the database mapped, and then we should have a resolver that explain to AppSync how to convert requests that I made to DynamoDB and responses that I get back. So those files are operated in this way. So those two files, request are velocity templates, request and response. The request file, so this one is a request file, an example of request file. Because we are getting a single object, we should call the get item from the AWS SDK for DynamoDB. If you know DynamoDB, you know that there is a method that is called get item. And I have to pass as a key, there is a parameter, this function, a key with the ID, and the ID, you should get the ID from this parameter in the context. And essentially, if I see the response, I have to say that the result that you get from DynamoDB should be converted to JSON and replied back to AppSync. Just because the response that comes out in JSON from DynamoDB is the same one that GraphQL can handle to our customers, because every single column from DynamoDB is mapped out to our customer. And the most important thing for the request is that effectively we map operation from the SDK and parameter that we bring to the SDK. It's very, very simple. So if I want to listing elements, I have just to add another resolver. There is a query list, and then we should work with the list machine, and we have two templates, also one for request, another one for response. Is not a file in this case, but it's just a string placed there. But you see that the result items, there is effectively what the SDK from AWS presenting to us is the element, the items that is returned directly to the customer, but we have to watch what is inside the velocity template for the request. And it's just the operation scan. And if you know, if you use DynamoDB and you use the method scan, you scan the whole database or the whole table. Of course, it's quite risky because you have to scan the whole database, incurs a lot of costs and a poor performance. But because of all methods are mapped, you can do a scan with a filter. And this kind of expression is the same expression that you lever when you work with DynamoDB SDK directly in your software. So it's just a mapping of operations. Of course, using the scan in an operation in an API is not a good idea, because the scanning of the whole table, or you know for sure that you have 10 elements, so the scan is not a problem at all. It is the right method. If you have a lot of elements, the scan method is a problem. So the only thing that you have to do is change it with a query, because you're creating index in the table, and then you have to prepare the expressions. So if you want to do a query and you want to filter by authors, so you bring expression, the author, so there is an index on the column author, and the author value is something that you get from the context. So maybe in your GraphQL you have a query that says that the author is equal to something, and you bring to the query parameter that leverage the index, so your query is also with a good performance. If you want to work with limits, if you want to work with next token, of course you have to do this. And the scan index forward to, it means there is ascending technology. So you want to work with ascending methods. So, and of course, your response should be much more complicated, because if you paginate elements, you have to paginate with the database technology that you have. And in DynamoDB, you cannot use page 1, 2, 3, 4, but you have to move with next tokens. So you have to bring also next token to your client, because of course, the next token should be the next page that you scan, that you query in reality. So everything is connected in this way in GraphQL. When you have a resolver like DynamoDB, you have just to create a new resolver, and you have to say that when you want to do something, you just have to work with DynamoDB as data source, and then you have to prepare your request. And your request for creating objects is the method putItem, and then you have to bring the ID, and you have to put the attributes. In our case, there is an ID, there is the ID of the machine, and then you have the name and the status of the machine. It's very, very simple. Every single method is mapped in this way. If you want to update, okay, again, you have to do the same thing, and then, of course, the update is the update item. Then you have to put the expression. So when we update also the name and the status. That is what I designed. This is not very clever, because maybe you just want to update the status, but it doesn't matter in this moment. And then you change the variables here, and then you can grab from the context all the elements that we have. So it's very, very simple. Also, we have the condition, because, of course, you have to prepare this, but we have to suffix only for the IDs that you bring in the update method. So it's very, very simple. And the point about how the JWT works in AppSync. Of course, we have the Cognito module, and the Cognito module is prepared in 3 things. First of all, the user pool. So where my users are listed and create signups and so on. Another element that we want is the front-end application. So because it's based on OpenID or OpenOut, we have to create clients. And my clients is my front-end application. So this is my front-end, and I can bring that I want to use with scopes, email, OpenID, profile, and so on. So the classic OpenID mechanism. And then we have to create the front-end. In order to reduce the development of the login page and so on, we can leverage the provided UI from Cognito. So it's very simple, just 3 steps. And then we can move to DynamoDB. How can I create a DynamoDB table using Terraform? Just prepare the resus, and I have the DynamoDB table here with a name and different paper requests, so it's 100% serverless. So I pay for every single request that comes through the database. And then I can also prepare indexing. In this case, those arrays are empty, so this 4 doesn't generate anything. But effectively, it's very, very simple. And I have created also the module for the DynamoDB. It's super simple. Of course, there is a little bit of code that we have to deal with. But of course, those are the main building blocks that we have to create. One for the GraphQL, another one for Cognito, another one for the DynamoDB table that store our data. As you can see, there is no elements for the subscription. So we analyze how we can get a single element, how we can list elements, how we can add elements, how we can update elements. There is no information about subscriptions, because the only information that we have bring in the equation is AWS subscribe, when we create the subscription in the GraphQL schema. Other elements that we prepare in our Terraform models are methods and techniques in order to connect building blocks together. How I can have data in DynamoDB and reply to multiple queries that I do with GraphQL endpoints. So this is the only thing that we have prepared. Is a classic and normal backend procedures. It's just prepared in Terraform templates. Of course, don't worry. You have an open, public repository on GitHub. I have the link at the end, so you can get all the code or you can try yourself. So, where subscription came in place? In the front end. So, we have to handle, for the front end, how we can handle the user authentication. For us, is provided by Cognito UI. So instead of creating a login form, then checking password on behalf of the backend and so on, we can leverage, of course, the Cognito default web pages. So our front end redirects to Cognito user interface. Then we can customize, and there is a new ways today to have much more flexibility in Cognito user interfaces. But effectively, we can leverage all the authentication procedures, sign-ups, and two-factor authenticators, and so on. We can leverage directly Cognito as a service. There is no code for implementing the login procedures. Then, what about the front end? The front end, I'm sorry, is written in Backbone. There's a very old framework, but I never work in front end, sorry. But I just want to find something very simple and how we can highlight the simplicity, how simple it is to implement AppSync and JWT tokens with Cognito and integration with the backend. And for doing that, the only thing that is very important is that the first thing that we have to do is amplify configure with some configuration file. Those are in our index.js file, the only two commands that are truly important. Other stuff is setting up the framework, the front-end framework, for working with the technologies, but we have these two calls that are very, very important. Amplify configure and import the configuration parameter that we bring here. That is a JSON file and is effectively divided in two pieces. One is the authentication, and the authentication is based on Cognito. This is my user pool. This is the pool client ID. Okay. I'm sorry. This is the user pool client ID, and those are the login with command. So login with domain, this is the domain UI provided by Cognito. I just place here the domain Cognito, and then I have my OpenID Connect scopes. Then I have to redirect sign in. When everything is sorted up, when I made my login, you have to return back here. Is localhost 1234, that is where I have the page locally. Then you have to call the method callback. So when the login is done, return back to the callback method. The second things that we have is API. I want to use from API GraphQL, and this is the single endpoint provided by GraphQL, and the default authentication mode against GraphQL is the user pool. So this user pool participates with this API, and this is the configuration. So from the front-end perspective, those are the only two elements that I need to work effectively with this technology. Just check the second page. Okay? What is important in this script? Is important this one. When the framework starts, the first thing that we have to call is sign in with redirect. So it means that if there is no authentication in place, you have to redirect to the Cognito front-end login page. So when the framework starts, the first thing that it reaches is checking by itself the fact that we have a token. If we doesn't have it, immediately redirect outside. And the second thing is routing. When the callback method is reached, you have to go in the callback function. And the callback function is written horribly, but just for the sake of understandings, we have to fetch the authentication session. And if there is a session here, now you have to return back to the home page. So you can go to the home page. So if you are in the callback page, and there is a session redirect to the home page. When you redirect to the home page, of course, reach the initializer function again, and because you have the token, now you can start the application correctly. So you can navigate the application and so on. So sign in with redirect, go outside to the Cognito page, then fetch when you return back to the callback, so the session is generated, you can fetch the authentication session, and then return back to the home page, and this function is no longer called because you have the session. How I can get things now that I have a token and login is well done, everything is sorted up? How can I get things from AppSync? That is very simple, it's just GraphQL. So I can prepare a query, for example, list machines, and list machine, what you have to do? You have to generate a client. Generate a client comes from the AWS Amplify SDK, so the official SDK from AWS. So you can generate the client, and then you can say, client GraphQL, I want to do a query, list machine query, that is this one. So this is a very normal procedure. And automatically, the JWT token is presented in the request. Go to AppSync, and AppSync sees the token, and the token allows the call. AppSync sees that the resolver is DynamoDB, it goes to the DynamoDB, create the query, and so on, and this is everything that we have sorted up in Terraform before. So it's very, very simple. And finally, we are here for the real-time section. So the real-time, how it works. First of all, we can create a service, an object in JavaScript, and our object can have a method, that is a start subscription, with two parameters. One is subscribe, another one is onClose. So what we have to do, always with the GraphQL client provided by the AWS SDK, we can create a query that is a subscription on update machine, that is the same that we have created with the AWS subscription label that we have added in our schema. And then we want to say that on update machine, ID, name, and status are the variable that we want to see, and we can call, on this method, we can call subscribe. And we can pass to this subscribe the parameter subscribe. There is no surprise, there is a callback, is a function that we will use later. And on close, we can pass the subscription. So this subscription is passed on close. It means that when we want to close the subscription, we have the object and we can close it. Okay? So when we use object, so machine service dot start subscription, we pass two functions. We can connect to the subscription in real time, so we can establish the WebSocket connection, and then on closing, we can also have the object that we have opened, and so we can close also the subscription correctly in order to stop the cost connected to the minutes of connection that we have. What about the start subscription? So, as mentioned before, machine service start subscription, we have to pass two parameters. One parameter is an object with a property that is called next, and next is a closure, is a function that brings data in here. And of course, the most important thing is just this. So when we start a subscription, we pass this object, and this closure receives data every time the machine is updated. So when this method is called, data on updated machine is the data updated. So if we console log the data, we see the JSON object of the updates that is made by someone on AppSync. So this is the complexity of the subscription with AppSync and GraphQL itself. Everything else is just updating the page. So there is a model that I want to update, and there is a view that I want to refresh, and so on. But the only thing that is really important is this. So I have to receive this event every time someone updates the object. So the second parameter is onClose, if you remember from the previous slide. And the onClose method remembers the subscription in this object in order to close it when I close the connection. So this method is called when I want to in order to close the object when the time is come for closing the object. And that's it. If we watch what is happening, so maybe I can also open up the network. I go to the sockets. Okay. Sorry, try to GraphQL. This is the socket that we have. So when we're doing something, as you can see here, oh, sorry, it's very, very small. Try to create a bigger presentation. But as you can see, I received this message in real time with the payload data on update machine. And here you see the object. It's very simple. Everything is working at scale. Everything is managed by AWS. It's 100% serverless. We just have to work with it. We just have to do the things that is very valuable, is modeling the data, engage with resolvers. There are resolvers that is very simple, like DynamoDB, because everything that is mapped. So for example, if I want to create a CRUD API, is really, really simple. I just grab AppSync, I create a resolver as DynamoDB. Every single object is mapped very easily in listing, in get a single element, in creating and updates is very, very simple. And I can have also updates in real time for every single entity they have there. If I have custom logics for mutation and so on, I can leverage on Lambda functions and so on. Everything works at scale. So it's very, very effective, is very quick to bring it on, and so on. So it's super, super effective to work with. Of course, because there is a lot of code, you can also check my GitHub. There is a repo that is called ServerlessDays, and you can grab all the codes. You see that it's divided in two folders. One is infrastructure, where you can see Terraform modules. Another one is front-end, and you see the application. Of course, I don't expect that anyone knows Backbone.js. There is anyone that knows Backbone.js? Oh, the only one is very old. But the only things that is very important are those methods. So as you can see in the front end, we have really 4 or 5 things to remember. That's it. You can bring it in every framework you like, and you can start it very, very quickly. Of course, thanks to AWS and the partnership that we have with AWS, we can also try to help you to speed up your proof of concept, your projects, everything. We can try to pitch your project with colleagues from AWS, and we can try also to have fundings from POCs. So if you want to discuss it, we cannot promise fundings, of course. But if you want to try, I do all the pitches for you with AWS for your projects. So you just have to reach me, send an email to me. We can try to discuss your projects, how you can accelerate with AWS and so on. And we can try also to reach colleagues from AWS and try to leverage some fundings. Okay? It's not a promise. I cannot promise it, but I can try. I can promise that I can try it, to have fundings and accelerate your project together with us. Thank you for listening. If there is any questions, thank you. Thank you. Sorry for the rush. If you have any questions, just find me. Sorry again. Thank you. Oh, sorry.
Oh, can you hear me? Yeah. Okay, just 5 minutes to collect all the people from the other room, from the other track, and then we are heading to the final keynote for today, and then just a quick keynote remarks, and we are giving away the prizes according to our leaderboard. So just a couple of minutes, 5 minutes, no more than that, and let's collect all the other people from.
Let's play something right. I know a place we can go when it all feels too much. Moving our bodies, it takes us places we can't touch. Don't
Okay. Okay, we are quite at the end of the day. How's it going? Okay. I have a very sad news because we ended Serverless Espresso, but we are ready for the last keynote talk. So please bear with me, and I'm glad to introduce James Eastham. He is developer advocate at Datadog, Microsoft MVP, and specialized and top-level international speaker about all the everyday issues that you can have writing and building modern application. And he is here today to tell us about his job and all the techniques that he found out could be useful even to you. So please welcome James on stage. After James' talk, please stay here. We will close the day and we can share with you some upcoming news about next edition and what's coming next.
Cool, thanks Luca. So I actually want to start with a question today. How many of you have ever sat down at work and had a challenge of some kind? You've had a problem, you've sat there and thought, I have absolutely no idea what to do next. Come on, this is a safe space. There we go, every hand, that's what I expected. And when you think about that time where you had a problem, I want you to actually think about where exactly that problem came from. Was it that the thing you were building, the thing you were trying to do was just inherently hard? It was just a problematic domain that you were trying to solve for? Was it the fact that it was a 20-year-old .NET Framework 1 application running on a Windows server underneath someone's desk somewhere? Or was it the fact you chose to run your application on Kubernetes? Right? All these things bring about their own set of problems. And at its core, this is a talk about managing complexity. And by the end of this talk, you're going to walk away with some really clear heuristics about how you can build, ship applications by focusing only on the complexity that matters to your users. I'm James Eastham. I'm a serverless developer advocate at Datadog. I'm a Microsoft MVP. I'm an AWS community builder. And if any of you have seen me talk before or seen any of my content online, you'll know that there's one thing I love talking about almost as much as serverless. That is, of course, pizza. And you won't believe the amount of stress, actually, finding this photo took me delivering this talk in Italy. It took me a lot of time to find this photo. So for the rest of this talk, I need you all to forget your day jobs, forget your Jira backlog, forget the features you've got to build, forget your on-call. Actually, don't forget your on-call. If your pager goes off, please go and deal with that, because you're all now developers for plant-based pizza. It's a startup, and your application today is a monolithic application running on a server in the cloud. And this has worked up until this point, but you've started to hit an inflection point. You've started to hit an inflection point where the number of developers you have all contributing to the code base is starting to cause you problems. You've got developers getting in each other's way, people are getting frustrated, someone's making a feature over here that's breaking another feature over here. People are getting annoyed. No one's getting more annoyed than Helen. Helen's your CTO. One day you get a message on Slack from Helen and you think, this is kind of scary. Why does the CTO want to come to speak to me? But anyway, you jump in, you think this should be interesting. Maybe all this hard work I've been putting in, that promotion that I'm finally going to get, fantastic news. So you jump on a call with Helen. Things start out okay, but then she sets you a task. She says to you, you're going to be in charge of breaking out the first microservice from the monolith. But she gives you some constraints to do that. You're going to be the only person working on this project. You've got no access to any of the developers in the organization, none of the infrastructure teams, none of the support teams. This is all on you to build and ship on your own. And just before she finishes the call, she rather obviously points out that promotion you've been waiting for, actually that completely depends on the success of this project. Okay, not quite as exciting as you first thought, but hey, this could be interesting, this could be cool. So you go off and you have a look at the functionality in the monolith, and you decide that the menu functionality is the piece that you want to break out. You choose that because it's not a tier 0, absolutely critical, can't go offline service, but equally it's not something so irrelevant that if it did break, no one would actually notice. And this is generally a pretty good heuristic for any kind of migration or modernization project, something that sits kind of in the middle somewhere. And this is where you encounter your first problem. And it's a problem of complexity. But what exactly is complexity? It's a word that's bandied around quite a lot. It's used quite a lot of different places. I've used it throughout my career. And actually, I think and maybe some of you have used it incorrectly. If we take the Cambridge English Dictionary definition of complexity, it's something that's difficult to understand or find an answer to because it has many different parts. Now, of course, this could mean a couple of different things. The thing that you're working on could have lots of different features, lots of different functionality. Therefore, it could have lots of different parts. Equally, it could just be a product of bad design. Now, whilst on the subject, I also want to define the word complicated, because over the last few years, I've realized that maybe some of us use these terms interchangeably, but they actually have slightly different definitions. Again, if we go to the Cambridge English Dictionary, complicated is something that involves a lot of different parts in a way that is difficult to understand. Now, two very similar definitions there, and I think there's a really important distinction, and it's a distinction of necessity. Complexity may be necessary because of the nature of the thing that you're building, what will be referred to as essential complexity. Complexity that's inherent to the problem that you're trying to solve, complexity that you can't get rid of. The menu service that you're trying to break out, its essential complexity is it needs to be a consistent double-digit millisecond response time. It's the first page users hit when they hit the website. It needs to be available, it needs to be performant. If you were building a payment service, a payment gateway, that would have a different level of essential complexity. And all of you will have your own kinds of essential complexity that you do deal with day to day. The other type and slightly more nefarious form of complexity, though, is accidental complexity. This is complexity that comes from the decisions that you choose to make about how you build and run your system. This is where you start to stray maybe into complicated. A single server, single process application with a single database, I would argue, has a much lower technical complexity than a set of 2,000 Lambda functions deployed across 10 different AWS accounts. Now, it's important to remember that complexity isn't always related to the technology, because software things we work on are socio-technical systems. The technology is important. The humans building the thing, the humans involved in the software, are also pretty important as well. And your current monolithic system has low technical complexity and also relatively low social complexity whilst you've got a small number of developers. But the problem you're starting to hit, remember, is you've got so many developers all contributing to the code base, people are starting to get in each other's way. And this is really one of the only reasons to start to build microservices. Microservices are there to solve social complexity, to solve these social problems that come when you get a large group of people all trying to work together on the same thing. Because microservices almost always have higher technical complexity. You've got lots of different components, you've got lots more different things to think about, observability, how are you going to do service-to-service communication, resilience, cascading failures, if you build on Kubernetes, cluster management, cluster upgrades, all these things are complexity that you've introduced by how you've chosen to build your system. So where do you even begin to start when you start to think about how you're going to break out this microservice from the monolith in a way that means that you don't really increase that accidental complexity? And this is where, in my opinion, serverless hits the sweet spot. And it's a word that seems to have been co-opted by marketing teams, by product teams, by service teams to mean a whole lot of different things. So I want to try and tackle that first off. But before we get to that, I know it's late in the day, I know you're not really all at school anymore, but I actually want to start with a quiz. When was the first ever serverless service announced? I want you to raise your hand if you think it was a year ago. Yeah, okay, no hands as I expected. What about 5 years ago? First ever serverless service, 5 years ago. Still no hands? Okay, I've got a couple of hands. 10 years ago. A few more. I can see you all doing the maths in your head. You were like, when was that service announced? Okay, 15 years ago? A few more hands. 20 years ago. What about 20 years ago? Okay, decent number of hands there. So for those of you who kept your hand up as long as 20 years, give yourself a medal, because the first ever cloud services ever announced, not the first ever serverless services, the first ever cloud services, SQS and S3, went GA back in 2006. SQS actually went into beta in 2004, but we'll take the GA date as the date the first serverless services were announced. And I've heard Julian Wood say this a few times, the cloud is inherently born serverless. So what does that mean for all of us today? What does this mean in practice? Well, it's simple, really. Serverless is only about reducing this unnecessary complexity, reducing the complexity that your users do not care about. Your users do not care how well you can upgrade a Kubernetes cluster. They care about your software solving the problem that you're being paid to solve. And sticking to that dogmatic belief that serverless has to equal pay-per-use and scale to zero, and we're a serverless first shop, so that means everything we build has to meet that criteria, is where I've seen the most people get into trouble building serverless applications. When actually, serverless isn't a binary decision. Serverless is a spectrum. And what does this spectrum look like? Well, at the far left-hand side, you've got the lowest amount of operational overhead. Services where you can pick them up, you can write your code, you can ship your code, give that to the cloud provider worries about everything else. This is where your kind of typical definition of a serverless service sits. The trade-off you get there, though, is that most of these serverless services are typically really, really opinionated. They force you into a certain way of doing things, so you lose infrastructure flexibility. You lose that control of the underlying infrastructure, which can be a good thing in some cases, can also be a negative in other cases. Now, there's another dimension to this spectrum that's really important to point out, something that Jan touched on in the keynote this morning, and that's the cost dimension. And if you could find a way to directly compare, say, a Lambda function to a comparable EC2 instance, and that's really difficult maths to do because they have fundamentally different pricing models, but if you could do that, imagine you could, the Lambda function would almost always work out more expensive than the EC2 instance. Which kind of makes sense, right? You're paying AWS to be your platform team, to run your infrastructure. Therefore, there's going to be a premium you pay to do that. What most of these calculations forget is the human cost. Whilst your AWS bill might be lower, you're going to need a team of people to run, to manage, to operate that infrastructure. And I would argue in almost all cases, that probably ends up negatively impacting the total cost of a system. So what does this spectrum actually look like in practice? Well, of course, at the far right are the services that you probably think about when you think about the word serverless. Lambda, Azure Functions, Google Cloud Run, Cloudflare Workers, where you write code, you ship code, everything else is the cloud provider's responsibility. But as you start to walk down this spectrum a little bit, as you start to step down, you get to services like Azure Container Apps, Amazon ECS, AWS Fargate, services that whilst they don't meet the true definition of serverless, scale to zero pay-per-use, they allow you to run containers with next to zero operational overhead. You give these services your container image, say I want this much CPU, this much memory, nothing else. The cloud provider handles the rest. Of course, as you walk even further down this spectrum, you start to get to your managed Kubernetes services where the cloud provider takes on the responsibility for managing the control plane. You've still got to worry about everything else related to Kubernetes. I promise I'll stop saying that naughty K word eventually. And then you've got your virtual machines right off at the far right of this spectrum. So really, when you're thinking about being serverless, why you should think serverless first, really, it's about reducing that unnecessary complexity as much as possible. Notice I don't say completely removing, just as much as possible. There's no right or wrong place to sit on this spectrum. That will completely depend on the thing that you are doing in your workload. If you're running a workload that needs some really specific GPU instances and needs to dynamically scale them up and down based on traffic, well, of course, you're probably not going to use Lambda for that. You might use Google Cloud Run, if you saw Paul's talk earlier. Which always leads to the question, whereabouts on this spectrum should you sit? And for almost all of you, sitting as far left as possible, sorry, no, it is your right, isn't it? Yeah, far right as possible, then is a good thing. Most of you don't need that underlying infrastructure control. Most of the workloads, most of you will be building will benefit from sitting as far right as possible. So this is what you do with your menu service. You go off and you start building, and you build what is the typical serverless API. Regardless of what cloud provider you're using, if you're using serverless functions, it'll be something like this. You'll have some kind of endpoint, some kind of URL, you'll have a separate function per route on your API, and some kind of persistence layer underneath, the kind of typical serverless API. Whatever programming language you write this in, it'll look, again, broadly the same. You'll have a function, it'll be a method, whatever it is in your chosen programming language, and you'll have a separate one per endpoint. So you do this, you go off, you build your menu service, you ship it to production, and you think, great, fantastic, we are done, promotion is in the bag. Fantastic. Because we've used serverless, nothing to worry about, everyone's happy. Helen comes back. She's honestly not as happy as she looks in this photograph. She's actually pretty mad. She's pretty mad because your users are getting frustrated. Your users are starting to see some slower performance in the UI. And only really when there's spiky workloads. If there's a sudden spike in traffic, let's say the marketing team runs an offer, people start to see really slow response times intermittently. You think that's interesting, but thankfully you're all excellent developers, so you added telemetry to your serverless application. You go off to your observability backend and you have a look at your traces, and you have a look at the last few traces that have come in, and you think, these look kind of okay. Like most of them are double-digit millisecond response times, some as low as 10 milliseconds. What are the users complaining about? So you sort your traces by duration, and then things start to look a little bit more problematic. You've got response times up in the half a second range. And remember, one of the requirements, one of the essential pieces of complexity for this service is consistent double-digit millisecond response time, regardless of the traffic pattern. So you zoom in and you have a look at this slowest trace. And actually, you realize that 521 milliseconds doesn't paint the whole picture. That's just the response time of part of the invoke. The total response time, including the time in transit inside things like API Gateway, is actually up over a second. So you've got these two spans then. Inside that second of response time from API Gateway, you've got this thing that took 521 milliseconds, and then this thing that took 91 milliseconds at the far right, for those of you that can't see. And as you investigate this further, you realize that this is, of course, a Lambda cold start. And you realize this may be what is starting to cause these intermittent problems for your users. Now, I do think cold starts get a little bit of a bad rap when it comes to serverless, actually. Partly because as a developer, when you're developing something new, you are guaranteed to see a cold start every time you deploy a new version of your function. And if you're running a real workload in production, there's preventative measures that AWS have built to prevent that. But for you as a developer building a new thing, you're going to see a lot of cold starts. So the number one piece of advice I always give to people starting with Lambda is run something like real-world load through your system. If you think you're going to get 10 requests a second, write a little load test using something like Artillery. There's really good load testing frameworks out there. Hit your endpoints with that 10 requests a second, and then go and look at your cold starts. And what you'll typically find is that it impacts less than 1% of requests. It's a really small proportion of requests that actually are impacted by cold starts. The other thing I always like to point out, let's imagine you chose to run this application on EC2 instead of Lambda. And you've got this team of people that you're paying to do that. I would almost always guarantee that the cold start of a new EC2 instance, if you needed to scale up your application, is probably going to be a lot longer than 500 milliseconds. So cold starts get a little bit of a bad rap. But there's another problem potentially with serverless. As you start to talk to other developers about what you're doing, you have conversations around the coffee machine, and they start to get confused. They're thinking, why have you now spread your application across 4 different individual pieces of compute? And you start to think about, well, as you start to scale this up, don't you end up with hundreds and hundreds of individual Lambda functions all doing separate things, maybe even across separate AWS accounts? And if we think back to that definition of complicated, it's involving lots of different parts in a way that is difficult to understand. Now, there's a really, really fine line here between necessary complexity. I don't know anything about this architecture diagram, but it could be that there is necessary complexity that's meant it's beneficial to break things out. But it's a fine line because it's really, really easy to end up in this situation where you've got hundreds and hundreds of Lambda functions doing lots of different things, and it becomes unnecessarily complicated. So now you're at an inflection point. You've got a decision to make now. Is this complexity that you want to deal with? Do you want to spend hours and hours trying to force fit your application to run on Lambda? Do you want to play around with concurrency settings? Maybe you use a cool new JavaScript framework to try and improve the performance. Maybe you rewrite the whole thing in Rust. Maybe you use provision concurrency. There's all these different things that I've seen people try and force fit their application into this programming model that Lambda imposes upon you. Or do you be a really pragmatic and sensible developer and choose another path? And you come back to this serverless spectrum. You come back to this spectrum of choices that you've got for how to run your application. And maybe you think, well, maybe it is time to explore containerization. Maybe we decide to look at Azure Container Apps, Amazon ECS, AWS Fargate, services that allow you to run containers in a really operationally light way. And for those of you that aren't familiar, Amazon ECS is simply a container orchestrator, much like Kubernetes is a container orchestrator. Fargate gives you the compute behind the container orchestrator. So you can use EC2 inside ECS. You can also use Fargate. The benefit of Fargate is that you say, I want this much CPU, this much memory. AWS handles the rest. The same way, the same things that you love about Lambda in terms of all the things that AWS take on for you. You're starting to hit another problem here, though, and it's a problem of one of the only constant laws that exist in software, and that is change. One of the only things that is inevitable in software. Just a quick show of hands, who's ever built a system that has never had to change? No, of course. Oh, I always get one hand. I want to speak to you afterwards. I always said that we'd all be out of a job in that case, but obviously not. There's one person, so come and speak to me afterwards. I'm intrigued. Change is something we have to deal with, isn't it? Changing business requirements, changing features, changing user profiles, changing user volumes, changing focus from the business, even a changing government somewhere else in the world that massively impacts the economy. Change is absolutely inevitable, almost absolutely inevitable. So what do you do now? Because previously, you were running your code inside a serverless function, and you were using that programming model that Lambda imposes upon you, where you've got a function and a method or a function inside your code. And now you want to run some kind of web framework, ASP.NET, Express, Quarkus, whatever the web framework is in your programming language of choice. And obviously, people are always shouting and screaming about vendor lock-in, and if you choose to use serverless services, you're locked into that cloud provider forever, and you can never leave. So you go off and you have a look at the code for your Lambda function that you've written today. This is the code for creating a new menu item. And you zoom in and you have a walk through the code. Now, don't worry about the fact this is .NET. It's largely irrelevant what the programming language is. But the first thing you do in your function code is you import the AWS SDK, and you do that outside of the function handler because you're a good serverless developer following good practices. You then go off and deserialize the request that comes in from API Gateway. So you take the body of the request and you start to parse that out in some way. You then go off and you make a call to DynamoDB. You run a whole bunch of custom business logic that's related to the actual business domain, to the actual problem you're solving. You then make another call to DynamoDB before building the response that you send back to API Gateway. And if you've written functions like this, I know I have, you should be thinking to yourself right now that you've made a huge mistake. You've made a huge mistake there because the compute, the business logic, the storage, the messaging, the third-party dependencies, everything related to your application is tied up in this single code file, this single big long block of code. What you're seeing here is a complete lack of flexibility. And with the pace things are moving at today, the speed that software is innovating, I think this is becoming one of the most important architectural illities. Call it flexibility, call it evolvability, call it whatever you want. The ability to deal with change is absolutely vital as we move forward building software. And this was actually codified all the way back in the 60s by someone who had no relation to software, a guy called Ross Ashby. He was a cyberneticist and a psychologist. And Ashby's law of requisite variety states that when the variety or complexity of the environment exceeds the capacity of a system, the environment will ultimately destroy the system. What this means is that if your system can't deal with the changing environment around it, the environment will always win. The environment will always beat the system. I've also recently read this book. Is anyone familiar with Barry O'Reilly and Barry O'Reilly's work? Okay, few couple of hands. If you aren't, get your phone out, go and follow him on LinkedIn right now, because the stuff he's talking about in terms of architecture, software architecture, how to do architecture is fantastic. It's really, really good. And this book is fantastic. And one of my takeaways from this book is that software engineering, as we know it, operates in a really interesting place, because when you compare software engineering to the more traditional forms of engineering, let's imagine you were going to go and engineer a building. The constraints and the environment around the building that you're engineering doesn't change all that often, right? At least in my lifetime, the laws of physics haven't really changed. Gravity's pretty constant at this point. So you've got this fixed environment around the thing that you're building. But when it comes to engineering software, it's this really interesting place where you've got the software itself that's incredibly deterministic. The reason we write software is because it's really good at doing the same thing over and over and over and over again. But the environment that this software operates inside, the business environment, the world we live in, is anything but static, is anything but deterministic. It's constantly, almost constantly changing. So this is obviously quite theoretical. What does this actually mean in practice when you're actually designing this menu service that you're building? Well, down at the application level, at the code level, adopting patterns like ports and adapters, like hexagonal architecture, patterns that fundamentally separate the application concerns of your business from the infrastructure concerns. And at the core of all these different patterns, and they've had a lot of different names over the years, at the core of them is the center of the application is the business logic. This is the code that solves the problem that you're building the software to solve, the problem that your users care about. This code in the middle should have no external dependencies. It shouldn't know anything about Lambda, about DynamoDB. This is pure business logic that can run anywhere. Your business logic then defines ports, primary ports and secondary ports. Primary ports allow external things to call into your business logic. Secondary ports allow your business logic to call out to other things, interfaces. You then define what's called adapters. There's two types of adapters. There's driving adapters. These are adapters that can call into your business logic. Your Lambda function handler is a driving adapter. It is something that is just there to adapt an inbound payload and call into your business logic. And then, of course, at the other side, you've got driven adapters. This is your actual implementations of the things that your application needs to communicate with. External APIs, external cloud services, things like that. Now, you might think this is an awful lot of ceremony to start thinking about when you just want to build applications and ship features. But where this gets really powerful is if we apply the services we've used so far on top of this diagram, and you've got a Lambda adapter up at the top, all your Lambda function handler should ever do is adapt the inbound event payload into something that your application understands. That's it. And then build the response on the way back out if it needs to, if you're using something like API Gateway. So what this looks like in practice, looking at that same application code from earlier, is we're still receiving the payload from API Gateway. We have to do that. That's a constraint that Lambda imposes upon us. You get this JSON blob from Lambda depending on what the service is that you've hooked up for it. We're then deserializing the body. That's still the same. And we're deserializing the body into this create recipe command. And then all we're doing is calling this create recipe command handler. This is that primary port. This is the thing our business logic has defined to allow external things to call in to the business logic. If we have a look at this handle method, again, I realize it's .NET, but this is just pure business logic, right? There's no reference of DynamoDB, of external services. This code could run absolutely anywhere. There's no external dependencies in here. And you'll notice right up at the top, there's a couple of interfaces defined. They're them secondary ports that will then implement to call out to other services. And then if we zoom back out here, we're building that response to pass back to API Gateway. Remember, all our Lambda function handler is doing is adapting that inbound event payload into our business logic, calling into the business logic and building a response. That's it. What this means then, if we're back in that situation that we found ourselves in, where we've got our application running on Lambda, we think containers might be a better fit, but we're not sure we want to try it out. Instead of having to pick apart that 100, 150 line Lambda handler, all we do is switch that adapter in the top left corner. We switch it from a Lambda adapter to use some kind of web framework. In this case, it's a .NET app, so it's ASP.NET. That could be Express, it could be Spring Boot, it could be any kind of web framework. And when we look at this code implemented in ASP.NET as a web framework, you'll notice that the core of these two handlers is exactly the same. Regardless if it's running on Lambda or it's running in a web framework, all we're doing is making that exact same call into our exact same line of business logic. We're calling in to that internal code. And you'll notice the Lambda one actually has a lot more lines of code, and that's simply because we need to manually deal with the HTTP request that comes in. We need to manually parse the requests. Most web frameworks do that on your behalf, which is why the lines of code are shorter. Now, this is a really interesting place to be, particularly if any of you have ever worked in an organization where you've been the one advocating for serverless, and you've had the common pushback of, well, we can't use serverless because then we're locked into AWS forever. When actually, if you use good code design like this, you structure your code in the right way, you start to negate the risk of this vendor lock-in, at least from a compute perspective. Well-structured code bases really reduce the risk of your compute locking you into a cloud provider. And ironically, most of the conversation about vendor lock-in is focused on things like Lambda on Azure Functions, when actually data is what's going to lock you into a cloud provider, not the compute you choose to use. So when I worked at AWS before I was at Datadog, and I was consulting with one of the biggest energy companies on the planet, and we were helping them migrate their applications from Azure to AWS. AWS had just won a tender to run all their workloads. And this energy company was super excited because they were like, we've built everything on Kubernetes, everything's containerized, this is going to be the easiest migration in the history of the world. We'll just pick it up and we'll just drop it into AWS, easy. And we started to do some analysis on their applications, and they were right. All their applications were containerized, they were stateless, like this kind of okay. I think it was about 65% of their workloads used Azure Cosmos DB. Now, I don't know if any of you are familiar with Azure, but you can't run Azure Cosmos DB on AWS, unfortunately. So it turned this, what they thought was a really simple migration because they'd used Kubernetes, to actually this really painful thing because we had to map these data models across. So it's almost never compute that causes the problem. So structuring your code base in the right way will negate the risks of you ever being locked in. So you take your application, you pick it up, and you run it on ECS now. It's containerized, your users are happy, you think Helen's going to be happy. She's happier, she's still not this happy though. She's still a little bit mad. She's a little bit mad because there was a feature in the front end that was the most ordered pizzas view, where users could come along and they could see what pizzas were being ordered the most. And because you've now broken out this piece of functionality from the monolith, well, this code no longer works because you've got the monolith publishing these order completed events, and you've got your microservice running over here, but there's no real integration in the middle. There's no way to connect these two things together. And you think, well, we're a container shop now. We build with containers. We do everything in containers. So let's build this handler in a container. And most programming languages give you the ability to start up some kind of background task and run something on some kind of loop in the background. And whatever programming language you're using, you'll do a similar set of steps. You'll communicate with your messaging middleware. In this case, it's SQS. You'll receive your messages from your messaging middleware. You'll iterate over the messages. You're still practicing good code design here, so you're using ports and adapters, you're calling into your business logic, and then you'll do something to acknowledge or not acknowledge the message afterwards. In SQS's case, that means calling delete message on the SQS API. But remember, you're pragmatic developers. So you come back to your serverless spectrum again, and you think, well, we've got this container that's running now. And we're a container shop, so we're using containers, but this container is now actually running 24 hours a day, 7 days a week, 365 days of the year, even if there's nothing sat on that SQS queue waiting to be processed. So maybe this is the right time to step back up the spectrum, step back to services where reactivity is their superpower. The core value proposition of all serverless functions is their ability to react to things that are happening, to scale up when there's work to do and scale down when there's no work to be done. In my opinion, that makes it a perfect fit for asynchronous workloads, event handlers in event-driven architectures, things processing messages off queues. And because you're practicing that good software design, you're structuring your code in the right way, actually that migration from a message handler running in a container to a message handler running on Lambda is almost as seamless as moving the web framework around. And if we compare these two things side by side again, somewhere in the middle there, you've got that exact same line of code, calling into that core business logic. All the code around that is doing, all that boilerplate is mapping the message payload into that custom business logic. Now, I'm not saying that lines of code is a good metric for complexity of software, but you'll notice in both cases, when we use the web framework for the HTTP workload, there was a lot less lines of code. It's a bit simpler to understand and rationalize. And the same again here, because the Lambda service manages all that communication with your messaging middleware. So all your Lambda handler needs to do is deal with that inbound payload, adapt that, and call in to your business logic. And I think this is actually a really powerful pattern when it comes to building modern applications that really focuses on the right kind of complexity. If you ask yourself the question, if you're building a web API, what is the simplest way to build and run a low latency web application? Is it to split that application across n number of different Lambda functions and apply some really specific optimizations to make that work in the right way? Or is it to simply just containerize it and run it in a long-running container? And equally, if you're building applications that are reacting to messages on queues, is the simplest way to do that to run that application in a container and define some weird scaling rules to dynamically scale that up and down? Or is it to use a service where reactivity is its superpower, is the core value proposition of the service? And the most important thing, what is the simplest way to solve the problem that your users have? And this is why Helen is now actually happy, finally. Because the user experience is consistent. Your users have got this really low latency response time that they're familiar with. All the functionality works, and you've managed to do that with very little operational overhead because you've chosen to use serverless services. This new application, this new microservice can be run by a very small team of people, which also has the add-on benefit of massively reducing that social complexity as well. You've not got lots of different people and lots of different teams that all need to collaborate to get work done. So of course, I realize that you're not all actually developers for a pizza restaurant. I've always thought that'd be kind of wonderful in my head and that you'd get free pizza every day. Like that's kind of the mental model I've got for working at a pizza restaurant. So what are the actual takeaways for you to take back to your jobs when you go back tomorrow or next week or whenever it is you're back at work? The first one is to focus on the right complexity. Focus on the complexity that your users care about. That isn't how well you can upgrade a Kubernetes cluster. That isn't how complicated can you make your application so that you can stand on stage and talk about it. It is relentlessly focusing on the things that your users care about and doing that in the simplest way possible. Secondly, design for flexibility. Keep flexibility as a first-class citizen in your architecture. Whether that's down at the code level, using patterns like hexagonal architecture or ports and adapters, and if we raise that up to an architectural level, things like event-driven architecture that enable you to build more evolutionary systems. Now, of course, event-driven architecture brings about its own set of challenges, but that is a way to keep your applications evolvable and flexible. And finally, and importantly, choose the right tool for the job. I appreciate this is serverless days, and a lot of you are working in companies that are serverless first, but don't let that dogmatic belief that serverless equals scale to zero and pay per use, therefore everything we build has to use them services. Pick the tool that solves the problem your users have in the simplest possible way for you as a developer or an operator or a support team. So finally, thank you all very much for listening. I always really appreciate it when people come and listen to me speak. I still find it a little bit mad, so I appreciate you all very, very much. There's some links there to the slides in the bottom corner and any resources, anything I've called out in the talk, like the book, that's all on my website there. My socials are over on this side somewhere. Feel free to reach out. I'll be around for a little bit after I'm done, so if you've got any questions, please feel free to come and ask me. And again, thank you to the organizers for wherever you all are for putting on such an awesome conference and also for inviting me to speak. So I appreciate all of you. Thank you. Ragazzi, sforza. Okay. So, just, can you give me the exit, okay?
So let's start with closing remarks. So it has been a very long day, and we are pretty tired. I think that you are tired as well, but we have a few final information to share. I want every one of the organizers on stage just to present them to you, and then I'm going to tell you the content of the slides, because we are very big people in our team. So the final leaderboard, we have clear winners. The first prize was a GenAI course by Aleva. The second prize was a case of beer from B Sharp, and the third prize was a free ticket to an overnight conference. And then we have these three winners. Saverio Menin win the first prize. Enrico La Sala, number 2, and Matteo Momo, number 3. Please, going out later, please step by the stands, the booths, in order to retrieve your prizes. Then, let me move forward, because it's time to say thank you. It's time to say thank you to our sponsors who made this possible. Please, an applause to the sponsors. Thank you for supporting us. Thank you for your continuous and precious support. Then it's time to say thank you to the people who delivered great talks today. You took a plane, you arrived here, you spent all day with us to share, to connect, and to stay all together as a community. So thank you to our speakers. Then I want to say thank you to all the people, and you can see almost of them on the stage, that made this happen. Without every one of us, without every one of them, this day wouldn't happen. So say thank you very much from my personal heart and from all the audience to all of you. Thank you. And finally, let me share some vanity metrics just to say how good we are and how great was this day. This is the map about all the attendees that we had. We have the attendees from all the country. 187 tickets sold. 151 checked-in people, which is less than 20% drop rate. Consider that for a conference of this kind, the drop rate, the standard drop rate is between 25 and 30%. So it went great. Please give an applause. But more important than that, 8 hours of live streaming on our YouTube and LinkedIn channels. 200 sandwiches delivered. And more than 25 kilograms of pasta cooked for all the attendance today. So it has been a huge event. And thank you very much. And see you at ServerlessDays Milano 2026. Have a safe way home.
Welcome, sir.